Yo, how's everybody doing today? It's Friday? Today is Friday. Nice. In California. The Mr. Space Strimmer Man here. I'm doing all right, Hey, dude, we lucked out that Starlink mission got postponed. And my voice is back. That's good. Starting to go yesterday. That was not cool. Today is International Popcorn Day. To that. Oh, yeah. This was linked yesterday. Creeper linked this up. Yeah, here, check this out. We'll jump right into some space news, I think. Here, ready? Here, look. Look at it. Look at this. I don't know about the music, but oh. Yes. You're running a train and railroader at the moment. Nice, nice. Oh, hello. Very nice. Very nice. You know what the best part about this exhibit is? It's inside. It's going to be inside. They're going to build the building around the stack, which is ace. I mean, the shuttle stack can sit outside for a good bit of time. It can. I wouldn't leave it out there for too long, but it can stay out there. That's going to be stoinks. Yeah, man. Awesome. That's really cool. I really wish they could get that stupid POV stuff off. I just want to see the picture. I'm actually like super curious how they're gonna get the shuttle into that thing. You need 2 cranes to rotate it, guys. That's a real important thing. You need 2 cranes to rotate it. We were checking that out yesterday. We're figuring out how that all works. You need 2 cranes to do it. I would be interested in seeing those hoisting operations. How they're going to mimic the VAB. But, yeah, either way. So, in other news, Japan went to land the Slim lander on the moon, and it seems like they're good, but, you know, I've been kind of keeping track of it because I had some other stuff to do in the morning. This was just like 2 hours ago. It's the Lev 1 rover, and it looks like it made some kind of soft landing, but I think you know, to echo some other like spaceflight pundits, I guess, words. Scott Manley said it tipped over. I think he's right. I think it tipped. The Slim press conference is coming up, so yeah, exactly. We'll figure it out here very soon. It may have tipped over, which, I mean, hey, if you turn the antennas, it might be a thing. You know, it might still be good. So here, I will get that up. Press conference will start in 3 minutes. So let's jump right into that. Dead Crew, 40-month resub. Thank you. Whatever happened to the one Indian rover? Not heard anything about it for a while. It crashed, I'm pretty sure. It is designed to tip over. Oh. Okay. Hey, if they still have signal, hey, I'd say it counts. I'd say it counts, man. I'd say it counts, dude. I'd have to go look at the telemetry, like a telemetry replay, but we'll see what's going on.
Discovery, go at throttle up.
Thank you for waiting. My name is Kishi from the PR media of JAXA. We will be starting
you got your worm.
This conference soon, so if I could ask you to be prepared.
60 months, man. Thank you. Thank you for all the support, guys. Really appreciate it. Ohayo gozaimasu, Slim-sama. Yeah, it's 2:10 in the morning. Yeah, 2:10 a.m. over there. Another big update on Stationeers a couple of days ago. I saw it, Corsi. Yeah. This is what should have happened, apparently. Yeah, believe it or not, dudes, I don't know too much about this mission. Well,
And we have another person appearing on the stage. So the person is heading towards the podium. So if you could just bear with us for a few more seconds, please.
okay. Well, in the meantime, here, let's see real quick. So this is what it was supposed to do, huh? How good are JAXA in comparison of other space programs? I mean, landing on the moon is a pretty big deal. Actually, you know, we were talking about the Indian... what the heck? Oh. You're gonna... Huh. Yeah, okay. I see it. Yeah, you got the soft landing skids on one side, and the solar panels are on the other. Dude. Dude. Cool. That's pretty neat. Here, I'm gonna leave that up there. So it was supposed to roll. Okay, alright. Because, yeah, I looked at the telemetry that Scott was posting. I'm like, those rates look like it's rolling. But I guess it's supposed to do that. So... it's not... I mean, I wouldn't necessarily call that litho-braking. That's just soft landing. Yeah, it falls on its face. It does a belly flop at the last minute. It's like, T-pose to assert dominance. You know? It's like when you do the freaking belly flop. I don't know about you guys. That's my thing to do. If I'm at a pool with friends, I get up on the diving board. I T-pose to assert dominance and then belly flop into the water. You know, to prove, you know, it's not about being funny. It's about sending a message. Right? That must hurt. Yep. Did ET hang test, and I don't think it's possible unless two SRBs are the same vessel.
Thank you everyone for waiting, and apologize for making you wait.
1 minute late, apologizes.
Starting time, but if you could just give us a little more while we prepare the press conference. Thank you.
Yeah, Make, exactly. How many G's is that? Well, 1/6. It's 1/6 of a G. Because gravity. So, RJ, you did ET hang tests, and I don't think it's possible unless the two SRBs are the same vessel. Oh, yeah? We'll see. You smelly butthole. And after it landed, the IMU was reading lunar gravity, so that's a good sign. Can we back this up a little bit? Can we go back a little ways? Damn it. Can't go back all the way. Oh. Japan's the only country that apologizes more than Canada. Dude, John, a Japanese apology and a Canadian apology is two different things, okay? Canadians will, like, not hold the door for you. And oh, sorry, bud, I didn't see you there. I didn't see you there, bud. Oh, that's my bad. Oh, wait, press conference is on. Japan will apologize if they don't.
Thank you very much for waiting.
I'm so sorry, I did not get the door for you. It's different. It's a different apology, okay?
We will start
Discovery,
the
go at throttle up.
the press briefing session regarding a lunar landing of SLIM, a smart lander for investigating Moon. Thank you very much for many of you
Moto.
for participating despite being late into the night.
Hey, Stream.
And we apologize for the fact that we have kept you waiting for quite a long time. For those participating through WebEx, and for those people also watching
drummer.
through the JAXA official site on the YouTube JAXA channel. I apologize to have kept you waiting for quite a long time. My name is Kaori Sasaki, the General Manager of PR from JAXA, and I will be the MC today. The press briefing today is held in a hybrid format, live from communication halls of Space Science and Exploration at Sagamihara campus, JAXA. And we're also streaming this live on the JAXA official YouTube channel, JAXA channel. So I'd like to introduce the attendees. From the right, Dr. Hiroshi Yamakawa, President of JAXA. And in the middle, Dr. Hitoshi Kuninaka, Director General of ISIS JAXA. And next to him, Dr. Masaki Fujimoto, Deputy Director of ISIS JAXA. And I think we are handing out the press release as of 10 minutes past 2. And so I'd like to ask the President to start with a statement. My name is Yamakawa, Director of the President of JAXA. Thank you very much for any of you for participating today. I'd like to start by saying a few things, and details will be explained by Mr. Kuninaka. And on the 20th of January 2024, at 10:20 JST, a smart lander for investigating Moon landed on the Moon. We have been able to confirm that it has arrived on the Moon surface. My name is Kuninaka, the Director General of ISIS. As was explained, smart lander for investigating Moon, SLIM, we made a challenge to landing on the Moon. Now, the SLIM has been communicating to the Earth station, and it is receiving command from the Earth accurately, and the spacecraft is responding to these in a normal way.
Nice.
However, it seems that the solar cell is not generating electricity at this point in time. And since we are not able to generate electricity, and so the operation is being done using batteries on load. And based on the data, and landing has been stored on this spacecraft. And so we are trying to data source that to the Earth. And we are making effort to maximize the scientific the achievement. And during the descent to the Moon, and while hovering above the Moon surface, we have been able to separate Lev 1. And Lev 1, once separated, will automatically send the signal, and that has been successful. So we do consider Lev 1 and Lev 2 have been successfully separated. And we are making an effort to acquire data at this point in time. And in order for us to analyze the data, we will require some time. That has been the case scheduled from the start. And so in regards to sharing of the data, we will require a little more time. And so what we know at this point in time is, as I have explained, and so we are still gathering data to understand the situation of this spacecraft. Also, SLIM has targeted the high precision landing with an accuracy of 100 meters. Well, we require to do a detailed analysis of data as we have indicated in advance. And so as to whether we have been able to achieve 100-meter accuracy or not, we would require a little more time for us to be able to confirm on this point. And also, so we will gather the data we have been able to gather, and we are hoping of holding a press conference next week. As for the precise date, we will inform you next week. And so that is what we know at this point in time.
Sounds like it.
Thank you very
Sounds
much.
like it
Any
flipped
further
over more
comment
than what it
from
needed
Dr.
to.
Fujimoto?
Thank
Thank you very much. The materials.
I have to look at the replay. I'll be able to tell you guys what it's doing if the telemetry that they received was correct. But it turns out that they did get a soft landing. The solar panels are not in the upright position, so that tells me it induced a little too much pitch rate and flipped over. Either that could be on a hill. It could be on a hill. It could be sliding down a hill if the IMUs show that data. It could have kicked up too much dust, and that lunar regolith could have fallen on the solar panels. That probably is a little bit on the more unlikely side. It could have sunk. There are some parts of the lunar regolith, particularly in the lunar highlands, where the regolith is like baby powder, but it's like 2 or 3 feet deep. If it sank too much into the ground, the dust could be covering the solar panels. It's like some of the lunar regolith in certain areas is like quicksand. That's the precise reason why most of the Apollo missions, in fact, all the Apollo missions landed in the lunar basaltic regions, because they knew the regolith wasn't going to be, they weren't going to kick up a lot of dust, or as much as you possibly could.
Please
Okay.
wait for the microphone. Ito of Sankei Shimbun News.
All right, I want to see that footage. Drummer, you linked up the stream that goes back even further. So let's jump over here. Hide the chat. Let's go back. I'm gonna go back and take a look. This is a replay, fellas. I'm gonna initiate a replay here. Initiate a replay. All right. Let's take a look. I'll bring up the. This over here. All right, let's take a look. So
boost. So now you can see the engine firing.
would you say the track deviation is normal? It depends on what their constraints are for normal. All right, let me just familiarize myself here with what's going on. Okay, your IMU is down there, so that's your rate. But that's just a rate. It's not broken down by axis. That's just the rate. It could be that means it's moving at 2.25 meters a second per second, or it's accelerating at 2.25, which seems about right. But that doesn't necessarily correlate to direction. It could be moving up, it could be decelerating, it could be accelerating, it could be a bunch of different things. This looks like your throttle. That's the throttle on the vernier engines. And you have no throttle over here. That is a z-axis rate, degrees a second, 0.19 degrees a second. That's a roll pitch yaw roll rate. I'm not sure which one. There's the, yeah, no, that's roll. That's yaw, that's pitch. Okay, sweet, we got rates here. Fuel oxidizer, total mass, battery power. And then here's altitude versus downrange telemetry. Yeah, this is roll, that's yaw, that's pitch. Got it. All right, cool, let's see what we got. So you're seeing the fuel and oxidizer go down.
Now you can see the planned trajectory and the red
All right,
pressure.
let's go forward a little bit.
Oh,
Let's get down to the landing.
now you can see the engine has stopped like 0%.
All right, so it seemed to have some kind of induced roll here. Fuel levels look... Yeah, that's all right. Hey, Rizzy, happy snow day. Yeah, that was delayed. It's all good. They do 2 hovers, scan the area, and burn fuel. Okay. Okay. All right, let's see what we got here.
It's looking for the safe place to land.
IMU is reading point. Oh, no, 2. Oh, there we go. Deceleration. Or acceleration.
Around the 2 meters, it will release.
I paused for a second. It's hard to tell what the altimeter is here. If we had an altimeter readout in... If we had an altimeter readout it like as a number, not as a graph, it'd be easier to see what's going on.
The left, and it will land. 2-step landing is expected. Now you see on the left hand side MLM. That means it has landed. From the telemetry, it shows the sign MLM. M, that means it has, and it will land. 2-step landing is expected. Now you see on the left hand side MLM. That means it has landed. From the telemetry.
Okay, so you got no rates here. There's no rates. IMU is reading 1.625. That's lunar gravity for the most part. If the IMU is reading, so that's an inertial measuring unit. If it's reading the gravity with 0 rate, that means you're on the ground. So like an IMU with a rocket that's stationary on Earth is going to read 9.81, right? Meters a second per second, because that's Earth's gravity. That's the gravitational acceleration. There's some fuel left over, 0 rates, 0 throttle. Batteries at 77%, 43.7 kilograms total fuel. They got about 100 pounds, give or take, of fuel left. Actually, it's more like 90. There's a 5 meters a second on the B at the time it's rolling. I see the induced roll, Tessa. Thank you. I'm trying to just talk it out so people here can understand what all this stuff means.
Around the 2 meters.
I just need to see it again.
Release the left, and it will land. 2-step landing is expected.
All right, pause here for a second. So, induced pitch. Right there. See this? See that right there? You have your thrusters, all these thrusters out here with the 2 main landing engines. These are the thruster, this is thruster throttle. Look at this. So, but your yaw thrusters and your roll thrusters here. So particularly this one, this one, this one, and this one. So if you have 3 firing on one side and 1 firing on the other side, like this, it's going to induce a rate on the vehicle. Now keep in mind, all these thrusters are downward facing. So it would be 3 over here and 1 over here and 3 over here like this. So it's going to turn it. We have an induced roll. We have induced roll here. We have pitch, right? And then we have yaw as well. Now, the rover, from what I can tell, right, from their animation, is supposed to have an induced pitch right here. They have an induced pitch by firing the thrusters, but it looks like they're modulating their control thrusters here with 3 firing here. Now, this looks like a telemetry driven animation here, if I'm looking at this right. Okay. Today is Friday in California. Shoot! Alright, so let's go back over here. So, we get this frame, right? And then you get nothing. This could be a minor blackout in telemetry here.
Is expected.
Okay. Yeah, it induced, see this right here? So you have 0 throttle, no landing engine, right? Nothing. But we have rates. See? 27.47 degrees a second radian right there on your roll rate. And then you have up to 10 degrees a second on pitch and 15.29 on roll. It flipped over. But it looks like it didn't flip over all the way. It looks like it was coming down, right? And if that's the proper position that it needs to be in, it looks like it went like this and kind of, it didn't flip all the way over. It looks like it dug in on the nose, right? And kind of moved to the side a little bit. There was a little bit of a signal interruption there. It's hard to say exactly what it did, but looking at these rates, right? It dug in right there.
Now you
and
see
it settled.
on the left-hand side, MLM. That means
so we see a very high positive pitch rate, meaning it's doing this, and then we saw negative pitch rate. So that means it rotated in, right, and kind of bounced off the ground and dug in because it stays positive, then goes negative for a second. So that's it settling on the dirt, on the lunar regolith. I think the thing took a nosedive, from what I can tell. It looks like you had a little bit of over rotation, and their thruster modulation wasn't exactly right. Either that, or their thruster modulation was perfect and it landed on a hill. Could have landed, if it landed on a slope, it would have caused over rotation too. It's hard to say. I'd have to have a more complete picture of the telemetry. Or it hit a rock. Yeah, could be anything. Yeah, there's a bunch of. Yeah, it over rotated on 2 axes. So the thing turned like that, right? And then it looks like it nosed up and then kind of settled to one side. It was meant to land on a slope. They showed an animation earlier, and the graph shows that too. If it was meant to land on a slope, why did it flip over? It's an honest question. Clearly it landed on a slope that was too steep. Where's the y-intercept? So the solar panels are facing in the wrong direction. So clearly there's I mean, it could be two things, right? I'm not saying it landed on too steep of a slope. It could be. That could be a thing. Or they didn't get their landing software exactly correct. I am seeing some perturbing forces here right before it comes into
They
land.
can't hover to land.
So we see compensation here with the thrusters to basically negate out all your rates.
Around the 2 meters, it will release the lev and it will land. 2-step landing is expected.
The tick rate on this telemetry is not enough to be able to figure out what's wrong. You could see what it's doing, but it would need to be in more real time for me to figure this out. It definitely did sink into the dirt a little bit. It flipped over. It over-rotated.
Now
the solar
you
panels
see
are
on the
facing
left-hand
into the
side,
ground.
M,
Not
L,
completely,
M.
but look.
That means
You can see in
it
the
has landed.
telemetry-driven animation, right there, you can see it's settling. See it settling around? The rates correlated, kind of settling in the dirt. See what I'm talking about? There's a huge induced roll on this thing. Look at that. You have a 90-degree roll there. 15.26 degrees a second roll rate induced. I'm pretty sure that's not supposed to happen. So, I mean, Drummer, if it was supposed to land on a slope, I mean, I'd say we could successfully rule this out. This looks like a guidance problem. Or it hit a rock. Or, it was coming down and it landed on a rock and flipped over. It could be either one. Yeah. But you can... Actually, the rates are correlating that animation right there. Or they're corroborating that animation, right? So there's the flip. That was the flip. But for some reason at this point, you have 27.47 degrees a second radian induced roll rate. Not good. That means it's doing this. Now, I'm not sure if it was supposed to turn 90 degrees like that, but that 27.42 degrees a second radian stays like that until the next tick. Then it's 15. And then it's positive 5 it's positive 5, so it went like this, and then it went back. I don't think they was supposed to roll 415. I really don't. If the solar panels aren't charging the vehicle pyro, then yeah, it'll eventually run out of power.
See on the left-hand side, MLM. That means it has landed. From the telemetry, it shows the sign MLM. Now you see on the left hand side, it will
I need to see this again.
release the lev and it will land. 2-step landing is expected.
Yep. This thruster information seems to be aligned with the rates. I'm not sure why we had... Yeah, why was there roll there? That's very weird. I mean, the animation doesn't show it, do it. Guys, it may have hit a rock. It's possible. It may have hit something on the surface or the dirt.
On the left-hand side,
Or it sunk too far into the dirt.
that means it has landed.
Or, I mean, it could be a thruster or guidance malfunction. I don't know if that if that roll was induced, then if it meant to do that, then yeah, you might have a little bit of an issue. But it definitely...
It shows the sign MLM.
So, here's the good news. Like I said, and this is what they said in the press conference. It did land. it landed. It counts. They're getting telemetry from the vehicle. You are getting telemetry from the vehicle. Right here. Everything's good. The IMU is reading 1.634. So I think we can rule out IMUs. The IMU being the problem. It's reading correctly. And I think the throttle stuff is reading correctly. Guys, really to see what happened here, we'd need the telemetry in real time. It's hard to say. It's hard to say. That could be anything. Could be a rock on the ground. The tick rate on the lander is not enough. We're getting lag, because it goes from that crazy, like almost basically gimbal locked thrusters, right? If we go over here a little ways, we go back here a little ways. Don't get me wrong, these thrusters don't gimbal lock. You're getting control lock because all of these thrusters are at 1,000 or 100%, excuse me. All right, let's see what we got here. That one right there. See? So, if you look at these throttle indicators, right? They're showing a percentage output of throttle. These are locked. 267, 226, 223, 228. Which means you have thrusters on pitch and yaw that are gimbal locked. Basically, the thrusters are trying to correct for a rate that either that or it's trying to pitch over. But if it was trying to pitch over, it would just be these thrusters with modulating thrust on 1, 2, and 3. The fact that you have lock on 3 thrusters, right? Now, let me think about this for a second. So I would assume that these rates are correlative to the orientation in the animation, right? So if you have 3 thrusters maxing out over here and 1 thruster maxing out over here, you are going to get a little bit of a roll rate, but a maximum yaw rate. And that's what we see right there. Now, and then we see negative 4.29 degrees a second radian. So that's a little bit of roll, a lot of yaw. That's right for thrusters left to right here. Now, simultaneously, we see these thrusters up here, 267, those guys, right, are also in lock, meaning they're at maximum thrust. Now, what's lock? Like, what are we talking about? These motors don't, like, turn, right? There's no thrust director control. No. They use differential thrust for control here. So when you're using differential thrust in rocket design, say you have 3 engines here and 3 engines here, all right, as opposed to 1 engine, right? Say you have 1 engine and the vehicle starts going this way. The engine's going to turn to compensate, right, to get the thing upright. Think like Falcon 9. The motor can move around. If a rate is induced on the vehicle, so something happens, maybe the wind blows or something, and the vehicle starts doing this, and the rocket engine goes to full thrust on one side, and it can't turn anymore, it can't compensate for that rate, and that is a gimbal lock. That is a loss of control. That means the maximum movement of your thruster the maximum induced moment of your thruster cannot correct for that rate. That's loss of control. That's loss of control with airplanes too, right? If you're trying to fly and your plane is damaged or something and you're pulling the joystick back just to get you put your elevators full backwards just to get the plane to fly straight, that's not good. That means if you have to pitch up again, you basically can't. That is not loss of control, but You've gimbal locked a control surface. That's bad. I'm not going to sit here and say that that's good. All these being in the red's probably not a good thing, because it seems to go on a gradient from white to red, and if it's green, that means it's good. But we have a bunch of thrusters here that are that are locked. You're in G-lock here. Well, not G-lock. You're in loss of control here. So we know that the yaw thrusters are not working. We know that these yaw thrusters aren't, or the rates for the yaw thrusters are right. Now let's look at pitch. Well, the pitch thruster here, you have one of them that's locked, and then you have three of them up here that's locked. This would induce a lot of pitch, which is what we see here. A lot of positive pitch movement here, and a little bit of roll. Because you have, once again, there, instead of like an engine that moves like this, they have thrusters on either side. And the thrusters, more thrusters firing on one side is going to get the thing to turn. Both thrusters firing on one side is going to get a deceleration. So, right, you would see changes on the IMU here. You're not going to see you're going to see an incremental change on the IMU if you're rotating, right? Because rotating is not going to move the vehicle around. You're not going to translate around when the vehicle's rotating, right? So what you're seeing here is the thing trying to do this. We have not a lot of acceleration on your IMU, which means it's hovering, right? But it seems like the controls go a little funky here. Yeah, LOC is loss of control. Yep. Yeah, you see a bunch of thrusters that have exceeded rates here. See, like if they're in the green, you're good to go, but if these go red, you got a problem. Now, once again, it looks like this right here is a telemetry driven animation based off of a simulation. Now, if you look, when you don't have gimbal or something, you still need to keep the thing straight up. So what they're doing is modulating the RCS. The reason why they do that is, one, modulating RCS can get nice stability, right? If you turn SAS and RCS on in KSP, it does the same thing. But see, from their animation, it dropped Lev 1 right there. And then, see what I'm talking about? That's what we should see. And see, this is why it's going to be hard to check the animation, because the tick that we saw looks like it's right there, give or take. It looks like we got a bit of animation, a bit of telemetry from here. Because see, 1, 2, 3, 1. That's why I think this is a telemetry-driven animation, because what we see here definitely looks about the same. That's from before the mission. I understand, which is why I said it's a telemetry-driven simulation. Yeah. I don't know if you heard me say that. Yeah, see? 1, 2, 3, 1. That's weird. Without more telemetry, it's really difficult to say what happened. This is hard to say. I'd need uninterrupted telemetry to tell you exactly what's going on. Because from what this telemetry looks like, it looks like the thrusters stopped firing. You have lock on a lot of these thrusters here. Now, let me just go back a little bit. Did they ever get, during certain phases of the mission before, I'm just kind of looking at the thumbnail, did we ever get lock on these things? Let's click right there. Let me see. No. See that? That's not good. Something... I'm not going to say it's a malfunction. You can't say one way or the other. This could be a bunch of things. It could be a bunch of different things. Like, and I hate to abstract this, but without more telemetry, see, everything just goes to zero there for a second. So that what we saw here would suggest that you locked like a bunch of the thrusters and the thing over-rotated. But that doesn't seem to be the case from their telemetry-driven animation here. Simulation-driven animation. This looks like a simulation of what they were trying to do. Because, see the thruster modulation that they're using to keep it on an even keel? The thruster modulation is more or less correlating to the telemetry. It's close. But the last thing we saw from the telemetry was right around here. So there was a telemetry blackout from basically this point to that point right there. Without that second or two of telemetry, I can't tell you what happened. We see the rates, and we could see that something induced a rate on this thing to get it to over-rotate. Could be the ground, could be a rock on the ground, could be the guidance software didn't work correctly. It could be that you had a sticky valve because you overloaded the duty cycle on the engines, right? Could be a bunch of different things. It could be 1,000 different things. Some things that I can rule out completely here are the IMU. I'm pretty sure the IMU is correct. The IMU is reading right this entire time, so it's probably not location. It probably knows what's going on. It knows where it is because it knows where it isn't. But yeah, it's very clear that whatever happened, it didn't settle in the ground correctly. It actually flipped over. Lunar dust may have messed with it. It may have settled into the soil cooking, or it hit a rock on the surface and, maybe it fired and then it corrected correctly, right? But if it hit a big rock, right, trying to come down, it could flip it. The vehicle's clearly flipped over, right? Like, see how we have a little bit of telemetry blackout here? Like, look. So the thrusters go into lock. Last orientation of the vehicle that we get is looking at its belly right here. Right? You're looking at the belly right there, and you're looking at it from the side right there. Now watch. You got a 90-degree induced rotation right there. See where the solar panels are? Like, look at the difference between that and that. Something made this thing roll. It wasn't supposed to do that right there or that. It's just supposed to... JAXA just said they made contact with the landed vehicle. Well, sure, of course. Yeah, the rover is intact. It seems to be mostly intact on the surface. But the problem is, see it settling on the surface right there? It's settling in the dust. You see it just move around? The problem here is that these things, the things that you need to generate power, aren't facing the correct direction. So the rover is intact. They have telemetry. Look, 1.62. She's good. Just pointed in the wrong direction. But once again, without if I don't have the telemetry here, but I can tell you right now, that's bad. That's not good. Something... Yeah, something caused an induced roll on this thing, and it was enough to overload the thrusters so they couldn't compensate. Dude, guys, this looks like it landed on a rock. I'm not even kidding. That's what this looks like. I don't really think there'd be anything on the vehicle itself, considering it got this far, that like a broken guidance system or something, or a bad IMU, or like relative navigation if it's using something like that. I honestly think it just hit a rock. Yeah, that's what this looks like. But once again, without all the telemetry, I can't tell you. Last. No. What's your last? What's up? If this was a 4-leg lander in KSP, this is what it looks like when one leg digs in and the other one pirouettes on that leg. Yeah, but it's not, though. This thing just is designed to land on its belly. Dude, I think it landed on a rock. Landed on a freaking rock. Or the slope was too bad. Like, I mean, Drummer's saying, oh, it's supposed to land on a slope. Well, clearly it didn't land on the right type of slope. I think... Yeah, I think the terrain screwed it up. It looks like... Because, once again, the thrusters, you never see them exceed duty cycle here. You never get them locking until right when it gets near the surface. So, for instance, like if it's coming down, right, and it dropped lev, right, and then the thing, once again, the last telemetry driven piece is right that we get is right around here. Actually, what part of the telemetry is the lander motors? Is that these things right here? PX and MX? Are those the landing engine throttle? I think they might be. Even those things. Yeah, 134. 134. Dude, it hit a rock. I'm not a bet man, but if I was going to put money down on it, it either hit the ground too early or it hit the rock. It hit something on the surface. Are they using a radar TV based landing system? Don't know. I'm not sure. I'm not sure what they're using for altitude here. But if they're landing on a slope, right, and the terrain is kind of like crooked on one side, and this thing is coming down, right, and it dug into the soil, that would explain these things. I think relative position to the ground got messed up. I think it hit the ground. Yeah, now that I'm really thinking about it, it hit the ground. Just hit the ground. It didn't even hit a rock. It just hit the ground. How much do you want to bet Regolith kicked up during the hover obscured the camera for onboard vision systems, didn't recognize it? Obstruction. It depends on where they're landing. It depends on where they're landing, dude. Is the mission profile not too hard? I think the engines hit the ground, MP. That's what this looks like. This looks like contact before it was supposed to. Could they refire the thrusters to set it upright? Well, no. The problem is that the thrusters are pointed up. How are you going to get this thing? They need this thing to roll 90 degrees this way, so the solar panels are facing up. With you have 14 thrusters that point upright. That's like not good. And if it's dug in, yeah, that might be a little bit difficult. See what Journey said. They covered the landing sensors in the presentation in detail. Okay. Cool. Can you elaborate? What do you mean? What, okay, they covered the landing sensors. Where? Give me a timestamp. I could tell you. Where's the landing site? Okay, they did. Okay, they landed in a Mar. That's good. Mari. They could rocket alternative sides. It's possible. It's possible that it could be uprighted.
So here it is. This is the rabbit's ear, and there are two rabbit ears. And the bottom one is the western side, and then this is where the crater is.
Oh, Mare Nectaris. That's right next to the Sea of Tranquility, actually. So Neil and Buzz landed right here, give or take, right around there. That's where the first moon landing was. Nectaris is a good ways south of there, but yeah, you can see that basaltic region just looking at the moon. You could definitely see it with a telescope.
So this is the landing site for SLIM. It's going to be on this crater where we think we're going to have exposed olivine material from the moon's mantle. And it's on this sloped terrain, so we have to land very accurately and on the slope.
Can we go back to naming stuff with like Latin names? These Mar Nectaris, Mar Tranquillitatis. That's awesome. Look at some of these names. Cyrillus. That sounds like syphilis. We don't want that. Theophilus. These are awesome names. Fracastorus. Liberate a ti ex inferis.
The crater itself is very small, like 1 kilometer, but SLIM is trying to get that.
Hold on, what did you say there?
The crater itself is very small, like 1 kilometer, but SLIM is trying to get that.
Okay. Et tu, lunar. Love me some big nectar. Yeah. Sea of nectar, I think, is the English translation there. Journey, do we get a timestamp on this thing, buddy? Let me see. Oh, actually, here, hold on. I think I found it.
Please tell us more about this crater, Shiori.
See what? Okay, just real quick. So they have all the stars for the 6 moon landings right there. See Mar Nectaris. There's Sea of Tranquility right there. See what I'm saying? Those are all the Apollo landing sites. The stars, which is actually super cool. And the Lunar Reconnaissance Orbiter has pictures of the descent modules. Hell yeah. Hell yeah. There you go. See the blast mark from where the ascent module took off? That's an Apollo descent module right there. That's cool. Dude, NASA should do something like this every time. This is awesome. Perfect. Sugoi. That is perfect. The mission press kit. All right, let's see if we can read about those sensors, see if we can learn something. Thank you, Thomas. All systems, can you give Thomas regular, please? So he can post. Moon Sniper? Am I free? Yeah, we could see you. Yep, we have you 5x5, buddy. So you mean we actually went to the moon? 6 freaking times. Because we're freaking G's, dude.
Discovery, go at throttle up.
Well, it doesn't matter anymore because Poison gifted you a tier 1 sub. Alright, let's read. See, I really, really appreciate the way Japan's doing this. It's just a couple of dudes sitting on a couch talking about going to the moon. Talking about where they're going, what they're doing, where the lander's supposed to land. And Drummer, yeah, I'm pretty sure you're right. It's supposed to land on a slope. It's designed to do that. To prevent over-rotation. So that means maybe it landed on flat ground. Maybe it landed flat. So the minimum criteria for success is to realize a soft landing on the moon with a small lightweight spacecraft, accomplished the following by the 2. By conducting an actual lunar descent, verifying the vision-based navigation, which is essential for high-precision landing, and developing a lightweight spacecraft system in check of its operation. I think they achieved that pretty well. Full goals would be to achieve a high-precision landing within 100 meters of accuracy. The navigation and guidance rules operate normally, and the achievement of landing accuracy is confirmed by telemetry data after the landing. partial credit. All right, let's see. What do we got? So, okay, they're using, this is a relative navigation. You can tell from the downward-facing nav camera. So it's relative. So they have PX and the MZ nav camera right here. Yeah, it's using relative navigation. They have just cameras facing down, and the computer is trained. It's algorithmically trained to look for a flat or, well, for a clear landing site. So I think with their relative navigation, I'm pretty sure engineers at JAXA know the difference between flat ground on the moon and a rock. So they probably would have trained the relative navigation to plot the right landing solution. The Astrobotic NASA presser was delayed by 15 minutes. Okay. Those are their thrusters. They're using 20 Newton bipropellants. That's RCS. Little tiny boys. 12 units of thrusters. So 3 in 4 thruster blocks. Which, okay. Your main OME engine, which we saw from the telemetry over here. So, yeah, PX and MX. That's your engine throttle right there. Okay. Landing rover. Laser rangefinder. An optical wave sensor used to measure altitude above the lunar surface before landing. It receives the modulated laser light reflected from the lunar surface and calculates the distance based on phase. Okay, yeah, laser rangefinder. Similar to if you play golf. Trying to see how far the pin is. If the pin's cut short or if it's cut back. Same thing. Only a really fancy aerospace version that's made by Mitsubishi! Unless the lander engine kicked up dust in the wrong way. So, Oglux, I wouldn't rule that. See, here's the thing, okay? I wouldn't say that that is actually a reason for the thing not working correctly. There's no way they didn't model some type of regolith dust kick-up, okay? Right? There's no way you didn't take that into account. No way. Right? That's what I'm trying to say is like that's too obvious of a thing. Now, here's the thing. I'm not saying just because it's an obvious thing that it's not what's going on. What I am saying is if they landed on a piece of terrain, right? If they landed on a piece of terrain that was not what the rover was designed to land on, i.e. if this thing's supposed to land on a slope and it plotted a landing solution for flat ground, you got a big problem then. It's going to kick up dust in a way that you didn't take into account, right? But I don't think... Let me read more. Hold on. I don't think that the laser rangefinder would malfunction in that regard. There's no way they didn't take into account the LRF not seeing too much kicked up dust, right? The only way that would happen is if it landed on a piece of terrain that was not what they expected, right? Are they planning on recovery or no? So Dan, this happened. Good questions, dude. This actually you reminded me because we got like super deep into telemetry analysis there. Japan was trying to land a rover on, or not a rover, a lander on the moon called SLIM. It's basically small lander for moon investigations, right? And what this thing basically was trying to do is basically get Japan the capability to know how to land something on the moon. That's basically what the rover was for. What the lander was for. That was its objective. Figure out how to get this thing down there in one piece. That's the goal of this mission. Just figure out how to land, which is cool. Right. So what happened is, so I'm a little bit of a nerd, dude. I'll be honest. I'm kind of a nerd. Okay. I'm a little bit of a nerd. I've been looking at the telemetry here from the actual mission. The Japan webcast was cool enough to actually give us the numbers. This is the telemetry. This is what the cars. I say car because telemetry is something that gets thrown around in Formula One all the time. This is what the lander is actually doing. You can see what thrusters are firing. You can see the acceleration on the vehicle as a whole, and you can see what direction it's pitch, yawing, and roll. Like if it's doing this, you can see where it's rotating, right? Safe to say I'm a nerd, but a nerd that likes this stuff and doesn't know a lot. All right, so this is pretty straightforward stuff. This looks like a lot. You're like, numbers. All right, that's if it's doing this. All right, This one right here is if it's doing that, right? And this one right here is if it's doing this. Hi. Right? So you have yaw, roll, and pitch. These are your thrusters. There's 3 blocks of 4 thrusters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. They're all facing downwards. And they use thrust modulation for attitude control. Basically, they're using RCS to keep this thing on an even keel in lieu of an engine that would turn in different directions. Now, on top of your control thrusters here, you have 2 downward-facing main engine thrusters right here. Orbital maneuvering engine PX and orbital maneuvering engine RX. The PX and the RX just means they're on 2 different sides, right? 4 blocks of 3. I said it backwards. So right here is your throttle outputs for your 3 engines, for your blocks of 3 engines here. And this is your throttle output for the main engines, and this is your telemetry-driven animation, fuel, oxidizer, total mass of fuel left, battery power. Once again, this is awesome. With this, I could figure out what this thing is doing. We could see exactly what it's doing. And then over here, you have a telemetry-driven animation. Are they on the moon yet? It seems like it landed, Bidster, but see, and Dan, watch this, dude. So it gets down to the surface, right? They get down near the surface, and watch the thrusters. Watch. Now, anybody here that watches sci-fi movies, when the console starts flashing red, something bad is happening. So spoiler alert, the console's flashing red all over the place. Something bad is happening. Something bad is happening here. That's a lot of red. That's no good. So what's happening here is that the thrusters are gimbal locked. Now, do the thrusters actually have gimbal like what you'd see in like Kerbal or something? Does the engines actually pivot? No. Once again, you're using different thrusts. Basically, you have some thrusters over here on this side of the vehicle and some thrusters over here on this side of the vehicle. If this thruster fires and this one doesn't, the thing's going to roll, right? So by watching the rates here, so we have 15.2 degrees per second rate on your yaw. We have minus 4.29 degrees a second per second rate on your roll. And then you have up to 10.5 degrees a second per second pitch. What does that mean? That means the thing is doing this. That means it's flipping over. Now, there was a telemetry blackout here. The telemetry stopped from the webcast. It just got stuck and then everything went to 0. Now, usually when you see red all over the console and then nothing, it either means you lost connection with the vehicle or it's just sitting there. So, the thrusters aren't firing. It's but the rates are still going. See 15.2, 27.47, 10.5. Actually, it's gimbal lie. The pitch rate indicator is off the charts. So is yaw. So is roll. That's bad. If you have rotation rates induced on your vehicle when your thrusters aren't firing, that means something else is flipping the vehicle around. Now, let's be real. Let's use some process of elimination here, okay? So, we have to know if this telemetry is good. Did we crash? Don't know. Hard to say. The IMU down here, so that's your inertial measuring unit. It measures acceleration. The IMU is reading a 2.433 acceleration. If the IMU is giving you a number, right? If that number is moving around, that means you're accelerating or decelerating in any particular direction. That thing over there tells you if the vehicle is moving, if it's moving around. Translation is what it's called, if it's moving. You know, like if you're playing a shooting game and you strafe left, right, that's translation. But if you use your mouse and you move around, that's rotation, right? Same idea. So, we have IMU. Our IMU will also pick up a number, 1.6 meters a second per second, 1/6 lunar gravity, right? if it's on the surface. It'll pick up the gravitational acceleration because gravity is pushing that thing down into the ground. It's just 1/6 Earth's gravity. 1.63 is 1/6 of 9.81 meters a second per second. That's what gravitational acceleration is on Earth, right? So the IMU is reading some type of translation. It's not sitting still. It's moving on the surface, but it's also yaw, roll, and pitch locked here. Basically, the thing is dreidling around on the surface. It's spinning. And now if you look at the animation here, watch. See, the IMU went up and then it goes down. See right there? IMU will eventually settle to 1.6, but you see the thing. What this thing is supposed to do is supposed to come down and then pitch over and land on its side, so to speak, right? That's what it's supposed to do. See this side right here? If you look, you're looking at me. See this side? So that's the side that should be touching the ground. Simultaneously, this side over here, this side on the rover, that's the side that should be facing that way. So it nosedived. So it went to do something like this and ended up doing it too much and then settling in the terrain nose down. Just released. Okay. Hey, Chief. So, like I said, this is not hard information to read if you know a little bit about like what pitch, yaw, and roll is and, you know, throttle outputs. But once again, so the IMU settles and it reads 1.63, right, with 0 rates, which means you're picking up gravity and the vehicle stopped. Now, you didn't crash into the ground because you're still getting a reading from the IMU, so we can eliminate that one. However, judging from this telemetry here and me playing way too much Kerbal Space Program, now it's not just that. I've read, it's not just Kerbal, all right? Read a lot about this stuff. Lock on all of these thrusters here and your landing engines. This tells me that it crashed into the ground. It booped off the ground and then flipped over. Astrobotic update has started. All right, cool. So we'll get a word on Slim here in a second, and then I will get to... Now we're going to switch gears over to Astrobotic here. So this is the Peregrine mission that launched. Unfortunately, the Peregrine lander was lost, so...
Hendrickson, Vice President of Business Development. Sharad Bhaskaran, Mission Director for Peregrine Mission 1. Andrew Solorzano, Peregrine Flight Director and Principal Systems Engineer. Also joining us and from NASA headquarters is Joel Kearns, Deputy Associate Administrator for Exploration in the NASA Science Mission Directorate.
Okay, so the Astrobotic Peregrine lander, just for people that are like, is this the lander that you were just talking about a second ago? Believe it or not, that's another lunar lander. Astrobotic was a NASA Commercial Lunar Payload Services mission that launched on the Vulcan Centaur Cert-1 mission about a week ago, give or take. Astrobotic is a different moon lander, and the Peregrine lander ended up having a fuel leak that basically they leaked too much fuel so they couldn't land on the moon. You said something about sand. Could it be stuck in the dust? Pigeon, that's actually... I think it hit the ground. I think it hit the ground. That could be just because they plotted the wrong type of landing trajectory, or they didn't get a thruster right. But when you see thruster gimbal lock like that, that means an outside force is affecting the vehicle, the Slim vehicle. That means an outside force is affecting it that's not the engines. The only other thing out there, like I said, process of elimination, the only other thing out there other than the lander is the freaking ground. So, I mean, once again, I'd have to get full telemetry to tell you guys exactly what happened. But, yeah, that should be pretty straightforward stuff. Anyway, we're going to change gears to the Astrobotic mission here, and let's hear what they have to say.
And one of our big nail-biting moments first was, will the lander turn on and start communicating back to Earth? And within a couple minutes of the opening of that window, we had comm. Power was up, spacecraft was operational, and things were looking good. And as we continued to turn on the spacecraft and initiate systems, within about 2 hours of the first turn on and communication, the propulsion initiation occurred, and that's where the challenges started. So the first parts of propulsion initiation worked really well. We were seeing balancing of pressures in the tanks as some of the valves started opening. Everything looked nominal. One of the final steps of that initialization is the firing of a valve to open the helium to the fuel side and the oxidizer side. The fuel side appeared to open successfully. The oxidizer side appeared to have a problem. And we believe that our leading theory has not changed at this point. We're going to be looking at this very heavily with a anomaly review board. But what appears to have happened is that valve connecting the helium to the oxidizer did not properly reseat and sent a rush of helium down into the oxidizer side. And I describe it as a rush because it was very, very fast. Within a little over a minute, the pressure had risen to the point in the oxidizer side that it was well beyond the proof limit of the propulsion tank and the oxidizer side of the tank. And we believe at that point the tank ruptured and led to, and unfortunately, a catastrophic loss of propellant at that point for the primary mission.
Frickin' valves, man.
I'll always remember the moment at Mission Control at ULA when we were coming from the highest high of a perfect launch and came down to a lowest low when we found out that the spacecraft no longer had the helium and no longer had the propulsion needed to attempt a moon landing.
Yeah, that blows.
So that was certainly a tough moment for all of us. But what happened next,
Indeed,
I think, was pretty remarkable and
kidding,
inspiring. Our mission control team in Pittsburgh kept their cool. They focused on the problem, and they diagnosed what occurred, and working with a clock on, because we had a problem where our solar panels were not oriented to the sun. We had just 6 hours between letting go of the launch vehicle and when the battery would run out for the team to diagnose what occurred, figure out how to fix the situation, and get us sun pointing once again. And literally within 4 minutes of the beginning of a loss of signal, expected loss of signal with the spacecraft that was going to likely cause the batteries to go down to critical or probably 0% and kill the spacecraft. One of our engineers on console, along with the whole team, was able to establish a solution and sent a command with 4 minutes remaining before that LOS to reorient the spacecraft and save the mission. But of course, we didn't know at that moment that it had worked. We had to wait the entire LOS period to find out if that maneuver had worked. And it was quite a thrilling moment on the other side of that, to finally see the batteries starting to tick back up and the solar panels starting to generate power and provide power for the spacecraft.
That's cool, man.
So that was a remarkable moment and a real...
Guy's a freaking G.
I'm so proud of our engineering team and our mission control team for keeping its cool and working the problem and trying to find a great solution to keep the spacecraft alive.
That's how you space
And at that point going forward, for the next several days and hours, we were focused on the fuel and trying to model what was occurring. Originally, the hole looked pretty big, but interestingly, over time, we actually think our current leading hypothesis is the tank, as it was lowering its pressure, started to seal the hole up a little bit, and the leak progressively got smaller and smaller through the course of the mission. And by the end of the mission, the leak was no longer the dominant issue with the spacecraft. So, of course, we didn't have enough fuel to do very many maneuvers, but it certainly changed over the course.
Cool.
We did continue to fly very successfully on our way out to the moon. On the way out, we activated all of the payloads that had power or could use power during the mission. We received successful signals from all of those payloads, and we got data back from all of the payloads that could send data. We were very pleased to see that. Interestingly, many of those payloads and that data, they were not intended to be turned on between Earth and the moon. And because of this anomalous state of the spacecraft, we decided to get as much of that as we could. And interestingly, a lot of those payloads were able to report some interesting data and some level of success from that. When we got back out towards the moon at about lunar distance, just a quick reminder that the moon was not there because we were doing a phasing loop around Earth, so the moon would have been back if we had gone back to Earth and back around out to the moon again. When we reached lunar distance, that was one of the first times that we got an updated trajectory analysis, and what that showed is that the leak that had occurred had done two things. One is it had veered us a little off course. You could think about it as like a left or right off course, but it had also slowed down our trajectory. And it changed the impact, it changed our trajectory to indicate that if we did nothing from that point forward, that we were very likely to return back to Earth. And at that point, we're talking Saturday, the 13th, we were assessing all of our options and trying to figure out what the next right path for the spacecraft would be. We reached out to our partners at NASA for their assessment as well. And that evening, we were faced with a very difficult decision on what to do with the spacecraft. We had an option of attempting to use our propulsion system to avoid Earth and go back out to the moon, or hold steady and have the spacecraft maintain the trajectory it was already on and intersect the Earth. At that point, we made the difficult decision, upon receiving recommendation from NASA, as well as looking at our own data internal, we made the difficult decision to do nothing and to not take the risk of firing those engines and to let the spacecraft fall back toward Earth. We did the best we could with the data that was available at the time. And then as we came back toward Earth, we continued operations and got as much from the spacecraft as we can. And then in the last few couple days right before entry, we felt it was necessary to do some maneuvers right at the very end of the mission to make sure that we could end up with a safe splashdown at the very conclusion of the mission. We did those maneuvers, which was again a proud moment for me to witness mission control and see what they did. We were able to activate the engines. We were able to fire all 5 main engines. We were able to maneuver the spacecraft in a unusual way. We were not able to fire the engines continuously. We had to do a series of small pulses. Those small pulses maneuver us away and put us out into a nice, safe location out in the ocean. And the final maneuver was very clever because they figured out and had characterized the leak at that point and figured out that if we could turn the spacecraft, we could actually use the leak to our advantage as essentially a continuous small propulsive maneuver that could push us further out into the ocean. So yesterday at around 3:50 p.m. we lost telemetry with the spacecraft, and 3:59 p.m. Eastern we lost ranging with the spacecraft, which aligns with our projected impact or projected re-entry at 4:04 p.m. Eastern. So since then we've been sharing images and video of the mission, and I'll just reiterate once again how proud I am of the team and the mission control folks and everybody who's been involved with this program from the start. We did not achieve the primary objective of landing on the surface of the moon, but we had an anomaly, and after that anomaly we just had victory after victory after victory, showing the spacecraft was working in space, showing that the payloads can operate.
Thank you so much.
And getting data back from those payloads and sending as much as we possibly can. So again, I'm just thrilled to be, and honored to be a part of this team. And it's really been a special experience that I'll remember for the rest of my life. And I do just want to read one quote from one of our payloads that did receive data, and this is a quote from Thomas Berger of DLR, the German Space Agency. And they had on board a radiation detector, so I'll just read this quote. The DLR M42 radiation detector was working perfectly throughout the whole mission timeline. We were able to gather over 92 hours of data measuring the radiation environment in free space during the mission, which is extremely valuable for the science community and for DLR.
Wicked.
So I think we were very happy at the end that even despite our anomaly, we were able to get some good science data for our partner for DLR. So from here, our next steps, we're going to be very focused on analyzing this anomaly, make sure that our leading tried to figure out exactly what occurred. As of now, our leading hypothesis has not changed, but we're going to be assembling a review board of many experts from across the industry to take a close look at this, to figure out exactly what happened. We are already assessing what those impacts could be for the Griffin program to make sure that this kind of anomaly never happens again. And we also are making sure to incorporate all of the successes of what worked on the Peregrine mission into the Griffin program to make sure that Griffin is successful. That mission is still scheduled for the end of this year, where we'll be flying once again, and I'm very much looking forward to that. And I can just say that I am more confident than ever now that our next mission will be successful and land on the surface of the moon, just seeing what our team did, what they went through, and what they overcame to get us to the unexpected but very exciting mission that we ended up with.
All right, thank you, John. And we have some other folks on the line too. So next up is Dan Hendrickson.
Good afternoon, everyone. My name is Dan Hendrickson. I'm the Vice President of Business Development here at Astrobotic.
Hi, Dan.
I've been with the company for about 9 years now, and over that time, I've been working with the payload customers that we brought aboard Peregrine Mission 1. I'd just like to echo John's point that the payload teams achieved a lot on this mission. It's been really incredible and heartening to see the Astrobotic team working very closely with all the payload teams around the world. And I just want to note that they've been so supportive, and it's just been an outpouring of support that we've received from them. We do not take that for granted. Obviously, this mission outcome wasn't what we expected, but we are so grateful for their continued support and the fact that they were able to get valuable payload data that should benefit the entire space community around the world. So again, I just want to iterate thank you to the payload teams that stuck with us through this adversity, and we look forward to flying again.
Thank you, Dan. And now for Sharad Bhaskaran.
Good afternoon. Sharad Bhaskaran, Peregrine Mission 1 Director. I've been the director of this mission for 7.5 years.
What up, Sharad?
We've gone through a lot of highs and lows, but it's been ultimately a very rewarding experience, especially to still get a lot of data from the spacecraft and data to our payload customers. So happy to be here this afternoon.
Thank you, Sharad. And now we have Anders Solorzano.
Hello, good afternoon. I'm Anders Solorzano, a flight director and the lead systems engineer for Peregrine Mission 1. I've worked at Astrobotic for well over 9 years since the start of the Peregrine program. I was on console as the flight director for a quarter of our mission time, and specifically during the launch shift, the main propulsion anomaly that we saw, the first main engine pulsing, and the Earth re-entry ops. I was pleased to have the opportunity to work with a dedicated mission team that behaved like a professional mission operations team despite the challenges that we saw. Glad to be representing this excellent team of astrobots.
And finally, we have Joel Kern. Joel?
Thank you, Olivia. Thank you for having me be part of today's discussion. I'm Joel Kearns, and as part of my role at NASA, I direct NASA's Lunar Science Program, which includes commercial lunar payload services, where we work with industry to take NASA experiments to the moon. So as part of CLIPS, Astrobotic's Peregrine Mission 1 became the first American commercial lunar lander to launch on a mission to the moon. We know we will learn from each flight as we go into the future with more and more CLIPS deliveries as part of our Artemis initiative. There are currently 7 deliveries already awarded, and there'll be more in the future. Now, Astrobotic was very proactive in operating the payloads in their alternate mission. Efforts by the Astrobotic team allowed the Peregrine, the NASA science instruments on Peregrine, to collect data about the environment out in space from the Earth to the moon. All the NASA science payloads that could operate by being powered on did receive power and effectively gathered data during the time Peregrine was in flight. The NASA payload teams adjusted their operations and were able to demonstrate, we believe, that they could have operated if those instruments had reached the moon. The measurements and operations of the NASA-provided science instruments on board, we expect will provide valuable experience, some technical knowledge, and some scientific data to future CLIPS lunar surface deliveries. 2 of the payloads, the neutron spectrometer system and the linear energy transfer spectrometer, or LETS, made measurements of that radiation environment in the space between the Earth and the moon. Now, a successful soft landing on the moon is extremely challenging. We've talked about this in the past. And exploring space is not for the faint of heart. People that work in space often say space is hard, for a reason. And our lunar delivery service model is a first for NASA. And this was the CLIPS model's very first lunar delivery, where we deliberately had U.S. industry provide the spacecraft and mission And as with anything new, there can be risk, unforeseen things can occur. We share at NASA Astrobotic's disappointment that the Peregrine Mission 1 landing couldn't occur. But I'd remind people that breakthrough innovation doesn't tend to take place as a progressively positive series of events. Failure is often part of the road to success. And flying and landing a newly developed spacecraft in space or on the moon is extremely difficult. And that's why NASA has described this lunar service delivery approach as challenging. We are embracing a risk posture where we new companies will innovate, push the envelope, and we will all learn and grow from each flight. I want to add that it was really inspiring for us at NASA to see the public support and the public rallying around Astrobotic as it conducted the Peregrine 1 mission. Our CLIPS initiative is meant to grow a nascent space industry, enhance capabilities to get into cislunar space, making the moon more accessible to all. So we're really encouraged by the American interest in enhancing our exploration capabilities together. Now, NASA is committed to supporting our U.S. commercial vendors as they navigate the really difficult task of sending science and technology to the surface of the moon, because the benefits of this approach, when it succeeds, are going to be very great. We commend Astrobotic for its diligence, perseverance, and making every viable effort to collect all the data they can and show the capabilities of their Peregrine system while it was in flight. And together, we'll be able to use those lessons learned to advance CLIPS. Thank you.
Well said.
Thanks, Joel, and thanks everyone for your comments. We'll now open it up for questions. Again, if you're on the line, please press *1 to submit a question. Once your name is called, please state your name, affiliation, and to whom you'd like to direct your question. If you find that your question has already been answered, press *2 to withdraw. All right, let's start with Marcia Dunn of Associated Press.
Can you say with certainty at this point that the Peregrine re-entered over the South Pacific yesterday afternoon and burned up? Did anything survive and impact the ocean? What specifics do you have on what went down? Thanks.
So what Astrobotic knows right now is that we lost telemetry at 3:50 p.m. and that we lost ranging at 3:59 p.m. We have reached out to multiple government entities and other folks to see if anyone else has any additional data or any other indication of positive reentry. We have yet to receive that confirmation.
All right, and our next question is from Joey Roulette from Reuters.
For John, what is the timeline for this next mission after what happened with the first mission here? And for Joel, you had said that we will all learn and grow from this flight. Will data from the anomaly investigation with Peregrine be shared with Intuitive Machines, Firefly, or any other Eclipse companies? Thanks.
On the first question of timeline, so our plan is to continue to proceed with Griffin, which is currently scheduled for November of this year. We will wait to see what the conclusion of our anomaly review board is, to see how much impact, if any, that has on the Griffin program. We do expect some, we just don't know how much yet, and if that will impact schedule, it is still TBD. But right now we're just focused on getting to that program and flight as fast as possible.
And next
John,
up, sorry, go ahead.
Okay, this is Joel. For the second part of the question, John, do you want to address any of that from your perspective before I talk?
Yeah, I mean, sure. In terms of what we'll be sharing, I think we've been pretty transparent with what we know about the system. We are all about making space accessible to the world. That's part of our intention for being transparent, because we really view this as a challenge of humanity against the stars here. So we'll continue to be transparent with what we find and what we uncover here, so that we can all get better as an industry and as a world for returning to the surface of the moon.
Thanks, John. And I'll add that NASA will provide technical experts to Astrobotic's Anomaly Review Board. What I have to say is that NASA does not share proprietary information from one company to another company. We can't. But of course, we will take the lessons from this in our thinking on CLIPS, and we'll encourage Astrobotic to share the findings with other companies.
It's cold out, reindeer.
All right, our next question is from Gina Sunseri from ABC News.
Yes, thank you. One, I want to thank you guys for your incredibly transparent and timely updates throughout this whole mission. I think you set a standard for other companies. Moving on from that, I'd like to know what really surprised you. You talked about things you didn't expect, but what did you come away with saying, wow, I didn't know we could do that?
A lot of things through the course. I mean, obviously the anomaly surprised us. I thought there could be a chance of some failure at some point. I mean, because lunar missions are just so difficult. Only 50% of them succeed. I just didn't see that one coming for how that happened. But in terms of the surprises, probably my best surprise through the whole mission occurred, I think it was yesterday morning. Yes, it was yesterday morning when I came into mission control because we were coming down to the closing hours of contact with Peregrine. And the night before, we had talked about trying to get pictures and trying to get one last picture as we come toward Earth. And an amazing thing happened. We knew that the sun and the Earth were almost in the same part of the sky where we were heading towards. We were heading toward Earth. So if you've ever tried to take a picture into the sun, it's really, really hard. And the first time we took that picture of Earth, we got a bad view. But our engineers, unbelievably, I still don't know how they managed to do this. They put the sun behind one of the very small struts that support our payload decks. So basically, it's like the equivalent of sticking one finger out in the sky and blocking the sun, and then they took a picture of Earth. And that picture we shared with the world, and that to me was like that was a big emotional moment because I think that represented the best of Astrobotic in that moment. All of the things working that did work on this mission, and the ability for the engineers to troubleshoot that and orient it and aim the spacecraft in such a precise way. It was an impressive moment. So that certainly took me by surprise in a very good way.
All right, next up we have Irene Klotz from Aviation Week.
Thanks very much. First of all, I just want to echo Gina's comments about the transparency and timeliness. Thank you. For Joel or for John, did you meet the milestone requirements to receive the full $108 million payment from NASA? And for John, during COVID, you had some supply issues like a lot of companies did. Was this valve involved in that? Have you traced the lineage of it yet? Thank you.
Interesting.
So on the first... go ahead.
No, go ahead.
All right. On the first question, so 10% of our award from NASA was subject to success criterion. We did not achieve all of the criterion to get all of that 10%. Though we did achieve some of those milestones. We believe that we've achieved two of those milestones. One was to achieve stable flight in space, and the second was to do payload checkouts. So we're going to continue the conversation with NASA on that one, but at least we believe we've hit those. But as with any milestone for any contract, there's always a review process and an assessment of that. And then secondly, in terms of the valve itself and any connection to COVID, it's too early to tell. The whole mission was always pressured by COVID and the challenge of a firm fixed price budget where we had to make choices and decisions about what mattered most at any given time. And we had to make difficult choices all through the course of how much redundancy or not to do, what kind of valve and what kind of component of for any type to do. And I think all the things that worked right means that we got most of those decisions right. But of course, the one that really diverted this mission and created a problem was one that obviously didn't work quite as we had expected. So we're certainly going to take a hard look at that. We've got multiple architectures, multiple valve options right now on the table that our engineers are poring over to make sure that this never happens again. But specifically, we can't tie it specifically to COVID at this point. It's really too early to tell.
And this is Joel Kearns. I'll add that when any CLIPS mission is completed, NASA determines the final milestone payment of any milestone that hasn't yet occurred based on the mission events that were achieved. And the maximum value, as John said, for this final milestone of this task order is 10% of that total task order value. So we haven't yet assessed all the activity in the mission to do an internal government determination of what the final payment will be.
All right, our next question is from Jeff Faust, Space News.
Hey, good afternoon. I'll echo the earlier comments about the value of the transparency. That's greatly appreciated. A question for Joel. The next Astrobotic lander mission you have lined up under CLIPS is for the Viper rover, which is a much more complex and expensive mission than Peregrine Mission 1. Are you contemplating any changes to that award, like additional testing milestones or such, to provide a better degree of assurance of success for that mission based on what happened with Peregrine? Thanks.
Hey, Jeff, this is Joel. What I would say is that we want to look forward and see the results of the anomaly review board to see what, if any, changes we need to make for the next delivery. As you said, the Viper is a very visible, very sophisticated, and costly payload that'll be brought down by CLIPS. So we want to make sure we really understand the root cause and the contributing factors of what happened on Peregrine. And if we have to modify our plans for Griffin, which is Astrobotic's task order to bring Viper to the lunar surface, we will.
Okay, thank you. And our next question is from Jackie Waddles, CNN.
Hey, everyone. Thanks so much for doing this. Also want to echo the thank yous for the transparency. Quick question for John. Can you give some details on what exactly that fix was that your engineer on console came up with that kind of saved the mission in that final hour? Was it just that you didn't know that you could use the ACL thrusters at that point? Any details would be much appreciated. Thanks.
Sure. Yeah, it's a fun story, and certainly a big turning point for how the mission unfolded. The engineer who actually found this, it wasn't their shift. It wasn't his shift. So he came in about a half hour before we were set to go into LOS. And all that time, mission control team was looking and looking and looking. And it just so happened that he was very familiar with one part of the code that could have helped the situation. And he found a way to basically send a guidance, navigation, and control update that kind of nudged the spacecraft and had it overcome the leak temporarily, so we could at least get around to the other side and turn the spacecraft toward the sun. The team worked very, very quickly to get us get that command as vetted as much as we can. Typically, commands like that are tested in our flat sat before we send it up, but in this case, it was very short. So the team worked very quickly to write that command up, get it sent, and of course, it happened 4 minutes before that LOS period. So the engineer's name is Josh Schaefer, and he's certainly one of the heroes of the mission here, and just so proud that it's a good thing that he was the one that built a lot of the systems, and I'm just so proud that he was able to find that and help save the mission and turn it into what it became.
Great. And now next up we have Stephen Clark from Ars Technica.
Thank you, and I think my question is probably for Joel and maybe John. What led NASA to make the recommendation to go ahead and allow Peregrine to re-enter Earth's atmosphere without doing a maneuver to potentially extend its lifetime? And for John, if you were able to save Peregrine for another orbit, what else would you have liked to have done with the spacecraft? Thanks.
Well, this is Joel. You know, this is Peregrine Mission 1 was Astrobotic's mission and Astrobotic's spacecraft, but as one of their big customers, you know, under CLIPS, we shared with them our view of the information, you know, our kind of background in similar discussions we've had for other missions, and our view of the risks. And we gave John and his team a recommendation based on that, knowing that John and his team understand their spacecraft because it's theirs and they built it, you know, better than we do. But based on everything that Astrobotic had communicated, as many of you have pointed out very openly and transparently, as they stepped through the mission, we had told them what we looked as their customer and as someone with a bunch of experience, how we viewed the risks of going ahead and having this Earth-based entry burn-up disposal versus extending the mission. And we communicated that to John. John, do you want to add to that from your point of view?
Sure. The question was asking, like, what would we have done if we had extended it, and what was the decision? So the thing we were weighing was, should we send this back to Earth, or should we take the risk to operate it in cislunar space and see if we can send this out further? Obviously, everyone knows the decision at the end of the day. We wanted to make sure that we would protect the cislunar space. But to venture into that hypothetical that we did not end up doing, if we were successful with that maneuver, theoretically we could have maybe made it around the Earth and potentially could have come back out to the moon. At that point, it would have been anybody's guess of what could have happened next. Maybe we could get an impact. Maybe we would have missed the moon. Maybe we could have maybe had enough fuel to get into lunar orbit. It's really the hypothetical world at that point. We just don't really know what would have happened next. But that was part of the challenge, and part of the risks that we were weighing is what's the responsible way to act here. We are setting a precedent for the future of how we operate in cislunar space and how we do these kinds of missions. This is one of just about 10 missions that just in NASA clips that to be sent out to the surface of the moon. And there's going to be human missions, and there's going to be international missions to the moon. It's important that we all act as responsible parties in that, and make sure that we're keeping the space available and accessible for all.
All right. Up next, we have Aria Alamahode from TechCrunch.
It's actually a pretty good press conference, man.
Hi there.
I don't really have much to add. The questions being asked are actually pretty good. Yeah, the precedence here for the questions is quite good. Yeah, I don't really have much to add. I'm just gonna shut up here. Good questions, great insight.
Review board being assembled and starting its investigation. And the second question is, I was curious if Dynetics or Frontier have been involved at all since this anomaly was identified, and if they will be involved through the rest of the year as you approach the Griffin launch. Thanks.
Sure. On that first question on the review board,
private space
the
flight,
mission
no,
is still less
really.
than 24 hours from its completion. So we're shifting gears rapidly towards that, but we have not put that review board together yet. It's not done yet. But I think what's remarkable for that is we've gotten reach out from lots of experts from the world over who have volunteered to be a part of that, and I think that's really, really remarkable. And I think it's reflective of the industry that we operate in. There's times that we all compete because we're trying to get the next contract, but there's other times that you step back and you realize that really this really truly is humanity against the most challenging environment known to humankind.
I value
the
safety.
space environment, and it's the camaraderie that comes out in times of challenge is remarkable, and we're certainly uplifted by that.
What was the second question? He just whispered it. Did you hear that?
What was the second part of the question?
Might not have the mic.
All right.
Oh, the question was about Dynetics and Frontier and other suppliers of ours. So through the course of the mission, we did reach out to some of our suppliers to understand how things might operate in an off-nominal condition, including our propulsion systems. But I don't want to speak for those suppliers. But from what we got, we got what we needed to make the most of the mission as it is.
All right. Next up is Douglas Messier from New Space Report.
Hey, thanks so much. Question for Joel. Two questions. One, what was the value of the payloads that NASA had on this mission? And kind of a general question about how much technical support is NASA providing to the CLPS contractors in general? Thank you.
So the value of the 5 NASA supplied science payloads on PM1 was approximately $9 million. That's in addition to the task order value. of $108 million. Now, at NASA, it's because we're buying a service from the companies, and we're not buying actually a mission from them. We're not buying a spacecraft from them. We make sure they understand what information is available publicly, and in some cases, we give tutorials to all the CLPS companies on certain topics, but we do not tell them how to design their spacecraft or how to architect it. We rely on them to do that because we really want to buy this as a service from them. And industry for many years has, and why we went down this route about 5 or 6 years ago, is industry for many years has told NASA that they believe they have the knowledge and the experience from a variety of space activities to do such a thing and provide an effective service of delivery of hardware and software to the surface of the moon and data back. And we really do not want NASA to be the one dictating solutions to other groups that are providing us a service.
Next up is Will Robinson-Smith from Spaceflight Now.
Next question, Willie. What do you got?
Yeah, so thank you so much for taking the time to speak with us and give us a thorough overview of the mission. Bit of a follow-up to Jeff Faust's question, I suppose, for Joel Kearns or perhaps John as well. Given that there's sort of some ambiguity as far as the timeline for the independent review of the PM1 mission, how soon would it need to be concluded and everything sort of buttoned up in order to ensure that a November launch date for the Griffin lander would be able to be preserved? Thanks.
This is Joel. I don't want to. Well, I would say that the effect it would have on the Griffin mission depends on the findings, right, and depends on what's identified that is applicable to Griffin. So I really can't speculate on what the timing is. I'll just point out that it's a relatively short period of time from today in January.
Okay, what that guy basically just asked is if you're traveling on a road trip and it's going to take 3 hours to get there, what time are you going to get to the gas station? What? Where's the gas station? Oh, I don't know. But when are you going to get there? What gas? What are you talking about?
We have yet to get...
Well, you need to fill up the car with gas, right? Well, yeah. Okay, so what time are you going to get to the gas station? I hope you don't run out of fuel. Like, what?
And understand all of the lessons learned of this and flow that into that program.
What?
It's to be determined. We have to see how this plays out and see how.
Where's the gas station? What are you talking about?
From that review board to see if
is that
there
a
are any
Buc-ee's
impacts
emote
on that program.
Next question is from Lauren Grush from Bloomberg.
Emote. How did you get that?
Thanks for doing this. I'm just curious what the discussions have been like with the commercial payload customers over the course of the mission, especially customers like Celestis, who are...
Why is it that every time I say the press questions have been good, every time I mention that up until that point, every question after that sucks? Is this a slight against me? I don't understand.
They, of course,
happens every time.
Their original intent with this mission, but they also
I'm just
knew
shutting
all
up from
of
now on,
the challenges and risks of a lunar mission and how difficult it really is.
Every freaking time.
I think when they came to the table, they implicitly understood that, but we didn't take any chances, and we outlined and explained all of those challenges and risks as they existed.
Most likely,
and
Gimbal.
To their credit, they still signed up. They flew their payloads. The payloads themselves worked in cislunar space, and throughout that process, it's been just incredibly heartening to see their words of support. Over the course of the mission post-anomaly, we were very heartened to be completing the paperwork for a new payload. So they did not waver. Since then, we've also had additional dialogues with our existing Peregrine Mission 1 customers about flying again and being on future missions. So they're right there with us. They've stuck it out. They have been very committed to seeing this future on the moon a reality, and we are so grateful for their continued support, and we are also very grateful that they're getting usable data.
And a few fun stories that we heard through the course is that there were a few times through the course of the mission that we were communicating with some of our payload customers, and they said, "Stop calling us because we're fielding media interviews," because their country was so excited about it. And specifically, I'm thinking about Mexico and the Mexican Space Agency payload. They front page news above the fold. They were talking about how Mexico had the first instrument in cislunar space of Latin America, and that's a pretty great accomplishment. And it was exciting to see them celebrating that. Of course, we would have loved to bring that all the way to the surface of the moon, and I hope we will on a future mission.
Next up, we have Austin DeSisto from Everyday Astronaut.
Hey, that guy. He's from Boston.
Good afternoon. First of all, I just want to echo what everyone else has said so far. Really appreciate the transparency throughout the mission and for putting this all together and letting us ask questions. My question is really for John. Before launch, we had spoken, we met up and kind of talked over some of the items, some things you were concerned about. But one of the things we did focus on was about success and kind of how you define success and what you see as success. And what you had told me then was that, as soon as you separate, getting communication and orienting to the sun was one of those big, milestones we've made it items. And so I'm just curious if you want to talk through, kind of that beginning phase, which you had mentioned in your introduction, about kind of like how you saw success evolve throughout the mission and, how you were making it just milestone to milestone, trying to keep that spacecraft alive and see more success with it.
Yeah, I appreciate the question and very much appreciated our conversation in Florida before launch. It certainly was an evolving target. We really wanted to land on the moon this time. We really wanted to get there. That's been our company's heart of hearts mission and goal for 16 years. We didn't reach it this time, and that was difficult, and that was challenging to hear that news when we had that anomaly. But what lifted us up is really
it's actually a good question.
Next and all
good job,
of the
Austin.
fantastic work that occurred from there. At that point, we knew we couldn't land, but at that point, we knew we had a spacecraft. We knew we had an orbiter that was in space. It was alive. Astrobotic had its first spacecraft in space, and it was still going. So from there, the mission changed. It was all about keeping the spacecraft alive. It was about once that was stabilized and the life support was supporting the spacecraft, then it became about activating payloads and trying to get as many wins as we can through the course of it, given the anomalies and given the challenges. One thing though that I am proud of is our goal as a company is to make space accessible to the world. And though this mission did not turn out the way we had planned, I'm really excited and proud of the fact that the world followed us and they were with us and they experienced the thrill of the space flight and the sorrow and the challenges and just the emotional roller coaster that goes with that. I'm proud of the fact that people followed along and carried with us, and I look forward to making all of those folks proud of us when we do succeed, and all of the folks that have supported us through the course of this. So it's been quite a journey, and I know it's very easy to focus on the failure and the one thing that failed on this spacecraft, and we're all going to have dreams of that for a long time to come. But there's a lot that worked. And that is something I'm very proud of. The Astrobotic design and built hardware, like avionics and software and systems architectures and other parts of the spacecraft, they all worked. We were getting images and video live back. Telemetry was working, comm was working, power was working, solar panels were working. There were so many parts of the system that worked. So even though we had that anomaly right out of the gate, it felt like we were so close. That's why I really feel confident that the next mission to the moon will be successful. We know what this anomaly is. We have the team. We have the mission control team that can basically handle any stressful situation. And I think if we get a good spacecraft built up, I think we're going to land late this year or with the Viper program.
Our next question is from Jordan Wright, the Angry Astronaut.
Good afternoon, folks. Thanks very much for everything you do. I have a follow-up question.
I'm angrier than this guy.
You said that theoretically you might have been able to get Peregrine either to a lunar impact or orbiting the moon. Now, I understand the problems of having a potential navigational hazard, although there are much bigger pieces of space junk in cislunar space than Peregrine. So I'm curious, what would have been the downside of trying? Thank you.
Delta V.
Yeah, thanks for that question. It was a very difficult decision and very, very difficult things that we were weighing there. We had asked our partners, and our partners at NASA weighed in with their recommendation, and their long storied space flight experience certainly mattered quite a lot in this conversation and the weighting of that. And what they were pointing out and what we were also concerned about was the engines and the fuel system were not in a nominal condition. Because the oxidizer, the pressure was so high and it was in an uncontrolled state, if we burned those engines at any significant length, it's, as the engineers were describing to me, it's basically like an oxyacetylene torch that is more or less going to burn a hole through those engines. So we were concerned about those small but possible probabilities that there's that it would be more than just missing a trajectory or more than just missing the moon itself.
Hey, Rev. What's up, dude?
It could have possibly caused a catastrophic situation that it would potentially create more debris. So those are the factors that were weighed at the time. But it was a very, very difficult decision to make. But ultimately, we needed to do what we felt was right for us, for our partners, to be responsible actors in space.
Next up, we have Mark.
That was an interesting question. We got. I'm gonna pause for a second. We got a little more insight. Like, Angry Astronaut's okay. Believe it or not, that guy knows a little bit, but so it seems like there's a little bit of a misunderstanding there with how phasing burns work. So long story short, Astrobotic doesn't have the thrusters don't make a lot of thrust. They don't make a lot of thrust. It's basically RCS shooting that thing around. So you're gonna go. They talked about doing a low energy transfer out to the moon. What is a low energy transfer? A low energy transfer basically, the vehicle has less delta V, but it's utilizing more of its environment. Think low energy transfers are like the sailing across the ocean of like ship transport, right? Can you have a sailboat with a motor? Yeah, but if you're using the sails, you don't need as much fuel because you're just using what you have around you. Now, there's not wind in space. There's solar wind, but the solar wind isn't enough that we could, like make a sail and sail out to the moon. What you use is the gravwell of each planet, or each celestial body. Use the gravwell of the moon and use the gravwell of Earth to your advantage. Like if you have a funnel and marbles are rolling around the funnel, you can get the marble to accelerate if you kind of rolled it closer to the hole of the funnel. It'll start spinning faster. Same idea. You can use the gravity to your advantage. So now, okay, so what's the downside of doing that? Well, using the gravity to your advantage is good, but once again, like a sailboat, it's going to take a little bit longer. Will a sailboat get to its destination faster than a cruise ship? Probably not. Nope, probably not. That's the trade-off here. With low energy, you're using the gravity around you to get out there for less fuel, right? But you're not going to get there as fast. So it seems like from what the guy was saying there, the phasing burns that Peregrine would have needed to have done to do a lunar impact or get around the moon would have been too high energy of a phasing burn and would have broken the thrusters, basically. Reaction control system thrusters on spacecraft usually need to be modulated, right? So like that. If you just keep one going for a long period of time, he said it'd cut like an oxyacetylene torch. If you flux too much heat into the nozzle, basically fire those engines for longer periods of time, you risk damaging the propulsion systems. So, delta V, basically. You don't have the delta V to be able to do something like that. But that was a better, his update was a little less candid than, or his response is a little less candid than mine. But that's the general idea. All right. Anyway, let's go back.
Hi. Calling from a
nice,
Pittsburgh
Rev. Hell
TV
yeah.
station. So my question is, we're sitting outside Astrobotic Studio here in Pittsburgh, and what kind of work is being done inside now? What are we going to see moving forward here in our area?
Well, literally as...
Are you serious? He just answered that a moment ago.
As we speak, I'm turning around to look through the glass because you're asking what's work going right now. We've got an engineer working on Griffin as we speak, assembling the next lander to go to the surface of the moon.
Right.
And that, of course, can be witnessed right through the glass of our Moonshot Museum for all Pittsburgh and the whole region here. Astrobotic is still committed to the moon, still committed to making the moon accessible to the world. That has not changed. And I mean, I can tell you that we are emboldened by this. We are excited by this. Certainly not the outcome that we wanted, but we're motivated to make it successful the next time. We believe we've learned so much through this process that we truly can do that. And I mean, frankly, it was a fun adventure. It was a really fun adventure, not one that we had planned. We got knocked a curveball right in the beginning. But it was quite an adventure for the last 10 days, and I caught the space bug all over again, and I'm really excited for the next adventure.
It does that.
Next, we have Marcia Smith from spacepolicyonline.com.
Marcia? Where's Jan?
Or maybe we do not. We may have lost you. All right. So
Marcia?
next up we have...
Can you hear me now?
Ah!
Oh, there you are. Go ahead.
Sorry. I was asking Joel if he could just quickly review the CLIPS missions that are scheduled for this year for 2024. There were 6 total scheduled for 2023 and 24, so this was the first of those. Are you still expecting 5 more this year?
It's up to the companies, to update their launch timing based on their readiness with their launch providers. We do know publicly that Intuitive Machines has publicly said that they believe they're going to launch their first CLIPS landing in February. We know that that Firefly is planning to have a launch later this year. We know that Intuitive Machines is planning their second launch later this year, and you also heard about the Griffin mission to land Viper, planned for the end of this year. Of course, what we do is we're watching readiness milestones with our vendors that we've negotiated with them, and of course, the launch date, is one of those things that we watch. But it is their mission. It's up to them. We do expect several CLIPS missions to take place this year. That's probably about what I can say today.
Okay.
All right. Thank you.
Some actually breaking news that we just received. We just received confirmation of the object's decay from the 18th. So that is independent confirmation that the spacecraft did in fact break up over the ocean.
Great. And next up we have Evan Robinson from Pittsburgh Post-Gazette.
Yeah, thanks, guys. It's been an honor to kind of tell the story for the Pittsburgh audience in the backyard. I understand the propulsion system for Griffin is different than Peregrine, and that decision was obviously made before this mission. I've heard, maybe potentially due to supply chain problems. But was that decision to change providers also based on any kind of performance concerns, anything that could have alluded to this valve failure before the demonstration this past week?
Yeah, I could talk to that. So there's a few different things. First is that Griffin is a much larger vehicle, so there's larger engines and larger tanks. It's a larger fuel system than Peregrine.
And larger talons.
Almost about 3 times the size of Peregrine. So everything is different right out of the gate because of that. There are similarities in architecture, though those will be things that we're looking very closely at. There are some similar components. We will be looking very closely at that. The main engines and the attitude control thrusters are different than Peregrine and going to be provided by different vendors than the first one. That had more to do with challenges with vendors in the past in terms of schedule, and also we had a challenge on Mission 1 with performance of the main engines. So it all kind of factored and rolled together. But the new Griffin vehicle will have fresh engines for the mains and the attitude control.
And large talons.
All right, next question is Richard Trevaux from Orlando Sentinel.
Hi, thank you for taking the time. Sort of following up on that, you have Griffin coming up. You've launched Peregrine. I think previously you said that these are basically two items in your catalog now. My question is there signs of cost reduction for production? So would it be, and how quickly would you be able to turn around, say, a new Peregrine style lander or a new Griffin style lander after all of the fixes are in? Thank you.
Well, thank you for that. So Griffin is in manufacturing as we speak. If we were to get another contract for a Griffin program, I think we could be off the ground in about 2 years, maybe 2.5 years in that time frame. So we feel very confident about that if it's very close to a build to print. And for Peregrine, it would be a similar kind of time frame if it's a build to print. And I'm qualifying it that way because frequently what we've seen from the payload community is the payload sometimes will ask for off-nominal or abnormal services, and that requires some more customization. So that customization is really one of the big drivers of schedule for us. So it's really kind of dependent on who's flying with us and how that one's going to be going. But right now we're just focused on our next mission, and business development continues to focus on new opportunities for customers and flights, and we'll of course be keeping you guys up to date on how that goes.
Great. Our next question is from Alan Boyle from GeekWire.
Hi. Thank you. I just wanted to find out if there was any more information about the confirmation relating to the spacecraft's decay. Is it visual sighting of debris, or is it more in the line of some sort of radio sensing of the breakup?
Fair question.
If you have any more details, I'd love to hear. Thanks.
We unfortunately don't have any more details. The 18th just pointed us to a website. What's the website's name?
Space-track.org.
Space-track.org, where they track these incomings, and they posted on that the update for this spacecraft. We don't know how they confirmed it, but they did confirm it, and that's certainly good to hear. And I do, it might be a good, cool branch off point, but I do want to point out one really fun part of this story, is that there were optical telescopes that were tracking the spacecraft at multiple points through the course of the mission. And in fact, we were when we were at lunar distance and assessing what trajectory we were coming back toward Earth with, there were multiple optical telescopes that were reporting that, yes, that we actually see the same thing, that you're on a trajectory to intersect Earth. And I thought it was phenomenal that we were getting that kind of feedback from folks all over the world. And what's even cooler, I thought, was that they were getting pictures. There are pictures of Peregrine flying through space that the optical telescopes have taken. And there were two in particular that I thought that was just really exciting. One of the groups actually took a video, very short video, and witnessed and recorded the very final burn of Peregrine's 5 main engines in the last maneuver that brought Peregrine home safely or brought Peregrine to the safe reentry to Earth. You can actually see the spacecraft going, and it almost looks like it lights up like a Christmas tree light, and that's the main engines firing. And then again, we saw, I think it was in Ken Chang's New York Times article, that he had a link to one of the videos of Peregrine flying its terminal descent down towards Earth, and you can see some kind of, it's either thruster or potentially even the leak itself that you can see. And I think that is just so cool that all these optical telescopes are able to track and see the mission and see Peregrine flying in space.
And we have time for one last question real quick. We have Ryan Ditto from the Pittsburgh Tribune Review.
Hi, yeah. I'm just wondering,
if maybe John can explain a little bit more what like Pittsburgh Mission Control did during this mission, and maybe just elaborate on how they were, I guess, specifically able to kind of help guide this along as it was going.
Sure. Basically, everything that occurred on this mission, after separation from the launch vehicle, all occurred from Mission Control Pittsburgh. It was staffed 24/7. We had shifts of 12 hours of each of our operators going in and out of shift through every single day. It was constantly being monitored. We had a team of orbit determination folks that were constantly receiving updates, giving us updated trajectory information live. The team was also coordinating with engineers that were on site working in our flat sat room, which is where we have a copy of the spacecraft, so we could execute test commands and make sure that it all worked. They were also reaching back to the engineers who had built the spacecraft at different points to get all of the available data to make the best, most informed decisions at any point during the mission. But Pittsburgh Mission Control was live. It was working great. And I'm very, very, very proud of the team that executed the mission.
So thanks to everybody for joining us today to discuss Astrobotic's Peregrine Mission 1. We realize there were a lot of participants on the call today. Thank you to everyone who submitted questions.
The astrobotic engineer, when he realizes he recognizes the problem, sitting at home watching TV, he would, oh, I know what's wrong. I'm going into work. That's awesome, man. Really cool mission. What's the status on it? The Peregrine lander? Oh, it's dead. Gone. Reduced to ashes. So, yeah, that was the end for the Peregrine mission. Actually, there were, there were pretty good questions. Some of those questions were...
Discovery, go at throttle up.
Yeah. Hey, Hooded, 31 months. Timberboard had another big update. I know, they actually emailed me about it. And I saw it in my email this morning. It's dead, Jim. Yep. Want to see the Loch Ness Monster? No? Oh, dear. Yeah, no, I'm good, Forge. Apparently Slim required a slope landing to reach certain spectroscopic interest regions. Why would it have been impossible to do this on non-slope terrain? They're trying to land on the rim of a crater. It's probably the regolith on the rim of the crater that they specifically needed for whatever they're trying to do. There's a smoker in Icarus now too. Cool. Have the deepest respect for them. Yeah, man. A little company from Pittsburgh just showing what's good, dude. Kind of wish they would launch another one. I kind of wish NASA paid them for multiple missions. They're upgrading straight to the Griffin lander, but... The Griffin lander is awesome. For the Viper mission, that mission, the one that they have scheduled in November... That's a cool mission. Griffin is a really, really interesting lander. This is a render from Space News. That's the Griffin. That's a render of it. Viper is a lunar prospecting rover. It's trying to find ice. We're pretty dang sure we know there's ice at the south pole of the moon, right? But like water, right? But this thing will specifically go and find it. That's what that mission is in November of this year. Hey, Rocket Guy, what's up? So, Griffin, I mean, it's not the biggest lander, but it's pretty big. That thing, I think that thing's the size of a go-kart. If I'm remembering right, could be pulling that out of my tail. It's, I don't know. Griffin shrugged. No, those are tracks. It'll open so the rover can roll up and roll off onto this thing. Yeah, Earth for scale. Yeah. So that's actually going to be an awesome mission. But it seems like they had a valve. Something went wrong with the valve. It didn't seat correctly. Yeah, that kind of blows. Like a lot. But hey, one engineer recognized the pattern in the behavior and came in and actually fixed the thing right before they lost signal with it, which is super freaking cool. That's really, really cool, actually. That's some John Aaron stuff, man. You guys always know when I talk. You guys know when I talk about, like, you know, there's knowing how to get to the moon, and then there's actually going out to the moon. This is the kind of stuff we need to be doing. This is the kind of stuff you got to learn about. You got to learn about how to troubleshoot these problems and figure them out, right? This is the stuff we need to be doing. Yeah, it sucks that Peregrine didn't make it, but you can be dang sure if they had another one teed up and ready to go right now, it would get there. Absolutely. It would at least get near the surface of the moon. They wouldn't have that problem again. Right? This is what I mean. You have to have that operational experience. And sometimes, from that operational experience, failure teaches you the best. You ideally don't want to get failure during operational missions, but nothing is ever going to go exactly perfect. You're going to get curveballs. Now, think about how nutty it actually is, right? That, like, if you go to the Apollo missions, I mean, you guys have seen kind of firsthand what a spacecraft malfunctioning, like the problem with a spacecraft malfunctioning and how big of a deal that actually is, and how much of a pain in the butt is to go and troubleshoot, and how much, like, can we salvage a mission? What can we do? Think about that. Think about Apollo 13 now, and how ridiculous Apollo 13 actually is. Or was, I guess, right? If you had the opportunity, would you go to the moon or take a one-way ticket to Mars? Robot, I've always said that I will... one-way trips... I think one-way trips are only warranted when I can land on Mars and stop at a Dunkin' Donuts, Space Dunkin' Donuts, and go get myself a coffee because I've been on a long trip. I don't believe in one-way trips. Unless... Even a one-way trip, you should have a viable way back. I would go to the moon over Mars if I had a way back. If it was a one-way trip to Mars right now, yeah, you're probably gonna die, you know. But anyway, did they make the valve or did they buy it? It seems to be from a contractor, Jack. Slimlands is covered from the beginning of the video. I got you, Lofty. Yep. I don't think one-way trips is space colonization. That's not right. Even when the Pilgrims came over, you know, to the North American continent, and the Vikings before them, they always had a way home. You know, the Mayflower, like, they didn't... I was going to say they didn't take it apart and use it to build things, but they may have done that. But you get the idea. It's not like you didn't have an avenue home. I think in spaceflight, not having an avenue home is a death sentence at this point in time. You'd get a one-way ticket, not a one-way trip. That's the right... Yeah, that's a good way to say that. Shipyards that the Navy uses are having the same problem with valves. Cactus, in that regard, we're seeing the fruits of eroding away our industrial base over the last 30 years. We'll see more fruits of that labor as time goes on. But, you know, they can make it for cheaper over there. Right? Establish the first cemetery on Mars. Yeah, I don't want to do that. I don't want to be the one that does that, you know what I'm saying? Any games today? Yeah. I figured we'd start with space news because the Slimlander and because of Astrobotic, but I think I'm actually, yeah, I think we should go games. In other news, the asteroid sample has been revealed. Yep, they got the container for the OSIRIS-REx mission fully open, and NASA released a very, very beautiful high-res picture of that today. That was the next thing I was going to share, but yeah, that picture right off the archives is actually very... Oh, that is a huge picture. These are samples from an asteroid, particularly the asteroid Bennu, which is where OSIRIS-REx went and plucked a sample off of it. Space rocks. Look at that one. Interesting. Metallics. I mean, I know, I get it, but see it? Look at that. I wonder what kind of metal that is. See these sparkly ones? Interesting. I'm no geologist, but when you get rocks like this, it's usually...
Discovery, go at throttle up.
Like, take like granite, for instance, like the rock. Not taking things for granted, right? Granite is an amalgamation of a lot of metals that were forged basically because of volcanic activity on Earth, right? I mean, amongst other things. I'm seeing a lot of metallics embedded in these things. Nice pun. Oh, I hate you. Hey, Klavic, 74 months. You could tell they're rocks because of the way they are. It's pretty neat. What's up, man? Can I eat it? You could. I don't know why you'd want to, but you could. You could. Don't take the sample for granted. Yeah, see? Look at that. I wonder... See, that one's super different. Why? Why is it super different? See, there's embedded metallics in some of these rocks. I don't even know if embedded metallics is the right way to say that. It's probably not. See, all this makes me... What the hell is that? Oh, okay, that's the post. That's one of the Tascam holder posts. I was like, what rock is that? It's not. It's metal. Yeah, see. Yeah. See, some of these have metals in them. I wonder what kind of metal. It looks like coal. Well, they did say that there is carbon on this asteroid, but that's not anything that we didn't know. Carbon is everywhere. It's that whole carbon life thing that we gotta kind of be wondering about. If I'm remembering correctly, I mean, carbon, every life form on this planet is carbon-based. We are ants, insects, whatever. Without carbon, I mean, it's a pretty abundant resource. That's what I'm trying to tell you. Plot twist. EJ's trolling us by setting up crushed Oreos in a mocked-up pot in his garage. No. If you sell all those rocks, how much do you think you'd get with all those metals? I don't know. 7, go to the beach, pick some rocks up off the surface, and then sell them. See how much you get. I'm pretty sure you don't. Not much. Forbidden cookie. Some of those are chonkers, yeah. So they did confirm that there's carbon in that asteroid. They confirmed that from their initial samples because they got more. Some of the rocks got jammed in the sample grabber and didn't get all the way put into the container, right? So they ended up getting a lot more than what they thought. And NASA also confirmed that there is the building blocks for carbon-based life on this asteroid. That's not that... When they confirmed that, that's not that crazy of a breakthrough. Like I said, that's... You know, if you're standing on the beach looking at an ocean, that doesn't, it's like, oh yeah, there could, you know, water. Things exist in water, so there could be life in there. Like, well, yeah, we know there's fish in there from, like, actually going out and in it. But if you're standing at the ocean, do you see a damn fish? No, you don't know. Like, that, just because there's an ocean, so to speak, just because there's carbon in the building blocks for life on this asteroid, on Bennu, doesn't mean that there's actually life there. That's not anything we didn't know. Yeah, Slump, it's been out there for a hot minute, as the kids say. Yeah, caveman, maybe. Yeah. Mm-hmm. Didn't they measure the surface composition while they were orbiting it? They did. They mapped the asteroid Novus. I'm not sure if surface composition was necessarily analyzed. I don't remember all the specifics of that mission. The amazing thing is that we actually flew to an asteroid and sampled it and then returned it. Yep. Start building our space colonies out of pewter, just like the Romans. Psyche's made up of lead and mercury. Nice. Nice. Pewter. Yep. You want to meet an alien. Okay. All right. Is this the first case of theoretical asteroid mining? Yeah, kind of. But no, that wasn't really a mission goal. Mission goal is understanding, like figuring out what the heck the thing's made out of. The Psyche mission that Hallie referenced there is probably a lot more in line with what we're kind of thinking. Psyche asteroid is made out of rare earth metals. We're pretty dang sure. But, I mean, we're not going to know until we go and figure it out. And then there's also the Lucy mission, which is inspecting the Trojan asteroids, which are asteroids that are caught in Jupiter's L3 or L4 and L5 Lagrangian points. Yeah, that's actually a crazy mission too. Yeah, prospecting would probably be a more appropriate term. Oh, boy. Or surveying, maybe. Okay. Why are aliens mostly imagined like creatures similar to human beings, like have legs, arms, and heads? Because in the movies, you have to convey a medium somehow. And if the aliens are unrecognizable, the viewers have a tough time understanding what's going on. That's more of artistic license than anything. Ugh, get it off! Hell no. Hell no. I ain't doing that. Be jelly. Robot, I'll give you another example. People have to understand, like, when people are watching, you can't convey something ridiculous. Like, say the alien was just a blob of jello, right? If you just introduce the blob of jello comes up and it's just like, right? Like, people are going to be like, I don't know what, is that an alien? Or are we supposed to be in danger or something? Or if the characters give some kind of exposition, oh, those jello blobs, don't get near them. They look like jello, but it's not jello. If it touches you, you die, right? Like, then you got kind of an understanding, right? But, you know, most of the time, they don't explain this to keep like in thriller movies where there are aliens, they don't explain what they look like to kind of keep you on your seat, at the edge of your seat, right? And then you see them, and if there's no exposition to why it looks like a giant puddle of poop floating around, you're just going to be really confused. It's more for immersion than anything. But that's like totally a creative license there. I can give you another example. So take a movie like The Fifth Element. The Fifth Element takes place way far into the future. Right? We have in The Fifth Element there are cars that can like hover around and stuff, right? If that's the case, why do they basically resemble a car with no wheels? See what I'm talking about? Is a flying car gonna look like this? No, probably not. But if you didn't make the flying cars look like somewhat resembling a car, people are gonna get confused. People aren't gonna understand what's going on. Right? That makes sense? Multipass. Like, there is some artistic license, right? Obviously, but it's very easy for a viewer to understand that those are flying cars. They're flying around and they look like a car. See what I'm saying? Yeah, this is like on the continuity thing that I like talking about in film, right? This is kind of part of the stuff that makes The Fifth Element so ridiculously good, right? And this is the reason why, you know, movies that immerse you, it's little stuff like that. Little stuff like that, it really drives the story, right? Because you don't get distracted. You understand that that's a car, and you understand that it flies around. Pretty straightforward stuff. There's no, you don't need to sit there and be like, wait, what the hell is that? And that keeps the continuity of the story very straightforward, right? The Fifth Element arguably has a very complicated plot, but it's a very easy plot to understand, right? Means he's a car thief. Blast him. Little stuff like that in continuity in film is what separates really, really good movies from okay movies to like really bad movies, you know? Is Fifth Element where the dude has a wall panel on his head? No, take it. I don't need it. Yeah. Mm-hmm. It's a really nice hat. You like it? Ah! The new Adam Sandler movie is going to give me the creeps. They made the alien look like a spider, therefore all spiders are aliens. Mm-hmm. 4 stones, 4 crates. 0 stones, 0 crates. Yeah, exactly. Like, I can give you another example. Yeah, I'm rewatching. It's fresh in my mind, so Brimo's never seen Breaking Bad, but we're rewatching it right now. There's a lot of stuff in the background of Breaking Bad, and this is no spoilers or anything. There's a lot of stuff in the background of Breaking Bad that sets the tone for the scene that you just don't. You look at it and it's not a problem. Like you get it. You get what's going on. I'll give you an example. So like when a scene needs to be set and you're trying to discern like what time it is, like where the scene is, right? The cinematography in Breaking Bad and the set designers often have a clock in the background. You know? There's a clock in the background. So, like if, you know, in Breaking Bad, if Walt's waking up. This happens every time you see a character in a bed in the show, or you see a character sitting down and eating breakfast or something. There's always a clock in the scene. And there's always a clock that's very, very prevalent in the shot. The reason why is because instead of having some text pop up like Monday, 3:05 a.m., right? It'll be a scene that is dimly lit. You can tell it's dark, and the clock says 3 a.m. The scene, the cinematography directly sets the scene without anything being said, and that allows you to more easily understand what's going on. That's more of a cinematography thing. I know all about that. That's the kind of stuff I went to school for. I'm really good at that. Yeah, I think that's, like, once again, that's what separates really good film and really good cinematography from not good film and not good, or just okay stuff, right? Like, cameras, lighting, set design, that's all, it has to be something that people understand. And if you can the more that you can convey with less exposition, I think the better it is. Yeah, Gilligan's amazing, dude. Yeah, Vince Gilligan's fantastic. I mean, the plot of Breaking Bad and Better Call Saul are fantastic. They're just great scene. Great scenes. Like, just everything. It's just really, really well done. I mean, Fifth Element's the same way. Like I said, Fifth Element has a really complicated plot, but most of that is subconsciously kind of conveyed to you so you understand what's going on. Do you remember the final shot of Breaking Bad with the slow zoom? That's a direct homage to Scarface. There's a lot of references to Scarface in that show, Grav. We're rewatching it. I don't want to talk about it just in case Brimo's watching this, right? I've noticed a lot of references to Scarface. I've noticed a lot of references to Goodfellas. There's a lot of references to just all different types of stuff, man. There's, like, the characters referencing different shows. Yeah, there's a lot. There's a lot of, dude, like, that's what I mean. Every scene you could sit there, like almost every scene in that show, you could sit there and analyze it. That's why people like it so much. How would you do the starts in X time, then moves to current day? How would you smooth it out? Oh, that's an easy one. If I want something if I want to set a scene for cinematography, zombie, in the 80s, show a car. Done. Easy peasy. Or maybe you have your protagonist listening to a Walkman, for instance, right? Nobody in the 90s had a Walkman. They had a CD player. Nobody in the 2000s had a CD player. They had an MP3 player, right? Or a phone, right? You see them pull a big brick out of their freaking bag, right? That tells you that it's the 80s, right? Yeah, Grav, I'm rewatching it. We haven't gotten to the end, so I'm just going to click that and not read it. I'll read it later. I'll read it when we're done. Computer monitors, television, cell phones, just regular phones. You can often set the time and place for a scene a lot. Now, actually, another show that does that really, really well is Mad Men. If you guys have ever watched that. Mad Men sets the scene and sets the date, not by a clock or anything on it, but what the characters in the show have on the television or the radio in the background of said scenes. Really cool way to convey settings. Yeah. Mad Men does that a lot. Rewatch Married with Children age perfectly like fine wine. Nice. Bro, you've seen it, though. Grab Shark, I watched Breaking Bad basically right when it came out, and a lot of the stuff, I've forgotten a lot of things about it, to be honest with you. So, I know I've seen it. I know the end, but I want to re-experience it, because dude, a lot of the things I forgot. Yeah. But yeah, that's what really separates, like, good film from great film, and part of that is making... Like, if you're making Aliens, part of that is making the aliens somewhat recognizable, you know? Nah, not really, Stuart. We'll figure out what we want to play. Yeah, it's... Grab Shark, I'm far enough out that, like, I remember the main details of the plot, but there's a lot of small things that I missed completely. Just played a $10 scratcher, won $150. Sending it with Geek for the Bucky's addiction. Nice. Nice. Yeah. It's good stuff. A lot of time and planning goes into that, dude. It's not just, if I want to make I want to make a movie that has a scene in 1987, right? Okay, so we'll have some cars from the 80s. You'd be surprised how crazy some set designers actually get with continuity and stuff. And you know, guys, I'm a sucker for that type of thing. Like, you know, if I see a scene and it's supposed to be in 1987, and in the background you see a truck from 1993, I'm like, what the hell? I mean, that's just the kind of stuff I'm a little retentive about, right? Like, or, hey, Faze, what's going on? Or if you, like, if there's a scene that takes place in, like, 1986, right? And, you know, guy pulls out a car phone from the 90s, I'm like, wait, what? What? Oh, that's cool, Jonathan. Neat. Bucky's is a cult. Change my mind. You can't. That's a fact. How would you know? You've never been. Geek is a Bucky's virgin. Oh, jeez. Oh, jeez. Like, there are some scenes in Mad Men where... I can't explain... no, never mind. I can't explain that without giving it away, just in case anybody hasn't seen it. Yeah. Damn. The Irishman did it well. They put a lot of work into the aging and de-aging to make everything look period correct. The Irishman is a Scorsese flick, Wertheim. Martin Scorsese is obsessed with doing stuff like that. Yeah. He's a real anal retentive guy when it comes to that kind of stuff. Like, I don't know him personally, but I've watched a lot of his movies. Continuity is super important like that. Stanley Kubrick, same way. Same way, dude. He was very obsessive about this stuff. Like, in, like, Full Metal Jacket, you're not going to see anything on the soldiers' uniforms that wouldn't have been out of place in Vietnam. Yeah. Oh, yeah. Scorsese, Kubrick, just absolutely insanely good directors. Coppola before Scorsese, so the guy that directed The Godfather. Yeah, it's that kind of stuff that really drives the point home. You see that new Scorsese film? No. Well, I know 1970s cars in the movies set in the 1980s. A lot of people had beaters from the 70s and the 80s. Yeah, Serge. I mean, that's dude. The cars are something that will immediately take me out of the scene. I'll be like, what? Why do you have what? That's not right. Like, sometimes what you're saying is right. Like, you know, you see movies that are set in the 60s and you see some cars from all just cars from the 60s, right? Not everybody has a new car. That's an important thing to understand. In shows like Mad Men, you see people driving around cars from the 50s, even though Mad Men primarily takes place from 1960 to 1970, right? There's still cars from the 50s driving around. We didn't just throw them all away, you know. I agree. Mm-hmm. Also last. Okay. Do you play more KSP1 or KSP2 nowadays? I try to split it up. They contracted Kubrick to do... Yeah, exactly, Tessa, yeah. Mm-hmm. Hot take, Godfather is one of the worst movies I've ever seen. I've tried so many times, it just sucks to you. It's not the theme. I love The Sopranos and stuff. Godfather is just incredibly boring. I've tried so many times. I don't really have much to say. What about Goodfellas? Goodfellas? Honestly, I never cared for those movies either. Interesting. Oh no. Huh. People have different tastes in movies. Grab Shark, you know, the plot of The Godfather, yeah, I get it. But also at the same time, The Godfather is, I think one of the reasons why it's arguably one of the best movies ever made is because of that cinematography continuity stuff that I'm talking about. Like, this is the kind of stuff that I look for when I watch a movie, you know. Is everything right? Is everything in the right place? How is this scene lit? Why is this scene lit the way that it does? Like, I you know, once again, went to school for this stuff. So I can kind of see behind the scenes, you know what I mean? Like, why did you choose to light that way? What are you trying to convey? I found that the best movies use shading and lighting in the scene to convey the mood and attitude of said scene. With that being said, Godfather, every scene in every single one of them is like that. Every single one. You can figure out if it's something bad's about to happen or something good's about to happen just by the lighting in the scene. That's what makes that movie so freaking good. I mean, the plot's okay. The plot's pretty damn good, like, if you ask me. But that's why that's regarded as one of the best, like, movies all around. 2 is even better. I don't look for that stuff until I watch a movie the second time. The first time, I like to engross myself in the story. Well, Unity, I would make the argument that stuff is what engrosses you in the story. You know what I mean? Basically, if you don't see anything out of line, you're going to be more immersed in the story. Which is why, like, certain things can't be distracting. Like, once again, I'll use it as an example. The cars in The Fifth Element, they look like cars with no wheels. There's a reason for that. So people can understand that is a car, even though it flies. And even though a flying car should theoretically, by design, look nothing like a car that rolls around on the ground. But they still are. That's the kind of stuff that makes sense. You don't even question it. You don't even question, oh yeah, it's a car that flies. You don't even question, there's no need to. You know what I mean? Because it was really, you could see how well thought out that is. Fast and Furious Tokyo Drift is probably the best movie lighting of my lifetime. What? Yeah, Northern, we did talk about it right at the beginning of the stream. But thinking about how good or not it is takes focus away from the story. That's not. I guess I understand what you're saying, but also that's not how I watch movies. Did you see Death Proof? Yes. Mm-hmm. Yeah, Death Proof is Tarantino and Robert Rodriguez. Those, yeah, good flicks. They were trying to do the Grindhouse pictures, the Grindhouse double feature, 2007, baby. Good stuff. It's subliminal in a way. That's what makes a good movie, where you don't even think about that. You don't even question it. What are your views on the shaky cam? It always makes you sick. You're talking about Bourne Identity, Serge, right? You're talking about Bourne Identity? Paul Greengrass with the shaky cam during the fight scenes. So what he's trying to do is convey the chaos of the actual fight by introducing crazy oscillations into the camera. It's a cool idea, but also at the same time, you can't see what the hell's going on. Yeah. Now, with that being said, there are other ways to convey chaos of scenes from cinematography. Like, there are other ways to do it. Transformers is the worst for this. Oh, yeah. Don't even get me started. Yeah, there are other ways to do this. And, I mean, if you guys want to talk cinematography, there's other ways to convey the chaos of the scene or a fight scene without hang on, it's just getting a little toasty in here. There are other ways to do that without shaking the camera violently so everybody in the audience has an epileptic seizure. minimal shakiness, like just like someone is holding the camera and kind of taping it. So like you have a cameraman that's on their feet, right? You know, with the camera doing this, and the natural shaking that you get from the cameraman moving around, right? That's going to get you the right amount of shake. The other things that you can do, you could have it on a dolly shot, right? So you have dolly shots, you have a camera that's on railroad tracks, basically. But that camera is on a gimbal and you can turn. Sometimes taking the camera and turning the shot so it's a little bit angled, right, will help convey the chaos, right? There's many ways to do it. It depends on how you're doing it. But generally, like, I think like if it was me, I would do what I just told you. A cameraman with a non-stabilized camera, using your feet, making it seems like you're walking around with the fight, right? Because that'll get you the perfect amount of shakiness, right? You see movies do this a lot. Certain movies, I'll give you actually a good example. And this isn't like a movie with the best plot, but you guys ever seen Crank? The movie with Jason Statham? It's actually a pretty good flick. The cinematography in it is pretty insane. But the cinematography in it is insane because the whole movie is ridiculous. So in Crank, it's this movie, by the way. Here, let me just get you a picture. In Crank, Jason Statham does a lot of running around. Let me put it to you like this. He does a lot of running. So to help convey the ridiculousness of him running around, like I won't explain the plot too much, right? If you haven't seen it. Long story short, his character has to walk and run. Well, not walk. He has to run around. Like, he can't necessarily get a car. So he has to run everywhere, right? And for whatever reason, he needs to get his task done in a certain amount of time. So it's very chaotic. So what they did basically was the director basically took a camera with a handle, and in the scene when he's running, he's just holding the camera running next to Jason Statham. So the camera's like, and the camera's turning and panning up and panning down and panning left and panning right. And it's totally over the top ridiculousness, right? Similar to the shaky cam from like Transformers or a Bourne movie. But in that particular context, the shaky cam works. It's supposed to be like that. They also use varying focal lengths to get a lot of fisheye lensing in some of those shots too, to just kind of convey the ridiculousness of a scene. Oftentimes when there are drugs involved in the movie, right? But oftentimes when a character is having some type of emotional event, or like, for instance, a character takes some type of narcotic or whatever in a movie, they use varying focal length on the camera to get the scene to go from, you know, like the background is flat, to get it to go like to get a fisheye lens to convey the whoa, I don't know what's going on here. They'll often utilize a zoom and a focal length change at the same time. Simultaneously, in movies as well, you guys have seen this. You've seen this a bajillion freaking times. You don't know that you've seen it, but I'll tell you. Simultaneously, sometimes in cinematography, if a character receives a bit of like terrible information, and this gets used all the time, it gets overused in my opinion, but say a character's on the phone, right? And the character's like, gets delivered some bad news. So, hello? Yeah? Oh no. Oh, that's not good. Oh, yeah. Oh, okay. Thanks. Bye. Yeah. Yeah, no, that's... All right, yeah, no, I appreciate you telling me. All right, bye. The camera will zoom in as they're receiving that bad information. Happens all the time. Every time. Slow zoom. That happens all the time. Oftentimes they could change exposure to change lighting too, but that happens all the time. I'm telling you, you've seen this. It happens in every scene. They never say bye in movies. Whatever. I just saw Poor Things, and it does this very well. The beginning is super disorienting with fisheye views. Yeah, cinematography is cool, dudes. That's something that I really enjoy. We don't get to talk about it too much, though. But yeah, it's a pretty cool conversation. Not realistic, you said bye. Oh no, bad news. Phase, it happens. Every move, dude, all the time. Everything. Or a lot of the times what they do now is when a character is delivering a certain bit of important exposition, they'll zoom in. They'll zoom in on the character. I don't know, man. It's a good way to do it, but I think that's just generally overdone. Now, with that being said, that doesn't really happen in Breaking Bad a lot. Like when Walt's on the phone, it's usually an already zoomed in shot, and sometimes it'll zoom out, right? Clear some B-list movies and have night streams with the same style as your space news segments. Oh dear. I would love to watch Tremors with you guys, but even getting the rights to show a little bit of those would probably be astronomically expensive. Believe it or not, the first Tremors has some pretty damn good cinematography. The reason why is because it's a B-list movie, and sometimes you can't really afford... Like, obviously, they couldn't... the graboids, they never could afford to show the entire graboid just going around, right? But that's what actually ends up making that movie, like, super freaking good, dude. Because you only see little bits and pieces of the graboids. Now, you compare that to later Tremors movies when they had a little bit more budget, and you see something like that, and that just blatantly looks like they superimposed a 3D character onto a Volvo. See what I'm talking about? How about that long single shot no cut in 1917? Goodfellas has a scene like that too. Yeah, those are cool scenes, dude. Yeah. So in 1917, you see, Grabshark, those are cool shots, and they're insanely hard to do. Those are called no-cut shots. So there are only certain times where that type of camera work is kind of warranted, right? Every style of shot, like a shaky cam or a pan shot or a tilt shot or a dolly shot, right? Those are used to get you a certain result. Now, in 1917... I think it's amazing. It's an amazing use of that because they're using that uncut shot to convey the labyrinth that is the trenches in World War I. That's cool. That's why that's so cool. That was a really, really good choice for that type of cinematography. Doing an uncut shot for like 2 to 3 minutes walking through the trenches. It's designed to convey the labyrinth and how confusing the trenches could be for somebody that wasn't familiar with them. Really smart use of camera work. Now, they use that shot in Goodfellas when Henry Hill and his wife, Henry and Karen Hill, are going into a comedy club. The reason why they use that is to show that Henry is connected because he gets to bypass the line, and he enters the club through the kitchen because he's connected. He's well known. He knows everybody because he's a union delegate. You know what I'm saying? That's really smart. It's a really cool way to convey that Henry is a really, really important person in this hierarchy of crime structures. They use that in the Extraction movies. I don't remember Extraction off the top of my head, Wertheim. But I know another movie that uses, I call them labyrinth shots, just because 1917, they convey the labyrinth of the trenches. Children of Men does that, which is an extremely underrated movie. Children of Men uses a long uncut shot to convey the chaos that is warfare. Yeah, really smart camera work. The Goodfellas shot is one of your favorites, all the interactions he has. Yeah, exactly, Aqualix. Henry wasn't a made guy, right, per criminal standards, or per organized crime standards, right, in the movie, but he was very well connected, and that's what that shot conveys. That's why Martin Scorsese used that shot in the first place. It hit perfect, you know? He enters through the kitchen. He enters through the back. Because he can enter through the back, because he's a well-respected guy. He enters through the kitchen. He knows everybody in the kitchen. This guy's really hooked up. It sets the scene perfect, dude. It's perfect. That's what I mean. Scorsese is obsessive about that kind of stuff, which is cool. That's why he's so damn popular. 1917 does that really well. Exactly, Hellfish. They use a long uncut shot to, once again, convey the labyrinth of the trenches. Smart. Really smart. That's a really good use of doing something like that. Now, I can give you an example where, and once again, this isn't like, I'm not trying to dump on anybody, right? But there are shots in like Michael Bay movies that I just don't generally understand why that type of shot was employed. But it is cool from a technological perspective. Michael Bay is notorious for having a camera that's on a 360-degree dolly almost, right? So there's a scene in Bad Boys when, you know, where the two main characters, Will Smith and Martin Lawrence, are in some guy's house, right? And they're in a room with two doors to the next room, and the camera basically is on a 360-degree track, and it goes through one of the doors, and then there's a wall, and on the opposite side of the wall, there's the bad guy, right? And the camera just keeps going back and forth and back and forth and back and forth. I'm not entirely sure why you would do something like that for that kind of particular shot, when a perpendicular isometric shot would literally do the same thing. But then again, it's artistic license. There's no... With cinematography and with arts, there's no, like, it's not like engineering where you're like, oh, that's not as efficient. If we're trying to do something efficient, why would you do it less efficient? That doesn't make any sense, right? Like, it's not as cut and dry, but I think that could have been conveyed a lot simpler without having to have a camera that pans around on a 360-degree, with a 360-degree dolly shot. That shot gets used in Transformers as well, when the two Transformers are fighting around the red convertible car, the old Impala, the two Transformers are fighting around it. Yeah, that same idea, but that's also Michael Bay as well. Should we switch out of science and technology? It's the science and technology of film. The latest John Wick. John Wick's cinematography is good, Smirks. Yeah, the cinematography is enough to convey the chaos of the scene, but also without the really ridiculous shaky cam stuff that's going on.
Discovery, go at throttle up.
Hey, Bird Dog, Tier 2, 63 months. Thank you very much. I find Michael Bay's movies unwatchable because of the camera work, but not in The Rock. The Rock is a great movie, dude. That's actually a really good flick, if not a little ridiculous. I think The Rock is a good movie. Michael Bay directed The Rock, yes. The AC-130 scene in the first Transformers is one of my favorite. Yeah, bring the rain! Yeah, that's pretty cool. Now, the first Transformers... Dude, I said it in 2007. Michael Bay directing a Transformers movie, that's perfect. That is what you want. That is exact... Yes, that's... Yeah. Mm-hmm. Your best. Losers go home and whine about their best. Winners go home and get the prom queen. Carla was the prom queen. Speaking of films, has there been any good sci-fi thrillers lately? I've been looking forward to something new to watch. I haven't seen much. The Transformers movies are good for the same reason that Top Gun is good. I mean, you want to talk cinematography, take the Top Gun Maverick. Amazing piece of film. Because they figured out a way to get a camera stabilized inside the cockpit of a fighter jet that's doing 4G plus maneuvers around. And all the actors and actresses are actually in the freaking planes. Dude, they didn't even do that for the first Top Gun. The first Top Gun, in the first Top Gun, when they're training at actual Top Gun in the movie, the Navy okayed a shot of it with an F-14 and an A4, right? And with the first Top Gun, they had one scene where those two planes dogfight around, and they just shot that same scene from a bunch of different angles, and they use a different angle from the same exact fight every time to make it look like different fights. But in reality, you're seeing the same flight of that A4 and the F-14 dogfighting. They only did one dogfight. And they, once again, shot it from different angles. And then the rest of it, Maverick and Goose flying around is just on a soundstage. But it works. It worked. It worked just fine. That was pretty cool at the time. Right? I mean, once again, Top Gun Maverick just completely blew it out of the water. They put actual cameras on actual fighter jets and put the actors and actresses in them. So when you see them flying around and pulling those G's, they're actually pulling those G's. The reason why is because that would be extremely difficult to fake that. Extremely difficult. I mean, at what point are you trying to emulate flying around on a fighter jet so much where, it might actually be cheaper to just figure out a way to put a camera on a fighter jet and just do it. Apparently they're trying to make a third movie focusing on Rooster. Interesting. I mean, Maverick is amazing. That's easily in my top 5 all-time movies. It's so freaking good. See last. I don't see... Oh, you didn't tag me. Whereas yeah, get permission from mods to post a link. Why film umpteenth different scenes when you can film one from a dozen angles instead? Not only that, fighter jets cost a lot of money to operate, Tessa. Yeah, those are expensive. To be honest, I've not really enjoyed many films since 2000. Maybe a couple that Denis Villeneuve directed, that's all. You know what movie that came out relatively recently? That's not necessarily a thriller, I guess, but it kind of is, that I really enjoyed. Bullet Train with Brad Pitt. Yeah, that's actually a pretty good movie. Yeah. It's pretty good. I didn't mind it. Yeah, Bullet Train was a good flick. That came out, it came out in 2020, I think. Yeah. You're Diesel. You're Diesel. We got a Diesel who's been running up and down this train the entire time. Yeah. Yeah, Bullet Train was really good. My favorite part is in the end. Do not call me bro! Okay. Is this a sex thing? Yeah. I like Bullet Train. I thought that was a good flick. It's a little weird. It's a weird movie, but once again, it's a movie that exists entirely on a freaking train. Like, I don't know what to tell you. Okay, bro, chill. Do not call me bro! Yeah, I saw it, Tessa. Thank you. Yeah, Serge, they explain that he's still flying and hasn't been promoted because he's arrogant, which, yeah, all right, that makes sense. But see, here's the thing. Like, in movies that are purposely over the top, I don't look for, like, plot continuity, right? Like, it's like, that's like trying to find meaning out of Bullet Train. It's just a fun movie to watch, and the plot's straightforward enough to figure out what's going on. I think it's cool. Like, Bullet Train is really ridiculously unrealistic, but once again, they kind of set that standard. AKA Spaceballs, yeah. Isn't it good to have weird films sometimes? Yeah, of course. And this is what I mean about continuity of film. Like, Spaceballs, you know it's a ridiculous movie. You're not going to expect orbital mechanics from a movie like Spaceballs. That is quite literally explained in the first 30 seconds of the movie, where the spaceship just keeps flying through the damn scene. It just keeps going and going, and then it has a bumper sticker on the back that says "We break for nobody." You immediately understand that this movie's supposed to be ridiculous and over the top. The first 30 seconds of that is the premise of the entire movie. And that's what makes Mel Brooks so damn good. You're expecting ridiculousness right from the start. They've gone to plaid. They must got hyperjets on that thing. What do we got on this thing? A Cuisinart? No, sir! What's better, Spaceballs or Blazing Saddles? I like Blazing Saddles, but I watch Spaceballs more. Check, please. Yep. Ace Ventura. Ace Ventura's a pretty damn good movie. But it also sets the scene for being just absolutely insane from the HDS. HDS coming through! Got a package, people! It kind of explains Ace Ventura's character, that he's willing to go completely over the top to figure out these pet detective cases, right? And it shows that he's very unorthodox in his actions, but he gets work done. Once again, the entire premise of the whole movie, in the first 3 to 5 minutes, that is using exposition and plot to explain character's background without actually explaining a character's background. Where the hell did Ace Ventura come from? I don't know. Florida? Makes sense. Ventura. Yes, Satan? Oh, I'm sorry, sir. You sounded like someone else. What's the matter, Colonel Sanders? Chicken? That's, dude, so funny. You think we're being too serious? Comb the desert! Real talk, though. Laces in or out? Laces out, dude. Out. All the time. No, like, okay, Smirks, in real hand egg, laces out. Every time. Yeah. I don't think I know a kicker in the NFL that punts and or kicks laces in. Somebody might like that, but we ain't found snot. Airplane's great. Yeah, and airplane, like, once again, it's explained in the first, like, 30 seconds or like first couple of minutes of Airplane that it's a ridiculous parody movie, in case you didn't get it by looking at the trailer looking at the trailer or looking at the poster of the movie. Right? Oh, look. They're little footballs. Laces out. Dan Marino should die of gonorrhea and rot in hell. Would you like a cookie? It's like, what? Oh, look, they're little footballs. Laces out. You know, what the hell? Oh, nice, Hazard. There you go. Now we're talking. She expects him home any minute. The engine's running, but nobody's behind the wheel. Liar Liar is a good movie, Unity. Oh, come on! What do you think of satire? It's funny. It's a tool that's used by comedians to convey certain types of humor. Caddyshack. To this day, I still don't understand the plot of that movie. What's the point of Caddyshack? You ever thought about that? It's ridiculous. I'm not going to say it's not funny. It made me laugh. Are you interested in darts at all? Passing interest. It's about the gopher. Pretty sure the gopher is the point. I've never watched Airplane, but I feel I've watched most of it through all the clips. Yeah, something like that, Tessa. Hey, we're all gonna get laid! Yeah! You know. Noobly, 60-month resub. Dude, you got your worm. Nice. A lot of people are getting their worm logo this month, Noobly, which I'm kind of wondering what I was doing at the beginning of 2019. I must have been cooking hard because a lot of people got their 60-month resubs this month. I must have been cooking hard. Wait a minute. Beginning of 2019. Okay. It's not the beginning of 2020 because then I was not that. No. Okay. Jeez. Nice, Sebby. I don't know what that means, but that's if you're telling me, I'm assuming that that's good. So, beginning of 2019 was very Condor focused. Yeah. I think you had an epic build in 2019. It had to have been Condor or the shuttle or something. We need more levels, I guess. Yeah, a lot of people just maxed out. Yeah, something like that, Forge. You want to call that. He's about to become the Max Verstappen of darts. Oh. Dazed and Confused and Super Troopers maybe have a new meaning. That I have my cannabis card. Oh, nice. 2019, wasn't that when Breaking Ground came out? Yeah, I think so. The base that self-detonated. Mint Chip. Mint Chip was 2018, but yeah. Feels like I've been watching way longer than 41 months. A lot of you guys have been here for a long time, dudes. Anyway, yeah, little bit about cinematography. Hey, Flip Up, 25 months. Thank you very much. All right, cool. Game time? Game time. Let's do it. Let me check launches here before we jump in. Yeah, phase is a good time. 2019 had SpaceX DM1. Yeah. Yeah, speaking of launches, let's see what we got. That Starlink from last night pushed 22 hours. It was a 22-hour scrub, so the next window is 9:15. I think tonight we'll go right to that, and yeah, 7-Eleven, baby. Did you see the Raptor Blue Fire? No, I haven't. Nice, Eddie. That's cool. Thank you. Don't know if you missed it, but Baby Driver is masterclass cinematography. It is, Klavic, yeah. Yeah, so we'll go right to the end of that. We'll go right to that launch. And we'll go from there. Ooh. Actually, quick space stuff. SpaceX released this footage. You guys are probably going to want to see this. This is from the Axiom 3 mission. right, so this is from McGregor, live from NSF. Holy crap. How does that thing not pop? Whoa. Throttling down. Flame out. Damn, dude. What the heck is going on there? Can't hear me? Pause Falcon. Wait, what? Oh, there was sound on that, wasn't it? Headphones shut off, dudes. This is why I hate using wireless headphones. They time. Sorry about the noise. Dude, I hate that. Sometimes I'm like not hearing anything, right? This thing just shuts off because it doesn't want to drain the freaking battery, right? And then I can't hear the damn noise. I miss sub alerts too doing that. Here, what was the noise for this? It was loud. Oh, that's weird. Yeah. Oh, lovely. Yeah, weird. Huh, loud. Anyway, back over here. Yeah, so that Falcon footage is amazing. It's actually better with the sound. But this stuff here for McGregor Live is, yeah, they're messing with fuel ratio there. I'm not sure how. I'm not sure how they would screw with the mixture like that, but... Damn, dude. Look at the thing throttle. That's crazy. See how the flame gets bigger? Oh, man. Okay, like... Dude, just for some reference here, that test stand is gigantic. That was an original Beale test stand. It's freaking huge. Like you see here, that's one story. So we are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We're 11 stories up. That flame is 10 stories tall. That's why that's nuts. Even when they throttle it all the way up, it basically is going to the ground, which is pretty damn impressive, dude. Yeah, they must have been messing with air oxidizer to fuel ratio on that Raptor. I'm not sure exactly what they were doing, but they changed the ratio and then throttled the thing like to the maximum. Yeah, see, then they throttle it down, and then... Sploosh! Cool. Does blue mean more oxygen-rich? It's moving in that direction, but it hasn't gotten to a point for lean conditions, erudite. The blue flame means you're operating closer to a ideal methane to oxygen. Is blue normal? It's just indicative of an efficient burn, Yannick. A more efficient burn. Basically, they're blowing up more of the methane is combining with more of the oxidizer. Now, Forge, you said it could be the film cooling as well. They may have figured out a way to use less film cooling, which gives you... less film cooling will get you a more efficient or more blue flame coming out the bottom. Yeah, and if it runs lean, it goes green. That's right. Yep. Engine rich, baby. Engine rich. That's not what we want. Actually, dude, we could do... there is something that I wanted to... There's something that I wanted to touch base on, and it's RE that commerce or space science technology meeting that we did the other day. A lot of folks are writing articles about that exchange, and some of them are I'm going to say grossly well, not grossly. Let's just say they have a very different interpretation of that meeting than I do. So I saw this on I found this on the Twitterers. Former NASA director trashes upcoming moon mission. He didn't mince words. Yeah. A lot of people are bashing Mike Griffin for stuff like this, which I think is funny because he's right. For some freaking particular reason, I saw a lot of people take it as a slight against SpaceX, which is not really what he's getting at, but yeah, Thomas, yeah. He said some stuff, right? He didn't mince words. That's why I like him. Yeah. He's doing that whole tell the truth thing. Yeah, I was like, here, let me show you. I've gone into pretty damn good detail of why I think he's correct. But what? I'm interested here. I'm interested. Give me 1 second. Maybe that's the point, right? Like, I get it. You got to click on the article, etc., etc. So, what do we got? NASA could not afford to faff around with a complex, partly commercial plan to put humans back on the moon with an eye towards long-term settlement. Instead, he said, the agency must get back to the basics and get to the moon as fast as possible. China, which has a competing lunar program, must not be allowed to beat NASA and its allies back to the moon. The space agency, he said, needed to restart the moon program and chuck out all of the commercial space nonsense. That is not what he said at all. Wow. Okay. Where was the part where he said chuck out all of the commercial space nonsense? Where was that part? I don't really remember that part. We watched the whole meeting. What? Anyway. The House members in attendance never paused Griffin for details about this plan, but they are outlined in his written testimony. It's an enlightening read for everybody who wants to understand where some traditional space advocates would take the U.S. space program if they had their way. It may not be entirely theoretical, as Griffin could be angling for a comeback as... It may not be entirely theoretical, as Griffin could be angling for a comeback as NASA administrator if Donald Trump is elected president. Wow, what a presumption. Oh my goodness. Where did you get, how did you, what? Come again? What? Where'd you pull that one out of? Well, like, dude, I don't even get mad at this anymore. Like, what are you talking about? What does that even mean? What? Oh, I got. Oh my god. What? It's a mat with different conclusions that you can jump to. What? Dude, I don't even get mad from this anymore. I'm just, all right. Okay. In Griffin's case, he would return the country to the cozy confines of 2008, just before the era of commercial space took off. And when he was at the height of his power, before being removed as NASA administrator. What? Bro. What? Who wrote this? Take a guess. Did you see that? Griffin's plan for an accelerated lunar mission, in short, calls for 2 launches of the Space Launch System Block 2 rocket, a Centaur 3 upper stage, an Orion spacecraft, and a 2-stage storable propellant lunar lander. Yeah, that's right. Yeah, Rockets, this guy writes books about spaceflight. Just thought I'd let you know. Stay in school. Yeah, seriously, writes books about spaceflight. Quite popular. This architecture would support a crew of 4 people on the lunar surface for 7 days, Griffin said. The straightforward approach outlined here could put U.S.-led expeditions to the moon beginning in 2029, given bold action by Congress and expeditious decision-making and firm contractor direction by NASA, he concluded. With this plan, Griffin is essentially returning NASA to the Constellation program that Griffin helped create in 2005 and 2006. The spacecraft, Orion, is the same, and the rocket, SLS Block 2, instead of Ares 5, is similar. The proposed lunar lander looks somewhat like the Altair lunar lander. He's trying to put the band back together, relying on Boeing, Lockheed Martin, and Northrop Grumman to get astronauts back to the moon in a quick and efficient manner. I don't understand what he said. Isn't he usually against SLS and pro SpaceX? I'm so confused. Sevi, that I was gonna get to that. I think that's really funny to me. That's really funny to me. Like, what? What are you talking about, dude? You're defending SLS? What are you, on drugs? What's wrong with you? Yeah, the Aqualex, I think it's the T word. I'll check the auto mod settings, dude. Is this Bizarro Land? Dude, I don't know. 2024 is a very strange year thus far. I mean, we're only a couple weeks in, but this is very strange. This is real strange. The problem with Griffin's plan is that it failed miserably 15 years ago. The Independent Augustine Commission, which reviewed NASA's human spaceflight plans in 2009, found that the U.S. human spaceflight program appears to be on an unsustainable trajectory. It is perpetuating the perilous practices of pursuing goals that do not match allocated resources. And that's probably putting it politely. No, that's not putting it politely. That's what happens when you don't give them the money that they need. I'll say it just once for continuity. The reason why Constellation was canceled 15 years ago is because they cited underperformance for the reason. They cited underperformance. Said it wasn't achieving its goals on time. Yeah, that's what happens when you give NASA no money. In 2008, they did not appropriate any money for NASA, right in the middle of developing the Constellation program. They didn't do that because more recession. That was their reason. Well, we're not going to give you any money. Oh, the program isn't doing good anymore? Canceled. Canceled. Why weren't you able to perform? We asked you to build a Formula 1 car, and you built us a go-kart. Well, we built you a go-kart because you gave us 50 grand to build a Formula 1 car. That's not possible. There's your context. Anyway. Like Haas. Yeah, and then fire the team principal for underperformance. Oh, you can't make this stuff up. Oh, it's so funny, dude. All right. Here. There are some huge fictions in Griffin's plan. One is that there would be 2 SLS Block 2 rockets ready to launch in 2029. Recall that it took 12 years and $30 billion to develop the Block 1 version of the rocket. The earliest NASA expects an interim version Block 1B to be ready is 2028. But magically, NASA will have 2 builds of the more advanced Block 2 rocket with more powerful side-mounted boosters ready by 2029. What? This assumes that if we decided to do this, we wouldn't change the procurement plan from what we're doing now, which is... Why? That's not how this works. That's not how any of this works. Yeah, me too, Tessa. I know what you mean. Then there's the lunar lander, which hasn't been designed, and it's not funded. And if it were built through the cost-plus acquisition strategy outlined by Griffin, it undoubtedly would cost 10 to 20 billion and take a decade based on past performance. Past performance of what? Past performance of what? The other lunar landers that we've made? I'm pretty sure we only made one, and that was 50 years ago. What are you talking about? Well, I don't understand. What? 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 What are you talking about? Based on past performance of what? Building core stages? That's not a lander. What are you doing? What are you doing? A reasonable estimate of Griffin's plan based on contractor performance with Orion. Been in development since 2005. Yeah, and then you pulled the plug on it in 2009 and then brought it back in 2011. It didn't tell you that part, but anyway. And the SLS rocket is that if NASA's budget roughly doubled, humans might land on the moon in the 2030s. I agree with that. Based on SLS. What? He was told by his sources, aka the alphabet cereal he eats in the morning. I don't understand. You're comparing the cost of a core stage for a super heavy launch vehicle to a lander. What? That's okay. All right. Okay. All right, let's keep reading. Then there's... Okay, we already got to the lunar lander. Commercial space sucks, Griffin says. Oh, this part's going to be fantastic. I love it. Let's go. One of the ironies of the career of Mike Griffin is that at the direction of the George W. Bush administration, he helped launch the commercial space revolution. That's right. Griffin created the Commercial Orbital Transport Services, or COTS program, in 2006, and it funded the development of cargo spacecraft by SpaceX and Orbital Sciences, also correct. It is no exaggeration to say that this program and its successor in 2008 to fund cargo supply missions to the International Space Station saved SpaceX. Without them, the company founded by Elon Musk would probably not exist today. That's correct. Commercial Orbital Transport Services was under the Constellation program, which Griffin chaired. Yeah. The programs that he helped iron out during Bush's second term are kind of the reason why SpaceX exists. That's exactly right. But even before he left NASA, Griffin was already turning on the commercial space industry. He did not support NASA's funding of companies because he did not believe they were putting enough skin in the game as part of their fixed-price contracts. Griffin ended up proposing the creation of the Commercial Crew Program that ultimately led to the Crew Dragon vehicle that broke NASA's dependence on Russian rides for the ISS. But these two sentences say the opposite things. Am I inferring too much? Those things... He says, well, he actually hates Commercial Crew, but he actually started Commercial Crew, but he secretly hates it. But he actually ended up saving it. So, but he hates it. What? Elon and Lori Garver actually replied to this article on X. I'd be very interested to see, yeah. Okay, all right. Yeah, flip up. There's a reason why I show this stuff. But anyway. The plan to use commercial capabilities certainly departed from what I saw as the correct path, Griffin said in 2013. In our view, activating a crew provision would only come after substantial, even enormous progress had been made on cargo. You have to learn to crawl before you can walk. We set the Commercial Orbital Transport Services agreements up initially to allow for money to be invested in crew development. But in our plan, we certainly weren't going to invest in crew development until cargo capability had been amply demonstrated. That does not mean... What? That doesn't mean that he hates Commercial Crew. That means they gotta learn. And that's exactly what happened. Commercial Orbital Transport Services, which under COTS, there was a program which still exists today called Commercial Resupply, CRS. There were two big phases of the CRS contract. There's CRS-1 and CRS-2. These are commercial resupply contracts for the space station. Dragon has one, Cygnus has one, Dream Chaser will have one. Dream Chaser wasn't part of the first round of commercial resupply contracts because it wasn't ready. But Dragon 1 was for the CRS-1 contracts, and Dragon 2 came for the CRS-2 contracts. There's a reason why Dragon 2 came around for the CRS-2 contracts. The reason why is because they learned to crawl, and SpaceX, bid a Dragon capsule that could be outfitted for cargo and crew after literally what he says. Right there. Once it was amply demonstrated, they started Commercial Crew. This was always part of the Commercial Orbital Transport Services contract. I'm still failing to understand here. Maybe I'm being obtuse on purpose because I like what Mike says. Like, I'm trying to rule that out of my judgment here. But also at the same time, I don't see any distaste for the commercial program is inferred from what he said, but that's not what he said. Where does he say here that he doesn't like it? He doesn't say it. He doesn't say it anywhere. He's never said that verbatim. And he's never even inferred that. I don't Alex, yeah, all right, am I like crazy here? Like, I'm just wondering, like, Yeah, of course it is, Hellfish. This article is so ridiculous that I actually had to share it. I'm like, dude, once again, I'm not getting pissed off. I'm just, this is actually kind of funny. Like, it's funny because he's defending the Artemis program and the SLS rocket. What? Oh my God, that's awesome. That's awesome. I thought you said SLS with the EOS could get Orion into low lunar orbit, so why not do that instead of the 2 launches? Cody, it could if you either A, find a way to mitigate boil off on the EUS, or B, uprate Orion's service module. It could, either one. Personally, I think you should do both of those things at the same time. Just a thought. Yeah, well, Hellfish, what are you going to do? All right, anyway. Griffin has also called the money that NASA spent on cargo and crew services provided by SpaceX excessive. He has carried forward this animus towards SpaceX and the U.S. commercial space industry, which the present-day NASA Deputy Administrator has called the envy of the world, into present day. The fundamental flaw in the Artemis acquisition approach is the assumption that the U.S. government can and should leverage its so-called commercial space for national purposes, and that this paradigm is applicable to human spaceflight. Let me read that again. The fundamental flaw in the Artemis acquisition approach is the assumption that the U.S. government can and should leverage so-called commercial space for national purposes, and that this paradigm is applicable to human spaceflight. Yeah, that doesn't mean that... I'd appreciate the discussion sometime about boil-off problem. I'm a chemical engineer and I still don't understand the difficulties. There is none, Dredd. There is no difficulties. We have to go do it. That's the difficulty. Therein lies the difficulty. Someone has to go and do it. It's not that hard of a problem to mitigate. It's just, until somebody goes and actually does it. Long story short, we've been talking about doing it, and sitting here talking about doing it abstracts the problem more over time, right? So we've built it up as this thing that we're never going to be able to do it. We're never going to be able to do that. The reality of the situation is we don't think we're going to be able to do that because no one's ever demonstrated it. Does that make sense? Can you discuss the Japanese moon lander? I already did. That's the closest he came to saying it. The current ways of interfacing with commercial surfaces is convoluted and bad for everyone, and that the only thing it accomplishes is making it easier to interface with new space companies than old ones. I think the context for that statement, Oculus, and you guys tell me if I'm doing what he does, but in the opposite direction here. He said the fundamental flaw in Artemis acquisition of the Artemis acquisition approach is the assumption that the U.S. government can and should leverage so-called commercial space for national purposes, and that this paradigm is applicable to human spaceflight. Bingo. That's pretty straightforward. That's pretty straightforward. He's saying that commercial entities have commercial stakes, and that's different than a rocket that is purely built for scientific purposes. The argument there is that a rocket like Saturn V, a rocket like SLS, and even to some extent the space shuttle, which if you flew it more, it probably could do this. The argument is that these rockets that are used for human exploration, that are used to serve U.S. government national interests, scientific understanding, human exploration, those rockets don't have any place in a commercial market. Understand? That's the argument there. Falcon 9 is a great rocket. Arguably better than pretty much every other rocket flying objectively by the metrics, right? You can reuse the thing. It's amazing, right? It flies all the freaking time. We saw one launch yesterday. We're going to see another one launch today. And the only reason the one's launching today is because they're supposed to launch yesterday and it didn't. Like, how do you use Falcon 9 to get to the moon? See what I'm talking about? Can't get to the moon. Because that rocket was designed for commercial low Earth orbit access, which is what the Commercial Crew Program contracts were. That's what he's trying to say. He's not saying that he's not saying that a commercial rocket is necessarily bad for the Artemis program. What he is saying is that a rocket that's designed for a commercial market to make profit isn't necessarily going to have, you're not going to have the correct acquisition approach for a rocket like that, because the rockets that NASA needs to go and land on the moon are rockets that have no place in a commercial market, like SLS or Ares 5 or Ares 1 or the Space Shuttle or Saturn 5 or Saturn 1B. There's no market for those vehicles. That's the context of what he's saying there. He's saying that because there's contractors in the proverbial pathway from the surface of the Earth to the surface of the moon, because there's commercial rockets in there, you're shoehorning a commercial rocket to try and do what you'd need a full built-out scientific rocket to do. Long story short, he's saying NASA needs its own pathway to the moon that is supplementary to commercial. That's what he's saying. That's my argument. And a lot of my logic is, a lot of my thoughts about the space program stems from what Mike Griffin has to say. That's where I learned from. Oh, good. You see what I'm saying? He's saying that you can use commercial rockets to supplement the program, but have them being directly in line doesn't really make a lot of sense. I kind of agree with him on that, to be 100% honest with you, and that's probably going to piss off SpaceX people, right? Like Eric Berger. I think he's right. I think NASA should have their own way to get to the moon. Their own way that's built in-house to get to the moon that is supplemental to SpaceX and Blue Origin. Pretty straightforward stuff. Because the rockets for the commercial market are always going to have commercial interests first. Except the one like kind of elephant in the room in that regard is Starship. Starship is objectively built for scientific exploration, right? And that's probably why so many people got pissed off at what he said. But also at the same time, NASA shouldn't be beholden to a commercial corporation to be able to get to the surface of the moon. I don't think that's smart. And that's what is inferred from that statement. Not that he hates the Commercial Crew Program. I'm not sure that's what he's saying. See above. I don't see anything about what you said, Aqualex, here, but I'm going to keep going. I disagree. This is an interesting viewpoint given that SpaceX's Crew 7 mission launched on a Dragon in September, and a private mission, Axiom 3, is due to launch later today. This article is from yesterday. This is just a mix of government and commercial missions flying on a private spacecraft that Griffin contends is not feasible because they're designed to go to the ISS, not the moon. Besides, NASA has always been dependent on private enterprise to land on the moon. Wasn't the LEM built and delivered by Grumman? Built and delivered by Grumman, Alex. Operated by NASA. Operative word. I've always been careful with this, and people just tend to glaze over it. NASA needs their own way, their own spacecraft, built by commercial companies, obviously, right? That is operated independently of commercial. Heck, dude. I would even contend to say that in this regard, like, if NASA contracted SpaceX to convert like 39B into a Starship tower and a super heavy launch vehicle, right? And said we're gonna buy this from SpaceX and we're going to operate it on our own terms for our own uses, I'd be cool with that. That's what I'm talking about. It's the operations thing that I'm like about. Not necessarily because there's anything wrong with what SpaceX is doing. I think Elon truly has, with how he's running that company, he truly has humanity's best interests at heart for, multi-planet civilizations, et cetera, right? I'm about as big of a SpaceX fanboy as they come. But NASA should have their own redundant capability. I don't think having a corporation being the arbiter of scientific truths is smart. I don't think that's wise. Not that Elon wouldn't give us the best that he possibly can. I mean, the guy works ridiculously hard to try and not do that. But what happens in some crazy, future, right, where NASA is contracting services to another commercial company, and contracts to resupply a moon base get, a commercial contractor says, "Nah, I can't do that. Nope, not going to do that anymore." Now NASA has to abandon a moon base because they don't have their own way to get there. Understand? That's what I'm getting at. The nuances in the operations. That's why HLS is a NASA program then. HLS is not a NASA program. I mean, it is a NASA program, but SpaceX is operating the lander. NASA gets the astronauts to rectilinear halo orbit, and SpaceX, the astronauts get on board Starship, and SpaceX operates the lander down to the surface. Same with sustainable lunar development. Same with Blue's lander. I don't think that's wise. I don't think that's smart. That's just complicating the mission. It's just complicated, an already complicated thing to do. And that's the kind of stuff, that's the kind of stuff that was in that Space Science Committee, dude. That's the kind of stuff that was there. This is what they talked about. They talked about a lot of the questions that the politicians of all people asked that panel that Mike Griffin was on is, how are you going to sink the industrial base so you can get to the surface of the moon? There's so much stuff here. What if something goes wrong? And NASA basically said, "Oh, we're flexible. It's fine. We'll see." We'll see is what the investigator general said verbatim. So that's the investigator general, dude. See what I'm talking about? All right. As part of his plan, Griffin says the contracts NASA has awarded SpaceX and Blue Origin should be terminated for the convenience of the government. To continue programs that we know will not achieve our goals distracts us from what must be done and damages NASA and the nation's reputation, even if they're being executed for free. He talked about the entire program. He talked about the entire Artemis program, not the context of that statement. We watched the hearing. The context of that statement was to stop Artemis as its current thing. Just get rid of everything. We got to start over. We got to rethink our procurement. We got to rethink our architecture to get to the moon. That includes commercial, right? That's what he said. There's nothing. See, that's what I mean, man. All the inference that Mike Griffin hates the commercial crew program is just that inference. He's never said anything like that. Yeah, of course it is, RJ. Dude, this article isn't even making me mad, dude. Like, I'm not getting pissed off. It's funny to me. Like how Mike Griffin ruffles so many freaking feathers, dude. The second he infers that, maybe using Starship for our first lunar landing, which might not be a good idea, which, I mean, I don't necessarily agree with that. I don't think that SpaceX is going to be the bottleneck in the Artemis program. I think it's going to be the suits. But what do I know? I think SpaceX will have the lander ready on time. Unless, the FAA keeps preventing them from launching because they want to learn how to make a commercial spaceport. I think that's a more dangerous precedent than anything. We have a program that's directly in line with the country's national interests at a federal level being blocked by other federal agencies because they need to learn how to make a commercial spaceport. That's part of the reason why Starship has been delayed so many times. It's not some crazy obfuscation. It's not bureaucracy for the sake of bureaucracy. The decision to make commercial spaceports under the jurisdiction of the FAA means that the FAA needs to learn what the regulatory framework is for a commercial spaceport, because that's never been done before. Straight up. That That is what is slowing down SpaceX. Now, I won't say that that won't lead to better things in the future. In fact, using something like Starship to establish the regulatory framework for commercial spaceports is actually a really good idea, because Starship is something ridiculous. It's ridiculous over the top. Using that as your metric, as your baseline, is going to make it so commercial spaceports can pop up with small sat launchers that should be able to get regulatory approval like this. Think about the rules that govern like an international airport, like an airport that sees a ton of traffic. Let's just use London Heathrow. The rules that were established for a high throughput airport like that make smaller airports for private planes and general aviation, that is what standardized those rules to make it easier to make a smaller airport or a smaller runway. Right? Like a smaller airport. It's easier to do because we have the high throughput airports as our baseline. It's really smart. That's what they're trying to do. But that also is slowing down SpaceX for the entire Artemis program. That makes sense? How far is SpaceX into figuring out the whole on-orbit refueling thing? It will be prototyped on the next flight test 415. They're going to move fuel between the header tanks on Starship, back to the main tanks, back to the header tanks. IFT3, so a month, give or take. What is the altitude airspace law for international satellites? Altitude? Above 60,000 feet, some guy, it's basically unregulated airspace for the most part. There are some regulation. There is some regulatory framework there in the form of the 1967 Outer Space Treaty, I guess, if you wanted to read a specific thing. But yeah, how many Starship flights before it's crewed? Well, if I know SpaceX pop, there's probably going to be a lot of flights, just like Falcon, a lot of uncrewed flights deploying Starlink satellites and whatnot, deploying the Starlink V2 minis, because or the V2s, not the V2 minis. Starlink V2s are going to eventually replace the entire Starlink constellation. So that's what, at least 5,000 satellites. So Starship is going to have a lot of flights to replace the Starlink network over time. The way SpaceX built out their Starlink network is that the network will only last about 5 years before the satellites run out of fuel and re-enter, because they're low in the atmosphere. They're enough where orbital perturbations from atmospheric drag, the satellites need to have thrusters constantly firing, or else they'll deorbit. And when they run out of fuel, when they run out of argon, because that's what they're using, when they run out of argon, they'll just deorbit. They'll shut off and deorbit and burn up in the atmosphere. They're designed to burn up, right? So, SpaceX really started going ham on Starlinks 2 to 3 years ago. Guess what? Starship, if I had to guess, Starship will start flying in mass capacity in about 2 to 3 years. And we're talking, I'd probably say, they start five or 10 launches a year at Boca Chica, right? And then they build out the second pad, and then they build out more pads, right, at the Cape and stuff. So eventually, I think with SpaceX's industrial base, you could probably scale Starship to launching on the frequency of Falcon 9 based off of what SpaceX has learned from said Falcon 9 program, 5 years, something like that. And if you look at that, that basically coincides more or less with replacing the Starlink network. Replacing everything with the V2 satellites. Right now they're launching V2 minis on Falcon 9. And Falcon 9 will basically pick up the slack until then. Yeah. That's why I don't think that Starship is going to be the bottleneck here, despite Starship being ridiculously complicated mission architecture. I don't think it's going to be the bottleneck here. SpaceX has a reason to launch it a lot. Does that make sense? Why does it seem like everything has ground to a halt since Jim left? COVID probably had a lot to do with it, Cody. Correlation doesn't equal causation. Elon said at this point Starlink would be launching V3s. Sure. After they achieved their first orbit, how many iterations of Falcon 9 were there before they made the one that got certified for human flight? I don't know what the internal thing is. I know that the Block 5 one was the one that was certified for human space flight, Mayor. Block 5 started flying in 2018 with the Bungamundu mission, and the first crew flight was May of 2020. Anyway, keep going. Cancel the contracts. This is rich. That's a fragment, not a sentence. When the Obama administration sought to cancel the Constellation contracts in 2009, Griffin and others fought hard to pay termination costs to the contractors, estimated at about $1 billion. NASA's deputy administrator at the time, Lori Garver, describes this incident in her book, Escaping Gravity. I was incredulous that any non-contractual assurance would have been enough for the company's CEOs to take hundreds of millions of dollars in liability on behalf of their shareholders, even if the promise had been made by the NASA administrator himself. Interesting. Correct me if I'm wrong, but the reason Block 5 and no earlier was the certified crew rocket is because SpaceX had to be frozen at some point, and SpaceX waited until the reliability had been figured out. One of the big things, Alex, that made it that way was Amos 6 exploding. NASA was really, really, really skeptical of solid oxygen permeation with composite overwrap pressure vessels after Amos 6. That probably was the biggest reason for the delay. And why SpaceX really pushed for Block 5, because Block 5 had the rectifications. Is that a word? Had the changes that's a better word. It had the changes that they needed to make to Falcon 9 to get it human rated. SpaceX chose Block 5 for the crew rating version because it had those upgrades to the COPV that wouldn't cause solid oxygen permeation when you're filling densified propellants. Yeah, I remember NASA making a big deal about this booster needs to fly a bunch of times for us to scientifically and empirically conclude that it's safe enough for people. And there was this whole big thing about flying COPVs on Block 5s that are reused. Do the reused boosters count for certification? Do they not? There's a big thing about that, dude. Rectification is French, technically. Ah, sacre bleu. Mon Dieu. Right? This is interesting here. When the Obama administration sought to cancel the Constellation contracts in 2009, Griffin and others fought hard to pay termination costs to the contractors, estimated at about $1 billion. Hey, Concrete, 48-month resub. This is my resub message. There are many like it, but this one is mine. My resub message is my best friend. Without my resub message, I am useless. Without me, my resub message is useless. What? Sorry, anyway. As a deputy administrator at the time, Lori Garver describes the incident in her book, Escaping Gravity. I was incredulous that any non-contractual assurance would have been enough for the company's CEO to take on hundreds of millions of dollars in liability on behalf of the shareholders, even if their promise had been made by the NASA administrator itself. I'm not understanding this part. I was incredulous that any non-contractual assurance would have been enough for the company's CEOs to take hundreds of millions of dollars in liability on behalf of the shareholders, even if the promise had been made by the NASA administrator himself. I couldn't believe that. Really. I couldn't believe that any non-contractual assurance would have been enough for the company's CEO to take on hundreds of millions of dollars in liability on behalf of their shareholders, even if the promise had been made by the administrator himself. When the Obama administration sought to cancel the Constellation contracts in 2009, Griffin and others fought hard to pay termination costs to the contractors, estimated at about $1 billion. NASA's deputy administrator at the time describes the incident. I just asked ChatGPT to rephrase it for a 10-year-old. Primo, I just don't really understand the context of this statement. Why this doesn't really make sense here. And once again, Griffin and others fought hard to pay termination costs to the contractors. Is that what Lori Garver said? Because then it's anecdotal, right? Like, why would Mike Griffin do that? Why would he when the Obama administration sought to cancel the Constellation contracts in 2009, Griffin and others fought hard to pay termination costs to the contractors, estimated at about $1 billion. Well, Griffin was for termination costs in 2008 and against it now. Yeah, Concrete, where does it say he's against termination costs to the contracts now? Where did he say that he's against termination contracts now? I didn't hear him say anything about termination costs of contracts in his testimony or in his paper. We saw both of them. We read the whole paper and we watched the whole subcommittee meeting. I don't understand how that fits into the argument that he's trying to make. There's some kind of inference here that, you know, he hates commercial crew and he would pay termination contracts to old space but not new space. I guess that's the point that he's trying to make. But once again, there's nothing here in this entire article that says Mike Griffin hates the commercial program. In fact, the article states the contrary just 3 or 4 paragraphs up. It says the exact opposite of that. I don't understand how Mike Griffin can hate commercial space so much, but also at the same time be the person that fathered the program that saved SpaceX, and then he ended up opposing the creation of the commercial program that ultimately led to the Crew Dragon vehicle that broke NASA's dependence on Russia for rides to the ISS. I don't understand how he can hate it, but simultaneously be the guy that makes it at the same time. Like, I hate commercial crews so much. Here's a contract that saved SpaceX. I don't think SpaceX should fly people right away because they have to they have to mature their launch vehicle and their capsule before they can retrofit it for people. I think they have to fly more, and then we give them a commercial crew contract. Oh, you must hate the commercial crew program then. Like, there's no... I don't get where he's getting some of these inferences from. That doesn't really make a lot of sense. Yeah, I can't tell if he's saying... Well, Brimo, once again, there's nothing to say here that Mike Griffin hates the commercial crew space program. He's never said that verbatim, but I get it. You know, no person that can navigate political minefields is going to say something outright, so we have to kind of presume, right? But, dude, in the context of the statements that Mike Griffin made in the meeting the other day, we never even saw anything like that. He didn't talk about commercial space programs once. He like, not once. I watched the whole thing. You were there. Like, I didn't hear him talk about commercial. It was his entire premise and his entire gist, and even in his paper, it was all about the Artemis program and procurement strategies for said Artemis program. That had nothing, like, I don't understand. Yeah, it's very strange. Like, anyway, Griffin is not wrong when he characterizes NASA's present plans for Artemis as complex. They are. They require SpaceX and eventually Blue Origin to develop large and sophisticated rockets and spacecraft, prove out the capability to store and transfer cryogenic fuels in orbit, and perform a myriad of rendezvous and docking operations in Earth and lunar orbit. NASA's current timeline for a 2026 lunar landing is not at all realistic, but 2028 does seem possible. What? Myriad alone is correct? Okay, cool. Today I learned. But how isn't that like the opposite of what? All right. There will undoubtedly be teething pains for Artemis. Oh. The person Griffin is suggesting that NASA should cancel contracts with SpaceX and Blue Origin because he thinks these projects won't help NASA's goals. But it's interesting because when the government wanted to cancel contracts before, Griffin argued to pay the companies even if it wasn't a formal agreement. That's a bit confusing. I don't understand how contract termination, Bree, is the thing that's like the gotcha thing there. That makes no sense to me. He's trying to pay them for work done. Yeah. Interesting. Also, there will undoubtedly be teething pains for Artemis. Man, where was that statement in 2018 when you were thrashing SLS the entire time? Yeah, I don't either. What does wanting to pay people before have to do with wanting to cancel contracts now? Yeah, I don't understand. The whole inference of his article is that somehow Mike Griffin has it out for commercial crew and commercial space, even though he's the guy that basically established the regulatory framework for the commercial space industry. Seriously, Griffin was the administrator in 2009. Commercial Orbital Transport Services. I mean, Eric even said it in the article. Commercial Orbital Transport Services was his idea. And giving SpaceX the contract for resupply was also his idea. And then putting in the regulatory framework in Commercial Orbital Transport Services in the Commercial Resupply 1 contract, he put in the regulatory framework in that for commercial crew down the road. Because that was always part of the Constellation program. When NASA starts focusing on going back to the moon, we're going to need a commercial market to supplement what the space shuttle was doing. There's always going to be a demand to launch satellites in space. And that's where you'd leverage the commercial industry. Different goals than what NASA is trying to do, which is basically what he said in that testimony yesterday. Guy hasn't changed his tune in 30 freaking years. Like, I'm so confused. Local chatter replaces their own insights with AI. I don't understand. Is that any worse than normal Twitch chat? Oh, God. Oh, jeez. What's up, Etel? How you doing? Etel, we're reading about this guy that everybody dumps on because he's telling the truth, and I think it's really funny. Everybody dumps on this dude because he's like, guys, NASA has had 2 launches since STS-135 in 2011, arguably 1, Artemis 1. 2 if you count the EFT-1 mission, which was on a ULA rocket, right? So technically it wasn't a NASA mission. It was ULA for being used for contracted service, right? He's basically the guy's like, guys, you haven't launched anything. You've launched 1 NASA rocket in the past 15 years. What is going on? And then everyone's like, this guy sucks. You suck. I'm like, it's really funny to me. I'm so confused. You've been lurking for a bit? Yeah, everybody hates him, even though he tells the truth. That's really funny to me. I'm actually getting a pretty good kick out of this article. Yeah, concrete, I guess. I think the insinuation is that he just wants to hand companies money when they don't do anything. Yeah, that's the insinuation, but it's because he has problems with the procurement strategy. I mean, once again, he ain't telling the whole story here. Because he has a problem with the procurement. I mean, he said it at the very top of the article. He says that NASA's procurement strategy is terrible. And that's, I think, the point that he's missing here. Procurement strategy is horrible. You've launched 1 thing in 15 years. 1. One thing. You know, that's the funny part about this. No one's going to look at that and be like, yeah, there might be a problem with how we have the architecture, the mission architecture of our space program figured. That might be an issue, right? I'm surprised this article didn't claim he kicks puppies. Yeah. That's why they hate him. Yeah, I think they hated him for telling the truth. It's pretty fun. Like, dude, you saw me get heated for the Artemis thing the other day. I'm not even mad. I think that's what I want to share this article because it's good for a couple of laughs, man. What currently is on the critical path for Artemis 2 and 3? Well, with Artemis 2, the Orion capsule is the big one, Nate. Their life support systems failed qualification for Artemis 3. So there's a little bit of a hyperbole on my part, but the life support systems on Orion doesn't work. Should probably figure that out before you put people on board. Yep. One thing I don't know why, it doesn't even matter how hard I try. NASA, probably. Okay, all right. And sorry for spamming your chat yesterday. All right, Shogun, what do you got? In 2016, Mike Griffin said, to quote my friend and colleague, Jim Alba, the now retired CEO of Boeing Commercial Aircraft, the current administrator's views of our nation's future in space offers no dream, no vision, no plan, no budget, no remorse. Griffin said during a hearing of the House Science Committee, we must remedy this matter with all deliberate speed. Like I said, guy's been ridiculously concrete in his points of view about this since, from as far as I can tell, like 2005. Alex, we'll look at it. You don't need to bring it up again. We'll take a look at it, pal, okay? I just can't do that while I'm streaming. All right, please be patient. Please be patient. All right. There will undoubtedly be teething pains for Artemis. Oh, please tell me there's people here that work on the SLS program. You don't need to say who you are. I just hope you're watching. This is Eric Berger saying that. Saying that right there. Like, if you work on the Artemis program, and you've been working on the Artemis program, and you're watching the stream, you've been doing it for a little while, I'm making it a point, and let me point, because I am the cream, to that statement right there. That's, all right, okay, oh, all right, sweet. But the plan initially developed by Administrator Jim Bridenstine during the Trump administration and then advanced by Administrator Bill Nelson under the Biden administration is a nice bit of bipartisan policy that brings together the traditional and commercial space industries in the United States, and it has added a strong element of international partnerships through the Artemis Accords. Yeah, Rocket Guy. Agreed. Hey, Rob, I'm good. How are you, man? All good, man. What? Bruh. Oh, my God. What? Dude, hell's gonna freeze over. Hell's freezing over. The Lions are in the playoffs, man. We're screwed. We are so screwed. Oh my goodness. We are so screwed. Yeah. And Aqualex, that's why he's bringing that up, because it's a, yeah, EJ made a Brobel reference. Oh no. I'm cool with it if my Bills win this weekend. Don't lose. I know that's what you do best. That's why he was bringing that up, because yeah. Okay, jeez. Shut up. They hated Griffin because he told the truth. This article is amazing, man. It's amazing. I love it. This article is fantastic. To chuck all this out the window for an uber expensive dash to the moon that would be nothing more than Apollo Part 2 and completely unsustainable makes no sense. Who cares if China lands 2 taikonauts on the moon before NASA later this decade or in the early 2030s? I would give that a low probability of happening, as China will have technical and funding problems too. No, Rob. No, don't worry about it. But even if this happens, China isn't going to establish norms on the moon with a single 2-day mission. Those norms will be set by the nations that go to the moon and then send a fleet of spacecraft over time. That part's right. See, it's interesting. This is interesting. Because he says that he says right here that the Artemis program is a good, great program, bipartisan, blah 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 blah. To chuck all this out the window for an uber expensive dash to the moon would be nothing more than Apollo Part 2 and completely unsustainable and makes no sense. Who cares if China lands 2 taikonauts on the moon before NASA later this year? I would give low probability of that happening, as China will have technical and funding problems too. But even if that happens, China isn't going to establish norms on the moon with a single 2-day mission. Those norms will be set by the nations that go to the moon and then set a fleet of spacecraft over time. Even if that happens, China isn't going to establish norms on the moon with a single 2-day mission. The Artemis program calls to land 2 times by the end of this decade. Normal, Kaz. Norms mean the normal, the regular. That is the future that NASA, SpaceX, and Blue Origin are trying to bring about. They're looking to move away from a few Titanic launches of entirely expendable spacecraft that establish nothing of permanence on the moon. Am I having a stronk? Call the Bondulins. Yeah. Agulix, I agree. How can you say that up here that the Artemis program in SLS is a good idea and then slide it in the next paragraph? What? It seems like he's writing an insult sandwich style. Say a nice thing that appeases the enthusiast, say something disagreeable, and then close with something else positive. Yeah. Man, I'll tell you right now, this article ain't gonna age too well. I'll tell you that right now. It's gonna age like milk. That's really funny to me. So, the hilarious thing here, dude, is that, okay, so check this out. This guy has constantly written extreme conjecture about how the Artemis program was a terrible idea and how SLS is a bad expendable rocket. We shouldn't be doing it like that. I don't think that's a good idea. This is stupid, etc., etc. He's been saying that for the last 5 years at the very least. At the very least. It's hilarious how he 180s on that to try and get you to believe what he's saying as an appeal to what you said. That's really funny to me. I think that's really funny, dude. I haven't read his book, Jim. I'm not. I'll get the Cliff Notes. That's the funny part about this dude. Like, he's like, oh, guys, I was just kidding. The Artemis program's actually a good idea, but Mike Griffin's an idiot. I think, I think because I said that, the Artemis program is okay, that you'll believe me for saying he's an idiot, even though he said nothing of the sort. That's funny to me. That's hilarious, dude. What did it begin? They want to develop reusable launchers, in-space refueling, and reusable spacecraft and landers. It won't happen overnight. There will be setbacks. But that is... He did it again. He did it again. He did it again. But that is one way... But that is the way one ushers in a new era of affordable spaceflight in the 21st century, by looking forward to what is possible, not back at what worked 6 decades ago but was wholly unsustainable. He keeps using that word. I don't think you mean what I don't think that word means what you think it means. Yeah, exactly, Alex. That's why I wanted to share the article. That's why it's funny. Are you kidding? Like, what? You're saying positive things about the Artemis program? Like, how much does this guy live in your head rent-free? That's hilarious, man. Oh my God, you can't make that up. You can't make that up. It's so good. I love it. Man, 2024 is weird, dude. What are you talking about? No, drummer. No. That's hilarious, dude. What? What? What are you talking about? Oh man, that's awesome. That made me so happy. All right. Here. We're going to X. We have to cook, boys. We're going into X. Put the gas masks on. Here's the thread about the article. Oh my God. This is great. I do think he kind of has a point regarding timelines not being serious. We are like how many tens of billions and 20 plus years into Orion and they still have problems? Yeah, didn't reply to that one. Read the tweets. Elon says his plan makes no... This is Elon saying this now. His plan makes no sense, just a worse version of Apollo. Starship will enable a permanently occupied moon base and eventually city on the moon one day. Yeah, Aqua, you ain't wrong. I think it's unlikely. Then why did you write it? That's what I'm saying. That's why this is funny. Like, what? You can't just agree when someone disagrees with your article. I think this is stupid. Well, I actually don't think it's that stupid. Yeah, I agree. But it could be stupid. What? I love this year, man. Oh, this year is great. Can't make this stuff up. Oh my God. Dude, I want a do-over. See, Elon says his plan makes no sense. It's just a worse version of Apollo. Starship will enable a permanently occupied moon base and even a city on the moon. Okay, cool. Sell NASA some starships then, brother. NASA needs to operate their own fleet of starships. And if we do that in the future, I'm cool with that. We should do that. That's a good idea. Hey, Chaos, what's up? Elon also said that Neil Armstrong didn't like Dragon or something along the lines, and that's absolutely wrong. Nah, that's not really how that panned out, RJ, but that's the gist of it. A CNN journalist on a special on a 60 Minutes special, I think it's Scott Pelley, I think is the guy's name, he phrased that article to Elon, basically saying they've said that, your rockets are trash. They said that what you're doing is a bad idea. That's how he phrased that question, if you watch that 60 Minutes interview. And Elon had a very emotional response, as he should, because he looked up to those dudes. But if you go and look at the actual testimony of what Neil Armstrong, Gene Cernan, Michael Collins, Buzz Aldrin, what they all said at the time wasn't that they hated commercial spaceflight. That's not what they said. They said that pulling the plug on our national space program and putting all our efforts into a company that has almost no experience flying things into space, let alone people, could set our space program back as far as a decade. They said that in a congressional testimony in 2011. When did DM2 first fly? When did we return people to space from American soil? That was in 2020, about 10 years. Oh, that's weird. Oh, that's weird. That's strange. Man, that's a strange one. It's almost like the first guy and last guy to land on the moon knows something about setting up a space program. That's weird. That's what they said. And actually, later down the road, Gene Cernan and Neil passed away, but even Buzz Aldrin has said that commercial space is great now that they're up to speed. And I don't disagree. It's great. But at the time, SpaceX, dude, you got to remember the context of this, dude. They pulled Ares 1 in Orion. They said we don't need to do that because we'll move astronauts on Falcon 9 in the future. Falcon 9, this was in 2011. Falcon 9 had launched once. And that, once. SpaceX had 6 launches under their belt. 5 Falcon 1s and 1 Falcon 9. And 3 of those Falcon 1 missions failed. And even the first Falcon 9 mission had an engine explode. A Merlin 1C engine exploded on that flight on the way up, but it used engine out capability to get where it needs to go. Do you see why they were skeptical of SpaceX at the time? I mean, it makes perfect sense to me. Falcon 1 flew 5 times, yeah. First 3 failed, 4th one was successful, 5th one was a Falcon 1E that was successful, and then they pivoted to Falcon 9. They pivoted to Falcon 9, Alex, because Mike Griffin, the administrator of NASA, was overseeing the Commercial Orbital Transport Services Program and through SpaceX a Commercial Resupply 1 contract for resupplying the ISS with the Dragon capsule. And in order for SpaceX to do something like that, they needed a bigger rocket. What they were so skeptical of is that, the inference of relying on commercial space at the time was that, SpaceX can move people to the space station for cheaper. And I will not say that they don't do that. They absolutely do that. Sure. It's still probably, we talked about this yesterday, comparing the cost of the space shuttle to the costs of Falcon 9. I still think it's kind of a loaded question because cost scales with capability in space, usually, unless employed in mass. But Falcon 9 is cheaper to fly into space because it does less than the space shuttle does. And if you stack up per unit costs of space shuttle to Falcon 9, it almost scales with the capability. It actually scales with the capability completely. Long story short, to do what the space shuttle does on one flight, Falcon 9 would need to launch 3 times. 3 times, almost, three Falcon 9 launches almost equate out to the per unit cost of a stack for the space shuttle. Which is, once again, shuttle's still more expensive, no doubt. But the shuttle does more things in space than a Dragon capsule can. Just saying. Absolutely, I knew of the need for Falcon 9. I just didn't know about the 5th Falcon 1 flight. I thought the first successful flight was its last. Nope, they flew 1 more right after that. Yep. When would flights from U.S. soil have resumed if NASA had kept going with Constellation? Conservative estimate, 2016, 2017. If properly funded. If properly funded. Big if. Raptor, if we take into account, like, say, in 2009, in 2008, Constellation has perfect funding. In 2009, it has perfect funding. They don't try to cancel it in 2010, and they keep going with Orion development and and Ares 1 development. Taking into account the funding that was absolutely needed, right? I'd say 2015 or 2016, something like that. Funny, that was the original crew launch projections for the Commercial Crew Program. Commercial Crew Program came around in 2014, and they were like, everybody was like, okay, we're going to have crew operations restored by 2016, 2017, right around the time for Artemis 1. Whoops. They were slated for 2015, Lundprod, but here's the thing, dude. Not even NASA with perfect funding can predict the future. The case to be made there is during the Apollo program. They still had problems with the Saturn V. It's teething, like, ironically, like what Eric says in his article. There's teething. Every rocket has a teething problem. You shoot for 2015, it's most likely going to be 2016, 2017. Just because you can't learn everything. Can't predict the future. Never know. Best case scenario, you get it right a little bit on time, maybe a couple months after. But when does that happen in the aerospace industry? That never happens. Conservative timeline projections are a plague on the aerospace industry. In fact, it's a plague on any type of engineering. Any software engineers out there? How many times do you have an argument? How many meetings a day do you waste telling your boss that it's going to take longer than they think it's going to take? Anyone? Your boss says, oh, I think you can get that done in a month. And you say, nah, it's probably going to take 2 months if I really work hard. Oh, okay. 1 month it is then. Take how long you think it's going to take, multiply it by pi, that's how long it's actually going to take. That's my rule of thumb. Can't you just, like, do it? Yeah, exactly. Yeah, see, I'm hitting some pain points. I'm sure there's people watching going, oh, EJ's too much, shut up, too real. I don't come to you for this kind of stuff. I'm like, yeah, okay, that's right. That's fair. You're right. Anyway, tell that to the Halo 2 devs. Yeah, right. What are you talking about? KSP came out in 2018. Shh. Here, mostly because they've added extra requirements after the estimations have been made. Scope creep do be like that. Bingo. Sorry, Ertas. Work is almost done. Don't do this to me. Yeah, interesting. All right, we're going back in. Put the gas mask back on. We're going in. We have to cook, chat. Hold up. Let him cook. This is Homer Hickam, the guy that wrote Rocket Boys. I have his book on my desk. His first paragraph is spot on. By the way, SLS should be used for cargo only. Agreed. Well, not saying we shouldn't Saturn V that thing, but yeah. Oh, they're back. Oh, no. I'm sorry, guys. See, I clearly pissed somebody off. My chat's going bananas. Mods, get the fire extinguisher. Dreadswirl, I had a similar situation at work. A legal compliance issue where a regulator asked for info. When can we answer the question? Tomorrow. No way. Give me 4 months. Yep. Oh, they're still going. Chat, you guys still here? Is my chat okay? Are we dead? I'm clearing the chat, boys. Whoa. It's imploded. Sangha, you dead, man? No, man. Whoa. Dude. The chat has imploded. Unbelievable. It was Eric, wasn't it? Got my eyes on you, you motherfucker. Yep, that's broken. Yep, it's broken. So I'm just a streamer without chat. Oh god, now I'm just like television. I'm having a good time. Not. Wow, the dashboard is unusable. Locking up my dashboards. Oh god. Okay, I'm back. I'm back. I'm back. We're here.
Discovery, go and
All right, I'm back. I'm back, dudes. Am I back? We need to remove slow mode. Silavarus, thank you for the 26 months. What have you done to piss off our bot overlords? It's probably Eric. It's probably him. It's probably the people that we're talking about in this article. You notice how we started talking about the people on Twitter and this happens? Damn! Yeah, dude, my chat just completely locked up. Like, completely locked up on my dashboard. I had to clear cache over there. I'm having a good time. Not. Oh, shoot. Yeah, dude, we had to get the gas masks, man. The bots have been bad lately. That's what you get for going to Twitter. Oh, I'm going back in. We have to cook. We have to cook! Your analysis is spot on. This flag and footprints reboot is dumb, other than the baseless fear that Trump would bring Griffin and shoot down Trump's own popular moon program or disparage the success of commercial crew, which flew on his watch. That's not happening. So he basically said, you're right, but you're wrong, but you're right. Okay, sure. Question for you, sir. Is NASA and Russia the only two space entities not working towards reusable rockets? What do you mean, Rode? NASA and Russia are the only space entities. What do you mean, Rode? NASA? I mean, I guess you could make the argument that NASA is pursuing reusable rockets with the leverage of the commercial program and what Falcon 9 is doing. Like, tons of NASA payloads have launched on Falcon 9, right? Like, a crew mission that's coming up, a commercial crew mission that's coming up very soon. Russia wants to move towards doing reusable rockets, Roadrunners, but they don't really see the need to change the status quo over there. That phrase is more relevant than I thought it would be. So they have people that want to do stuff like that, but they're just keep launching Soyuz, keep launching Angara, keep launching, well, there's not many protons left, but you get the ideas. Most Chinese agencies aren't into reuse. China's national program has no interest in doing reuse. China is working on a couple of commercial startups. There are commercial startups over there that are doing reuse. Yeah. It's not the Chinese National Space Agency, but then again, with how they have their system of government, nothing is owned by people. So their commercial And Russia does the same thing. They are commercial companies where the biggest shareholder is the state. Yeah. An equivalent to what we would have over here like that is Amtrak. Yeah. Yeah, Amtrak. That's our passenger rail service for the Europeans who are about to start laughing hysterically at us. Yeah. I've seen it, Adam. Yeah, it looks like a bird strike from what I can tell. There's a video of a 747 with the engine catching on fire out of Miami. Yeah, it's an Atlas airplane. It looks like a bird strike if I had to guess. Please, no, not Amtrak. There's an attempt, bro. There was an attempt. We don't toss people out of windows when Amtrak is mismanaged. Yeah, it's out the door. No ticket. A disgraceful attempt. There was an attempt, Dukas. There was an attempt. Hey, they're trying. What's wrong with Amtrak? I understood the Silent Bob reference. Amtrak is... I mean, Dredd, there's nothing. To be honest with you, there's nothing really wrong with Amtrak. They do a good job. It's the U.S.'s passenger rail service at a federal level. The thing is, okay, let me... If there is a problem here, I'll give you an example. Like, if I could point to one thing and say, this is why Amtrak is the way that it is. I live in Boston. You guys know that. I don't make it a secret. All right? Like, I'm frickin' from up here. I almost swore there. Sorry, I'm reverting back to my native tongue there for a second, guy. All right? And that usually involves cursing up a damn storm. All right? So, if I wanted to get on a plane and fly to New York City, okay, let's look at all the avenues of transportation here. Actually, let's start there. Look at all the avenues of transportation. I could take Amtrak, I could take the train, I could take my car, or I could fly. You could boat down there too, but I'm not sure why you would do that. Let's just take boats and put it in the happy gold star area on the refrigerator over there. So we have car, plane, and train. The car, getting down there with the car probably is the cheapest way. That's also the longest. I can make New York via car about four hours. If there's traffic, 5 hours. I mean, if there's no traffic, it could be as little as 3. Okay? Probably the cheapest way. Gas is pretty inexpensive, right? But that takes a little while. I could fly on an airplane. An airplane would get there in 45 minutes. It's the fastest way to go. And let's just make up some prices here. Say, like, with a car, it'll cost me about $200 in gasoline, right? I have a car with a V8 in it. What do you want? Costs about $200 in gasoline. The plane ticket is $300, and the plane gets you there in 45 minutes. Okay. The train costs the same as the plane and gets you there as slow as the car. Do you see what I'm talking about here? The reason why the train, high-speed rail, which theoretically has a top speed of 170 miles an hour, that's, what is 170 in kilometers an hour? Like 220, something like that. 220 kph. That's not the fastest. I know that there are trains overseas that go way faster than that. That's our high-speed rail. The reason why it takes so damn long on the freaking train, despite it takes as long as a car, is because Amtrak operates on private rail lines that are either owned at the state level for state transportation, or they're operating on freight lines that A, were made 150 years ago and they're not built for high-speed rail, so the train has to go slow, or B, Amtrak doesn't have the preference for right away. Basically, if there's a freight train there, they have to yield to it. When I did take high-speed rail down to New York one time for an Intrepid stream with DOS, our high-speed rail got stuck in traffic behind a passenger train. because it all uses the same rails. That's the problem with Amtrak. $300. I said 220. Yeah, I said 2. Sorry, I'm doing my math wrong. Yeah, 180 miles an hour is about 300 kph, not 200. And the prices end up being equivalent as an airplane. So what's the incentive to go on the train? It takes as long as the car, and it's expensive as the quickest way, the airplane. That's the problem with Amtrak. So you're not paying for convenience, you're not paying for time. It's the worst of the other two. That's the problem. If our high-speed rail between Boston and New York was able to go unimpeded, it could be potentially as fast as the airplane and as cheap as the car. But we won't do that. Part of the reason why we don't do that is because there's no space. There's no space to put high-speed rail between Boston and New York. There's no space for it. There's too many people. How are you going to build that? Now, I could tend to say with enough political will, we're capable of putting somebody on the surface of the moon. I don't see that problem as insurmountable, but what are you going to do? What is most used in the U.S.? Cars, by a long shot, man. The only possible scenario is that if you don't have a driver's license, you're afraid to fly. Yep. Does that apply nationwide or just to that route? That's the only route where there's high-speed rail dread swirl. And it basically, the using other people's tracks, nationwide. Same problem here. Montreal to Toronto is 6 hours by car. Train is 5 hours and costs almost as much as going by car. Only upside is not having to drive. See what I mean? Can't even finish your own roads. Yeah, we don't. Yeah, in the Northeast, we don't even do the damn car part right. That's a good point. Oh boy. But yeah, I mean, if we want to go play cities and mess with that stuff, we can. But yeah, let's. I want to keep going with this. We might. Maybe we'll do that later. Who knows? I would have to drive 6 hours just to get to a station to an Amtrak station. Yep. All right. Anyway. Let's see. This is Lori Garver. I sort of respect the consistency of Mike's principles. The reality is that commercial cargo was created by OMB, the Office of Mission, basically NASA's budgeting department, based on previous alternative access program, and SpaceX had to file a lawsuit to get him to open up the competition. I'm sticking with the George Costanza principle of do the opposite. But that is a little disingenuous, don't you think? To imply that a program was implemented without the say of the administrator by the Office of Mission Budgeting, or OMB, the Office of Mission Budgeting, based off of an alternative access program without consent from the NASA administrator who oversees this entire thing, is a little bit, that's kind of a stretch there, don't you think? The Office of Mission Budgeting really only goes forward with a program once it has administrative approval. SpaceX had to file a lawsuit to get him to open the competition. How does that... Huh. I don't understand. How does that even, like, what? Oh, dude, look at the reply. Yeah, see, okay, I'm not crazy here. His consistency in the face of changing evidence is one extreme. Your attempts to rewrite history and take credit for commercial crew are the other. Yeah, that's what I'm saying. Yeah, but like, what? What are you talking about? These are these people real? Like, you. The administrator has to approve all programs. That's why he's the administrator. There's no way that Mike Griffin was like, don't do commercial crew. Don't do that. And the Office of Mission Budgeting was like, we're not going to listen to you, Mr. Mike Griffin. We're going to do it anyway. That is not how this works at all. Like, what do you think? This is like some kind of high school play or something? Like, I'm confused. What are you talking about? What? Why are some of the MC screens down? Downtime and maintenance. You're a loose cannon, OMB. You're off the case. What are you talking about? This is great. Dude, oh man. This is awesome. I love it. I love the gymnastics going on here. This is fantastic. I'm trying to comb through. Is there any other gems in here? Put the gas mask back on. This exactly describes constellation. Yeah, why do people think this? I don't understand. Slide wire baskets are being installed at 39B. Pics are posted in the NASA image gallery. Cool. Cool, man. There's another tweet here. Griffin has never let go of the fact that his child was canceled and is angry at everything else. I'm pretty sure he's angry because his program, even with all of its shortcomings, planned for a lunar return basically right now. And actually it would have been, even like in the worst case budgeting scenarios, probably would have been 2 years ago. I'm pretty sure he's pissed because we've spent like 6 times the amount of money that his program was going to cost and have gotten nothing in return. I'm pretty sure that's why he's mad. I'm pretty sure that constitutes being angry about that. Anyway, what does the rest of this say? Even though Constellation's design concepts and funding concepts are the same as SLS Orion. Whoa.
Discovery, go at throttle up.
Oh, wow. Whoa. These people don't know what they're saying. That's wow. Okay. Hey, Twidget, 37 months. Thank you. Nice shirt, by the way. Thank you.
Discovery, go at throttle up.
Yeah, the rest of this is just a bunch of people weighing in that don't I don't really think understand what's going on here. Oh, there's one. This article makes no sense. Nice. Nice. When are you doing planes again? I'm getting to it, Shatter. I'm getting to it. I've been having to rebuild things, dude. I had some kind of nasty illness over the last couple of weeks, man, and it completely screwed up any semblance of timeline that I had for getting anything done in an expedient manner. Yeah. These people are so confidently wrong with no desire to find out if they're right or not. Yeah, Raj, it's pretty bad, man. And the bad part is that that's the whole premise of the article. I would love to watch a 2 or 3 hour video of Griffin roasting these comments and explaining exactly how they're wrong. I'd pay to see that, Aqualex, yeah. We want Jim Bridenstine back. Nice. Nice. My guy. Logan. All right. Just as I right now start feeling upper sore throat, I need to get sick now if that's the case, because girlfriend and I are supposed to head to Colorado on the 30th. Shatter, whatever I had was disgusting. It was a weird sickness. No symptoms. No symptoms except for a raspy throat every once in a while and achy muscles, but extreme fatigue, like extreme fatigue. Like you get up in the morning, it's like Shatter, I forget if you drink or not. You ever get like a little hungover, you wake up the next day and you're just like, nope, want to go back to bed. That every day for better part of like, I don't know, 2 to 3 weeks. Not fun. Hopefully you don't get that. I was down with the sickness. Yep. Oh, wow. Oh, wow. You're lucky you never get hungover. You haven't drank enough. River Turtle gifted a sub to Unity. I'm disturbed by that. Yep, me too. What did the 5 fingers say to the face? Sorry, I'm just reading about this. It's just all the same stuff. Well, in an alternative timeline, NASA could have kept the shuttles flying. See this guy? Chaotic neutral. Chaotic neutral. Slap! To be honest, I kind of like this for Artemis 3. It's extremely simple, fast, and can't go wrong. Hey, right. All right, my guy. All right. There's another guy here. I can't imagine advocating cost plus over commercial in 2024. Oh boy. That's arguing contract structure over contract structure over operations. That's like saying I can't imagine advocating for the telephone because sailboat. What? I'm somewhere between impressed and disgusted by your David Draymond impression. Huh? What? Oh, sailboat. And I don't care how complex or expensive a program is anymore. To be honest, if we had committed to any of them, we'd have results by now. Aqualex, that's been my argument for the longest time, bro. That's been my argument. All these people, all this cope and all this steam blowing here that's going on, this blowharding that's going on by Berger and all these other people, Lori Garver, whomever, right? Completely ignore the fact that if we just kept going with Constellation, we'd be going to the moon now instead of at the end of the decade. Just saying. Just saying, bro. Like, just saying. I'm just saying. Like, you know, like, the thing is that there were stipulations for commercial crew to happen in that at the same time, and everybody here that doesn't like Mike Griffin seems to not understand the fact that NASA's programs need to be detached from a commercial market. It's like they just miss that part every time, dude. Every time. That's why I share these articles. I think that's funny. The 30 billion. Yeah, I know. The 30 billion. You heard in the testimony. You heard the testimony from that meeting that we went over the other day that we've spent $90 billion on SLS since it started. That's awesome. Oh, that's great. That makes me laugh. Yeah, exactly, Hellfish. You cannot, there's no one here, no one can tell me with a straight face that if we put those $90 billion into the Constellation program, that we wouldn't be further in space right now. That is very funny to me. He started dancing with the Hercules, 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 Hercules. And that's taking into account all the faults that Constellation potentially could have had, like the requirement for R68s on Ares 5. You know, like converting the R68 to a regenerative cycle because of heat concerns. The nozzles on the R68s, they were worried about it with Ares 5 because they could melt each other from the outside out. From the outside in, right? The nozzle is made out of heat shield, but having a lot of them close to each other they would melt each other. That's a problem that the Saturn V had. The F1 engines gave off so much heat that they could melt each other at close range. That's why they wrapped them with asbestos. Fun fact. And you know what the funny thing is? Yeah, we saved 30 billion so we could spend 90 million. You know what the funniest thing about this is completely? The complete funniest thing here is that I know what they would say. They would say, well, we didn't want SLS in the first place. We wanted to move all to commercial. We wanted to just pull the plug on the entirety of NASA. To advocate for just commercial from now on. That's what they'd say, right? Well, you know, like, I say it's funny because we've spent 3 times as much and achieved nothing, right? And they would say that, well, we didn't want SLS. Congress wanted SLS. Yeah, Congress wanted SLS because you basically said, no, we're going to take thousands of jobs out of your congressional districts and move them, and not move them, and replace them. We're going to take thousands of jobs out of your congressional districts and replace them with hundreds of jobs somewhere else. So, who thought that was a good idea? Yeah, oh yeah, they'll go for that. I think that's extraordinarily arrogant of our political process, no matter how bureaucratic it may be. That's extraordinarily arrogant about how stuff is done. I'm just saying. I'm just saying. Like, just saying. NASA being treated purely as high-tech pork. Well, Kev, I'm not going to sit here and pretend like it's not a pork thing. Sure, absolutely. It's a jobs program. Of course it is. It's a job program that increases our scientific understanding of things. If we let the system work. If we let it work for us. In order to do that, 2 things need to happen. You need to get enough people on board to vote for something like this and vote for it and fund it correctly, right? And then the second one is that it needs to have results. It needs to have results. That's the checks and balance in this. So the second part is NASA needs to hold their contractors to this. We have unrealistic planning, unrealistic deadlines. SLS was supposed to fly in 2017. 2022. 5 years late. And this is what I mean. At face value, if we were, like this article, we'd say, oh, they're not being able to deliver. They're not delivering correctly. They're not delivering. Oh, man, they suck. Which is basically what everyone says. And it's funny because he defended that process in that article that we just read. But, hear me out. Everybody's going to dump on the contractors for SLS for it being late when you never gave it the funding that it needed to be on time. That's the truth. Yeah, RJ, there you go. Hellfish, I'll say it once, I'll say it again. The money's never been the problem. It's direction and accountability that have been the problem. And it's been the problem since we got rid of Constellation. No direction, no accountability. And if I recall, that's pretty much exactly what Mike Griffin said. Just saying. Man, he stirred the hive, didn't he? It's kind of funny. Anyway, that's pretty good, man. I like that. SLS is late, but so is Crew Dragon, Starliner, Vulcan, Starship. Yeah, you know why? Because arguably, Raja, I would say that Crew Dragon, Starliner, they're all late because Crew Dragon and Starliner, they're late because of firm fixed price contracts. That's why they're late. Now, okay, so why is that? Why is that the case? Why do I think that? Well, okay, hear me out here for a second, all right? This is going to be a little bit of an extreme example, but an example nonetheless. I want to buy a car. I go to the car dealership. I buy a car for 40 grand. Yeah, I wish, right? Buy a car for 40 grand, all right? And maybe I don't like that car, I go return it. I don't like this car. I buy it, and then I'm like, okay, I sell it back to the dealership. I don't know, maybe I lose some money, right? Let's just say that the dealership takes it back for the exact price, which depreciation, probably not a thing, right? But say it does. Okay, so I didn't like that car. I got my 40 million back, right? Now I try to build my own car. Is that going to cost as much as just buying the damn thing? No. Well, if anything, that's going to cost a lot of time. The reason why is because developing something takes more time, right, than just buying it at a fixed price. Using fixed price contracts for development is a very bad idea. By definition, you're underfunding the program. Which is funny because SLS says it's cost plus, but they flatlined the freaking budget allocation for it over the last 10 years. There were points during SLS development over the last 10 years where it needed 6 times its budget. It needed 6 times its budget. And there are times like now and in the beginning of the program where it did not need that. That's the reason why the price tag is seemingly so expensive. They flatlined its development budget. Development works in cycles, right? Think about like video games, for instance. How many people do you need to make a video game, like a good video game? You need a dev team of 20 to 30 people, right? Or let's say 40 to 50 people to make a decent AA game. When that game comes out, do you necessarily need all the developers? Say you no patches for the game, or even you just had a bug team just doing patches for said game. Do you still need 30 to 50 people to do that? No. Operations are way different than development. Funding Dragon and Starliner in a fixed price program is disastrous, despite SpaceX's crazy, ridiculous will to will something into space, quite literally, or quite actually, right? Yeah, horrible. And that right there is what Mike Griffin is talking about. He doesn't hate commercial crew. He doesn't hate the commercial crew program. His whole thing, his shtick for the last 30 freaking years is how we procure this stuff and how we go about funding it and how we go about coming up with the contracts for it. Hey, Talby, what's up in the world of space and science? Nothing but a lot of laughs. It takes one person to make an awesome game. Yes, sure, absolutely. Like a good indie game, yeah, absolutely. Is Starship semi-cost plus? Starship is not cost plus at all, Tim asked. HLS is firm fixed price, if you really want to know. And that's really funny to me because I don't think Starship as a lander is a bad idea. I think Jim was nuts, and I think Jim did a really smart thing, basically forging our lunar program into writing and forcing Congress to fund a second lander with his decision. I think SpaceX is HLS is the lander that the lander that we need. I think it's the lander that we need in 10 years. And maybe in 10 years when it flies operational, it should replace everything. Because, dude, at the end of the day, you can't dump on an architecture that's going to be able to put 100 tons of something onto the lunar surface. That's ridiculous. But for what NASA's trying to do right now, it's a little bit overkill, right? It's a little bit overkill, but fixed price on the HLS for 2, possibly 3 landings. Uncrewed, crewed, and another crewed. So actually it's 3. There could be 4 if I'm remembering the contract structure. I'd have to go look. Firm fixed price for a development program. And that's your lander for the first return to the moon. Oops. Oops. And then everybody uses Starship as an excuse for the bottleneck for the Artemis program, saying that, oh, Starship is going to be the reason why it's going to be delayed. Starship is the reason why it's delayed. Starship is the reason why they delayed Artemis 3. Starship, it's not going to be the reason. Your contract structuring is probably going to contribute to that, if anything. But once again, despite NASA's best efforts, SpaceX will brute force will something into space. And that's an argument that I never really understood from the people that think like what's in this article. I never really understood that. They have an incessant need to insist that everything that NASA does be handed over to commercial. And while I don't think necessarily that that's a bad idea, but what are our examples of that being a cost-saving measure to NASA? SpaceX? Okay, anything else? Starliner? I don't think so. The whole idea and the entire premise is that commercial can get it done faster for cheaper. It still took SpaceX 10 years to build a capsule to go from having a capsule on the books to a crewed flight. So about that whole faster thing. Cheaper with SpaceX, sure. Is it cheaper with Starliner? And I'm not dumping on Starliner either. I think it's a great design. I think when you contract a company as your safe choice for developing a spacecraft when they have no experience developing spacecrafts is a really, really bad idea. Especially on a firm fixed price. Oh, that's strange. Yeah, you heard me right. Boeing has no experience building spacecrafts aside from Starliner. Whoever at NASA thought that would be a safe solution, that would be a safe bet, Boeing would be your safe bet. For a company that has zero experience building spacecraft, operating spacecraft, they got plenty of experience. But the spacecraft that Boeing operates, that they had operated previously, the Space Shuttle and the Apollo CSM, were engineered by companies that Boeing absorbed later. They have no experience developing a spacecraft. Somebody looked at that and said that's the safe answer. Heck, SpaceX had more experience developing capsules than Boeing when the Commercial Crew contract was awarded in 2014. You know why? They had been operating the Dragon capsule for the better part of 4 or 5 years. That's weird. Strange. See what I'm talking about? When has commercial actually been faster and cheaper? This isn't a slight against commercial. I still think in certain applications it's amazing, and I think eventually it'll be better than anything that NASA has to offer. Absolutely. Arguably Falcon 9 is. Right? But that took time. So cheaper and faster. When's that happening? We either get one or the other. And SpaceX is your only prevalent example of this actually working. Which is, once again, why I don't think Starship is going to be late. I think Starship will be on time. You know, believe it or not, maybe a couple of years at best. But a couple of years is great for SpaceX. In Elon's own words, SpaceX takes the impossible and makes it late. At least the door on the Starliner didn't fall off. Damn, son. Damn. Oof, Creeper, that sucks. If you're not going to wear your NASA hat, you should at least have NASA emblazoned on your forehead. I'm not doing that. Get out of here. What's going on, buddy? How are you? Yeah, Talby, it's interesting, right? So how long has SpaceX existed? Since 2002. Faster, cheaper, better. Yep. One could say Boeing has experience with doors that... Never gonna miss an opportunity to slide on to completely shart on Boeing, are we? I mean, that could work there, right? Yeah, sure, maybe. Interesting, though, huh? It's kind of just concerning because there's a lot of, there's a lot of absolutes being spoken here about stuff that's not so absolute. That's weird. I just don't really appreciate this type of behavior in spaceflight. But, what are you gonna do? What are you gonna do? What are you gonna do? What can you do? Anyway. All right, what else do we got? There's more stuff here. There's a Phil Sloss article about SLS. That's good. That's nice. Got that. I got the teleconference. We covered the slim stuff. Somebody get EJ a Wolverine costume. We were talking about infrastructure. Now I want to play cities. Damn you. Damn you, chat. Why? Was there any update how the first night in space went for Axiom? No, nothing. I'd say if they really want to hold to their A1, A2, A3 milestones, they should do versions of these missions. Like A1, Artemis 1 needs to be Artemis 1.1 and actually fly with the life support. Can we talk about the Icarus kick stage? Impulse, you mean, Alex? Impulse's kick stage is cool. Storable methane. Can you imagine 20 years with SpaceX? Some people have been working there for that long. Man, you really never will find out what you want to do with KSP. We don't have to play KSP ever again. If you really want. If you're gonna force my hand like that, Mr. The US doesn't have human rights. Thanks for that one. The heck should I listen to what you have to say, you bum? Yeah, don't think I didn't forget about that. I don't forget about that stuff. There was something here about the EUS that I wanted to... yeah, here we go. Yeah, it is that Phil Sloss article from NSF. You can take what I say however you like. That's it? That's your response? That's it? Last name isn't Burger by any chance, is it? The EUS stage moving into the qual phase. Very nice. Very nice. I want to look at the pictures. Yes. Yes. Who you have a problem with? Show me the guy. I don't have a problem with nobody. We good. Golf cart. Play the video? Oh. I think that's a narrated NSF video.
You've heard it said NASA's Space Launch System.
Oh, hold on. I don't have any.
Well, NASA already has hardware built for the rockets and capsules for the next 4 missions. A large part of it is sitting just outside New Orleans at NASA's Michoud Assembly Facility, and only NSF got a tour inside. Sponsored by Novatech.
Word. Nice.
The entire floor at Michoud, sometimes referred to by the workers as MAF, is full of parts for the upcoming crewed lunar flyby Artemis II mission, the moon landing mission Artemis III, and even some parts for missions beyond that.
From where we're sitting right now, it's exciting to look around and point at development hardware, structural test article hardware, and flight hardware.
What you're seeing right now is the entire length of the core stage for Artemis II, with most of it already covered with the special orange insulating foam. Now it's down to something called FIFT, the Final Integrated Functional Test, basically making sure everything works.
We've done all of the individual functional tests on the 5 elements, and now is when we really we hook them all up together and really test out all of the functionality of the rocket.
That's Amanda Gertie-Jansen, core stage assembly, integration, and test leader for Boeing, NASA's prime contractor for SLS stages. Following testing, the giant core will have to be prepared to be loaded onto the Pegasus barge for shipping to the Kennedy Space Center.
So there's really, that's kind of final fairing install, shipping covers, antenna covers, kind of all of the pieces that can't get exposed, and all of the pieces that will be hooked up when we go stack the full rocket. So we put covers on a lot of that, systems tunnel covers, put those on, and then once we're in shipping configuration, we do some rotations there.
What are you looking at for finishing the testing and kind of being ready to go, ready to roll out to the barge?
So we're working to a plan right now that we to complete by the end of the year.
But it's not just the core for the first lunar flyby in 50 years. Orion spacecraft prime contractor Lockheed Martin is also getting final pieces ready for launch delivery.
Hey, Ambrosch.
Fairings for the Orion service module are there, along with something very important for a crew flight: seats.
Cool.
We're standing in front of a couple of the crew seats for Orion. And so I was asking you before we went on here which one this is for, and you said yes. So could you talk about what we're looking at here? And
so they are reusable. The crew seats that we're looking at here are Artemis 2 and Artemis 3 crew seats, and likely reusability beyond that. You see 2 of the crew seats here. There's another crew seat that's not shown here, and a pilot seat also that's part of our fabrication, part of our build.
Okay. Are these, is there anything different about, like, are there mission specialist seats, commander seat, pilot seat, or are they interchangeable?
They're interchangeable. The only differentiation is the pilot seat. The pilot seat has some additional controls, and what you don't see here are the arm mounts. So there's a set of arm mounts that are going to go onto these. Before we deliver these, there's some additional functional testing that we're going to do on the armrest before we set them out.
And these are obviously, you can see they're adjustable. Yes. to the different sizes of crew members.
Yes, they're adjustable for a large individual and a small individual. I'll leave it at that.
Okay. So in terms of the types of testing that you're going to do on these before they're ready to go to Kennedy, what do you need to do?
It's just functional testing from here on out. The design is certified for flight, so it's just functional testing associated with the actual flight units themselves.
Of course, NASA is already eyeing the first lunar landing since Apollo 17 in December of 1972. Artemis III will land the first woman and the first person of color on the lunar surface ever. In case there's any concern about delays, well, we could see parts of the core stage for that mission.
So core stage 3, we're working through integration on the forward skirt and the inner tank. We're processing the LH2 tank, and then we're working on our welding on our LOX tank.
Engineers predict that could arrive at the Cape as soon as 2024. They're also working in tandem with teams at KSC to prepare the Artemis III engine section.
Nice.
And once again, the focus is also on getting Orion ready for its historic crew of 4 on that mission. We were able to see some of those Orion service module fairings, which will keep the capsule protected until the rocket reaches space, when it will be jettisoned.
Cool. Look at the jig,
along with
man.
an adapter
That's
cone
killer.
to help it attach to the main rocket.
This thing.
Another
freaking
key reason so
sweet.
much of this hardware is at Michoud is because of their unique technology, just like today's video sponsor.
And that sponsor is Novatech, who has been...
Sawyer, that's awesome.
test their inflatable heat shield concept known as HIAD. But it's not just the space industry who trusts Novatech. In case you didn't know, NSF is full of Formula One fans, and Novatech is playing its part in helping to make the races even safer. These load cells were used in the development of the Halo safety devices for F1 cars. For more information, check them out on their website at novatechloadcells.co.uk, or
they got Novatech to sponsor a YouTube video? Huh. That's some good footage, Zay. I can see the links, guys, so don't worry about it, unless you get timed out.
Or check out the link in the description. And thanks again to Novatech for sponsoring this video. Now, back to Philip at Michoud.
That's
Following
cool,
that
man.
mission, SLS will change into its next variant, Block 1B, which is already under construction at Michoud. It turns out a lot of the delays is just waiting for a turn in the welding tools.
It's pretty close to ready. We've already got the majority of the work complete, so just waiting for the opportunity to get it down.
That vehicle will be able to lift more mass, will be slightly taller, and include an exploration upper stage and a larger fairing, which is already being welded.
That's what
These
they should
are
have made
friction
first.
stir welding samples, and can you talk about what we're looking at with this blade and that
dude,
blade?
sick.
Sure. So this is a self-reacting, it's a test sample, as you indicated. It's a self-reacting friction weld. This is the type of weld that we...
Dude. How's that for rolling dimes? How's that for rolling dimes? That's aluminum too. Bro, it's perfect. Dude, yo, that's awesome. Dude, it is, dude, that is eye candy. Holy crap. Wow, I don't hate that. You know what the crazy part is? Look at the thickness of the sheets that it welded together. That is not thin aluminum either. Wow. Oh, that's beautiful. This was worth the price of admission, man. How deep does that weld go? Full pen with a stir weld, Jim. Yeah, full penetration. Stir welds don't actually have a feed wire or bead if you know anything about welding. It's a head that spins, and the friction creates heat that actually heats up the aluminum, and they actually stir it together. Like, think about like a mixing bowl. Yeah, like that. Like if you're trying to make a cake, you put all the ingredients, you mix it up. Same idea. But it uses the friction of the stirring head to actually heat up the aluminum and meld it together. The cool thing about that is because you're not adding a welding bead, right? And it's also very low heat, so you don't warp anything. There's no temperature. You don't see any like heat scalding here, so you can keep the heat minimum. And because you're not adding any welding bead, the molecular structure of the aluminum post weld is exactly the same. This, for all intents and purposes, is one piece of aluminum now. If you look at it at a molecular level. Now, when you weld something, because you're using wire, right, and you're zapping two pieces of steel together, because the circumstances for the manufacturing process of those two steel pieces that you're trying to weld together are different from arc welding, right? Like with a MIG welder. I know that arc welding isn't MIG welding. I get it. The electrical arc that gets put through wire to make the welding bead with like a traditional MIG welder, because it was manufactured in different ways, the plates, right? Believe it or not, at a molecular level, the weld is actually stronger because it was made differently. That metal, the way that metal was made was different than the way the plates were made. So if you have like a regular tank that's welded together, the tank will most likely fail not at the weld, but the connection between the tank and the weld, because you have differential molecular structure there. With a stir weld, that's not the case. It's completely uniform. Completely the same. That like I said, even though that's been welded together, that might as well be one sheet of aluminum at a molecular level. That's the important part to understand. That's really useful for making, rocket fuel tanks. Why? Why is it useful for rocket fuel tanks? Well, one, you can create a tank that's way stronger. And you can also create a tank that's way lighter. The first rocket to ever incorporate stir welding into it was the space shuttle with the external tanks. They probably saved a couple 100 pounds of welding bead doing a stir welding operation on the tanks instead of actually like TIG welding them together. Yeah, probably 200 to 300 pounds of weld. Yeah, they redesigned the external tank 2 times through the shuttle program. There's the Block 1 tank, which basically flew from 1981 to like 1986, and then the LWT, which is the Block 2, and then the SWLT, which is the Block 3 external tank. One of those, so LWT is lightweight tank, SWLT is super lightweight tank. They used friction stir welding in the late 80s to make the tank a lot lighter so the shuttle could take an extra 100, 200, 300 pounds into space. Welding for 17 years. I never knew that. One of the many reasons I love watching your streams. Yeah, Talby, the bead, right? Everybody says, oh, the weld is stronger than the steel. Yeah, that's right. The failure point is actually at the weld, though, because it's the actual connection at a molecular level between the actual weld and the plate. But don't get me wrong, for us mere mortals, not NASA, right? For us mere mortals, a MIG weld or a TIG weld is good enough. We're not making rockets here. I mean, we could. What's the tensile strength of one of those welds? It depends on thickness, and it depends on the thickness, and actually it's just the material. I mean, I was about to say it depends on the thickness, it depends on what type of tank, depends on what you're putting in the tank. I mean, yes, that has a lot to do with it. I don't know what the tensile strength is, but it's straight up the tensile strength of whatever aluminum they're using. Thickness is irrelevant.
Do on the majority or all of the PV welds for the crew.
I saw it, Josh. I saw the plates aren't welded. They're not. One is more than the other, and I was hoping nobody saw it. It's the same as the sheets, dude. Tensile strength is I think they're using. It's either an aluminum lithium alloy, or they're using 7000 series, that might be the same thing. I don't know. I'm not brushed up on my metals. But that is nice brushed metal, though.
All the pressure vessel welds, right?
Dude,
what's the difference between?
Dude, look at it. It's freaking perfect.
This is obviously a sort of a clean set of 2 plates together. What's the difference between this one and? And the one on the right that's got these things. They almost look like tools sticking out of them.
Sure.
What's this one?
So again, a test panel. These are plug welds.
Okay.
So as we talked before, with a self-reacting friction weld, there is a start and a stop location, and those start and stop locations are cleaned up, and then they're closed out with plug welds.
Okay. Does it leave it? But it doesn't leave it doesn't leave these elements in them.
No. There's an element of this piece that is spun in the tool there, and when it's inserted at a high speed load into the hole, it forms a friction weld, a plug friction weld, and then this the stem, and there's a kind of a nut on the other side that are machined off and cleaned up to make a.
Talbot, you seeing that? A stir welded plug weld. What the hell you plug welding? Plug stir welding. Today I learned. I didn't know that could be a thing. I didn't know that. I didn't know you could do that. I'm sorry, officer. I didn't know you couldn't do that. You like that, chat? That's good, isn't it? Because I did know you couldn't do that. No, seriously, I didn't know that.
A nice, smooth finish to the weld.
Right, and so you have this articulating tool that it sits on that moves around to the different weld positions it needs to go to?
Correct.
That's
and for
wild.
the crew capsules, they're ready
Balls.
to apply the special heat shield blocks known as AVCoat.
And so then this final piece, this is this is just a
AVCode
sample for demonstration purposes of AVCode, which is the base heat shield material?
Correct. So this is AVCode. This is a sample of an AVCode billet, as we call it. It's a curved sample. We manufacture both curved and straight billets here in a different part of the factory. They are sent to Kennedy Space Center for final machining and installation onto the heat shield. They form the outer mold line of the heat shield. It's approximately 170 blocks that we manufacture. It's has some weight to it. As it gets machined down into thinner pieces that are fit to the heat shield. So the final thickness and weight are less than what you see here.
We also saw parts of Core Stage 4 ready to be assembled, including barrels and domes for the engine section, inner tank, and propellant tanks. Also in the welder, the pressure vessel for the 5th Orion crew capsule for Artemis.
So this
5th, you say?
This is a cone panel weld tool. So we'll, when we get the cone panels here for Artemis 5, we'll place them on the tool. There are 3 longitudinal welds that will complete to complete the entire cone for Artemis 5.
Okay, and so they're the 3. What are the 3 panels, the 3 cone panels that they come here?
So for the uninitiated here, this is a jig. It's a welding jig. Note that it kind of looks like a capsule. What they do is there's a holder down here. See these pieces right here? These guys hold the panels in place, and they hold the panels in the shape of the capsule. All right? So he said there's 3 longitudinal welds, so that means they have 3 plates. So basically what they do is they manufacture the same plate 3 times. Actually, well, 2 of the plates are the same, right? Well, the same. One of the plates has the windows on it and stuff, so they can see, so astronauts can see out the capsule. But so the plates are kind of similar, but some of them are different. Like the one with the windows is different. The one with the door is different, but it's the same exact size. And then I believe those are billet. They billet machine those plates, and then they put them together. They put 3 of them in 3 times symmetry together, and then they zap them on the jig with that tool over there. That's a stir welder. That's a robotic stir welder. That thing is basically gonna rotate it, rotate it again. It's gonna make that noise too. What? Have you ever heard a stir welder? Hey, we read that article before. If I say it makes that noise, it makes that noise because that's what I'm reporting. Okay.
There's a hatch section, there's a section that has the windows incorporated, and there's a more generic section that closes.
Hey, that's what I just said.
The team at Machine wants everyone to know they're working hard on America's return.
What do you think about relativity? I think relativity's awesome, man.
Space exploration.
We're to the point now where you're like a pre-flight checklist. Yes, I got the tooling. Yes, facilities are there. Yep, I've got all my engineering release. I've got hardware coming in. I got work instructions being released.
Yeah,
right?
exactly.
So it's in that right before execution phase of trying to make sure all this stuff is in place to go, we're ready, right?
Thanks again to Novatech for sponsoring this video. I'm Philip Sloss for NSF. Thanks for watching.
Just as long as they don't have door blank offs on the other plates. The Orion is a Lockheed design thing. Thank you very much. Okay, Lockheed design. No, there's no door. They won't have problems with their door plugs. Am I right? That's an awesome vid. Guys, go like and subscribe for NASA Spaceflight. I do consulting work for them, and I commentate. I don't really consult. I crap post in their freaking Discord. But I do commentary for them on their streams as well. Make sure you go over there and give them a follow. The content that NSF is driving out lately is very nice. Very rich. Very rich. Tasty, building flavors. Just a little bit of space flight facts. Just a little bit of, little bit of nerdiness, and a little bit of a sponsorship in the video. But it's funny because instead of the sponsorship being, for a VPN or something, the sponsorship is from a company that makes aerospace components. Tasty, rich, beautiful. The vanilla cream. perfect 10. It's true. What? Why are you booing me? I'm right. That's good. Perfect. All right. So yeah, go over there and subscribe on their YouTube, dudes. Trust me, you won't be disappointed. It's great content. And you know, best case scenario, you know, you hate me and you like their stuff, and you don't want to hear me. You don't want to hear me talking about putting my crappy commentary over it. So yeah, go over there. It's a good time. Trust me. That was very Silence of the Lamb-ish. I'm very concerned now. I ate his liver with a fine Chianti. What? What? What's going on, man? I don't know if I'm getting done. I don't know what you're talking about, man. Hello, Clarice. One JEJ will show up on the stream with the mask. Don't give him any ideas. All right. Oh man, that's pretty funny, man. It's pretty funny. Anyway, what do we want to do next? Same thing we try to do every night, Pinky. Try to take over the world. Cities? Dude, we were talking about trains and stuff, and I got the hankering. That's what, you know.